Good morning. Hope everybody had a great evening. Let's go ahead and have you check the green check. Let me know you can hear me okay. Audio's working well. Awesome. All right. So a couple things just to kind of chat about before we really get started for the day. It's brought to my attention a couple things. So on the credit card fraud project, I guess there was an error. I apologize. Anna, was it you that brought this one up to me, or was it somebody else? I'm trying to remember who brought it up yesterday.
Yeah, it was me. But
okay.
I did realize after you mentioned the program or the project solutions that I didn't run that code, so it might work. It was different than like
gotcha.
program work, but there was something wrong with the code that was already written in the program like template that we should fill out. So it was just, I wanted to let people know that it wasn't them.
Got it. Okay. Oh, and actually, it looks like Desiree had some feedback on that too. It looks like .label wasn't supposed to be there, so that's maybe the main difference there. But yeah, if somebody as you run into problems like that, if little things come up, it's definitely great to share that with each other. You know, obviously, the first person that counters it helps everybody behind them. So, anytime you can bring stuff like that up, it'd be very helpful. Little nuances like that do come into play. Sometimes bugs get introduced. The problem with labs, they don't put quite the energy that they would into production work, right? So sometimes people are fixing one bug and causing another, right? And we've all seen that happen. So, but yeah, the solutions are definitely helpful along the way as well. But sometimes the solutions themselves have bugs in them too, right? So that's where the catch-22 with that. So as everybody kind of just works through this stuff, if you find anything, you can kind of let us all know. And then also that helps me report it back to Amazon too, if there's new bugs or whatever that you might encounter. There was another one too that I had a very interesting conversation yesterday. So the flight delays project is kind of an interesting one. The data set that's being used for that one is a public transportation flight data. Talks about delays and whatnot. So you can choose actually from the site that they reference that it comes from. It's all transportation data. So I mean, you could do like buses and all kinds of things, but they get flight data. And interestingly enough, they actually have you omit weather delay from the analysis, even though that's kind of the objective is to predict whether or not a flight is delayed by weather. It's kind of weird. The rationale, I think, is that they say that you don't know if it's coming from the origin or the destination, and so it's kind of weird. I think that project ultimately they're just trying to predict delays, period, and delays at the destination because you have if you have a flight and it's delayed. Is it delayed from the source or from the origin airport or from the destination airport? Which one caused the delay? If you're trying to look at a flight and then you're trying to predict future flights between two airports, and it's a flight you don't have any information on necessarily, right? That's the whole point of predictions. That's the whole point of machine learning is to be able to predict something maybe you've never seen before, right? But know that it looks like it's probably likely to be delayed or something because of a lot of different variables. So it's not about specific flight combinations, it's about the airports and which airports might have the most likelihood of having delays. So they focus mostly on delays for the destination airport. I kind of went through and read through it a bit more yesterday, but it was just kind of brought up that, hey, weather, ironically enough, weather delay was omitted. And there's actually more reason for it. I dug into the data. I really kind of got hung up on this thing. So last night I dug into the data a bit more at the data source over at the transportation company that provides this data. And weather delays are actually in more than one spot. The main weather delay that they have you omit is actually only major weather delays like hurricanes and tornadoes and stuff. But the majority of weather delays actually come from a totally different field. And so that adds a whole nother wrench to the whole thing. So I think they're trying to avoid that complexity and just said, look, we're just going to focus on delays. Okay. So it's a little bit of a cheat because the objective is delay based on weather, but they focus on really just delays from anything. And so I'd say just roll with that. If you try and use the weather delay field, which they tell you to omit, which makes sense now, it's not going to be accurate because it's only delaying based on severe weather, which is only a very, very, very small fraction of delays. In fact, weather delays in general, I learned something new looking at that data and looking at discussions around the data from that site. Weather delays only account for about 6% of delayed flights. Everything else is usually vendor problems, mechanical things, late aircraft that get in your way, right? All that kind of stuff. So kind of interesting stuff, but it's kind of neat when you do these projects, you learn a little something because we are using real data in a lot of cases, right? I mean, most cases it's publicly provided data that we're working with. So some fun stuff there. Anyways, just wanted to kind of think that one through just a little bit and kind of, say, look, some of these, they are just meant to be projects for you to work on and kind of get you thinking. And I do really think, it's a good idea that you stop back and think and go, well, why are we doing this? Why would you omit weather data from this, even though that's the objective? So it's good to ask those questions, but on the same token, keep in mind, it is a lab. It is a lab project. In reality, you might spend a lot more time, right? A lot more time really kind of diving into the data and figuring out exactly how you're going to solve the problem. You're getting, 2 hours a day actually really getting like an hour a day on the project, right? Because you're doing the exercise and then you're doing the project. And you're getting like an hour and a half a day. So in all reality, Monday wasn't part of the project. You get Tuesday, Wednesday, Thursday, you get 3 hours on the project. Larger projects like that in real life, I mean, you're probably gonna spend a lot more than 3 hours really kind of sifting through the data and figuring out exactly how you want to do it and experimenting and playing around with that. So just kind of keep that in mind as well. Okay. That these are simplified projects to try and maybe, lead you to a fairly simple direction, even though there may be much more robust answers or solutions to the problem. Okay. All right. Good. Any questions from yesterday? We covered a lot of pretty good stuff yesterday. We went into, the definitions of things like accuracy and precision and recall and F1 scores and AUC, ROC. All those are for classification problems. I want to make sure you understand that. Those are all really for classification problems. The confusion matrix, as opposed to, there's also other matrix we've talked about, right? We've talked about correlation matrix as well. Understanding the differences between those, how what they're for. The confusion matrix is going to give us our true positives and false positives and true negatives and false negatives, right? Those 4 values, and it's a balance of those values as to what we consider true. Okay, what we consider accurate, if you will. But again, the actual term accuracy is we're taking all of them into consideration, but maybe we don't want to. And again, just kind of recapping, I know I've said this probably 100 times now, it feels like, but if I've got my fraud and I've got 99% of the fraud is not fraud, and that's reality. If I simply said nothing is fraud, I would end up with 99% success, right? If I used accuracy. So accuracy is a bad option for that, most likely, right? Maybe F1 scores make more sense or something like that, right? But you could play around with some of those numbers and see what you think makes the most sense. But bottom line, just because 99% of the answers are correct doesn't mean our model's working. Doesn't mean it's working at all, not even close in that context, because of that. And that's also another reason to not have class imbalances on your training, right? So we talked a little bit about that too, class imbalances. So if I was training this and my test data set, by the way, if I'm training this environment on just that 1% fraud, right? Um, it's gonna lead me to have some very, very good numbers, no matter what, no matter how bad I am. I'm gonna have 99% success. So what I'd rather do is see if you can get half of those fraud and half of those entries to be fraud. Now it's 50-50. Class balances are going on, and now it's all balanced. And now if you don't get the fraud correct, if you got none of the fraud answers correct, you would actually only get 50% accuracy, right? And then same thing with tests, right? You want to make sure that your test and validation kind of represents the same thing. So if my original data set is actually balanced correctly and I have 50-50, if I can achieve that, then I randomize it and I take a chunk for test, a chunk for validation, a chunk for training. Now I'm going to end up with a much more robust answer. So keep that in mind too. I can't have those class imbalances are really going to mess me up. And that's also going to give us some false hope on success. Again, 99% success looks amazing when 0 fraud was predicted correctly. Or I do class balance there and I've got 50-50. Now, if I don't get any of the fraud right, I'm only showing 50%. And so that's gonna show us that things are working or not, right? So that's where your test, if your test, your way of evaluating, and then the data set, if those things aren't all kind of thought through carefully, you could very easily tell yourself that you're doing amazing when you're really doing terrible. Okay, so all things that we need to be thinking about, right? Randomize your data. We also talked about k-fold cross-validation. Remember that, right? What's that for? I'm not going to use k-fold cross-validation to create some hybrid model per se. I'm using it usually to compare. That's usually the way to use that. Is I have a really small data set. I don't know the performance of this data. I don't know the performance of my training because the test is just too darn small. And so to get a good test out of it and a good training out of it, I'm going to do multiple folds and run through that multiple times and get an idea comparatively about how my settings are behaving and my algorithm is behaving and all of that. So if I want to try different algorithms and see which one maybe works better, or if I want to try different hyperparameters for those algorithms and compare them and see how they work better, k-fold cross-validation is a great way to do that. All right. Any questions from yesterday other than the stuff I just kind of recapped for us real quick?
Right. I have a question about the data.
Yeah, go for it.
For fraud. So if I was supposed to get a data set where there's an imbalance with the amount of data that I have excuse me, for fraud versus no fraud, so I have more non-fraud data than I have for fraud data. What if the business could not provide additional fraud data to me? Would an option be to remove some of those data, or would I keep it?
Great question. So sometimes there's a couple different strategies around that, but sometimes I wouldn't remove data because it's almost always more data is better. The problem is the imbalance. So do you remove the not frauds, or could we somehow inject fraud? So what some people will actually do, and this seems to be successful at times, I would still run it through tests and verify your success at the end, but maybe actually injecting new fraud entries. And sometimes you can do that by just copying fraud, right? So you have a couple in there that are fraudulent. You could duplicate those and have duplicate records. There's good and bad that comes with that, because by duplicating the record, it's an identical scenario. So it's not necessarily going to be able to predict other scenarios as well, but at least you're giving it more representation, more weighting for fraud. So that's one strategy. There's a few others out there you could kind of dig into a little bit more. But yeah, you want to try and do your best for class balance. Now, that's the other thing too, is you're not always going to be able to. Now, in my example of 99%, that's a really, really big imbalance where I have a 1% and 99%. But if you're looking at a class imbalance of like, I don't know, like 30-70 or 40-60 or something like that, it's not ideal by any means, but it may work. And there are strategies. And we even talked about a couple of those metrics around class imbalances and stuff. So kind of go look back through some of the notes on the slides and stuff too, because some of them actually kind of highlight that if you have a class imbalance, this might be a good one to use, kind of a thing, or a good metric to use. So sometimes class imbalances are just there, and they are what they are. We just want to be aware of them. If we can fix it, great. If you have a situation of it's 99 versus 99 to 1, to realistically duplicate those records to make it 50-50 is probably not realistic, right? I mean, you would just end up with a whole bunch of the exact same record. But if you have a smaller deviation than that, or smaller variance, then duplicating a few of the fraud records may not be a big deal, right? And so you could bump that quite a bit. If you have like 75-25 and you're like, it's just not enough, maybe I could actually just duplicate all the fraud records again, and now I have 50-50, right? Or I don't know if the math works that way or not, but I would basically double the fraud count at that point, and I'd have enough records now that would kind of reinforce that, if you will, right? So some different strategies around it out there, and there's others. There's some pretty advanced stuff you can do, but that's just kind of some ways to kind of think about it if you can, right? Okay. So let's see, where are we at? Just looking at my looking at our schedule here. Okay, feature engineering. We're entering into our feature engineering discussion. So I got to get that slide loaded up here. Actually, I had the wrong slide pulled up, so give me a second here. Feature engineering. Then I'll share my screen here. Go figure. Microsoft had an update like 2 days ago. I think it made my system better. So go figure all the problems I was having. I think I'm better. We'll see. Cross my fingers. So this is what I get for. I held out for a long time. It's been out for a while. I was thinking, okay, it's got to be better by now, right? All right. Okay. So feature engineering. All right. So up until now, here's what we've done, right? We formulated the business problem and the problem formulation. We went ahead and did that, right? Keep in mind the difference here. The business problem is purely from the business, about the business. What are we trying to do at the business level? Problem formulation is about the machine learning side of it, but deciding what kind of machine learning problem it is. In other words, what are we going to forecast? What are we going to predict? So this really isn't about the data. Keep that in mind. It's framing it around the business problem of the business wants to know if this is fraud. So our problem formulation is fraud or not fraud. Okay, maybe we don't want to scale. We talked about the whole idea of a scale. The scale can be a problem in and of itself, because then who draws the line in the scale? Now, here's the interesting thing. Binary classification problems, there's usually still a scale within the system where your cutoff might be, kind of a thing. And we'll talk more about that kind of stuff today too. So it's kind of interesting because it still might exist, but it just may not be presented to the business that way. And that might be better, because if you present a scale to the business, there's going to be the business is going to have to make that choice of what number's better. But here's the thing: if we make that number choice, if we make that cutoff in our own environment, we can use test and use data to see if that's the right cutoff. Right? We can actually come to let the numbers tell us that's the right cutoff, and kind of play around with those different thresholds and get what's optimal. If we just present some scale to the business, then it's going to become emotional, and or subjective, right? It's just going to be somebody's going to think, oh, I think we should cut it off at 0.7. Somebody else is going to say, no, I think it needs to be a 0.8. And, they'll negotiate some number without any data behind it, right? But we have the opportunity to create that threshold and say, here's our model. And our model has a cutoff, and our model is going to predict this is fraud or this is not fraud, and it's accurate in doing so, right? Again, I'm using the word accuracy there loosely, but that's the kind of thing that we have to be thinking about. Is sometimes even with binary classification, there's some sort of cutoff that might be taking place there, and it's kind of up to us to tune that, perhaps. But the nice thing is we have the data to tell us that. We don't have to take some guess, right? It's usually try different cutoffs and see what the results look like and run it through those tests so that we can then just simply say, hey, business, our model tells you if it's fraud or if it's not fraud, and it is correct so many times out of so many times, right? And so then it's mathematically sound, it's scientifically sound, it's not just subjective to the business, all right? So then, of course, we collect our data, we see if it's appropriate. We want to visualize it, kind of see what we're working with. As we talked about, some of those visualizations can bring out things that you would have a really hard time spotting otherwise. Then yesterday we trained our model in our projects, and you spent a little bit of time evaluating it as part of that as well. Again, confusion matrix is about evaluating it, right? And that's where the F1 scores or the precision, sensitivity or recall, accuracy, those are evaluation mechanisms. Those are meant to tell us how the model is performing. So as those numbers go up or down with our tweaks, we know if our model's getting better or worse, right? So you could make a change to the data, you could make a change to the features, you could make a change to that cutoff I was mentioning, you could make a change to a hyperparameter. All kinds of things you could do to help adjust those scores, right? But ultimately, the model evaluation phase is those things we were just talking about. And then, of course, you've also got on the regression side, we've got things like R squared and whatnot, right? So we're going to use those things as evaluating the model so that as we make changes, and again, those changes, to recap on this, some of the big changes that we can make, hyperparameters so we can adjust, and we're going to talk about those this morning as well. Hyperparameter tuning that we can do. We could muck with our data, right? Maybe our data needs some work still. And when I say our data, I'm saying that loosely. We could do some feature engineering and stuff here, right? Figure out maybe we need to change some features around. We need to engineer some features. And what we mean by that is maybe we're creating features. Maybe we're adding features, okay? And we're going to use this to enhance our model, all right? And then, of course, as I said, threshold cutoffs, that kind of thing that you could adjust. Maybe so we're using those scores to help us drive what direction we need to do with some of these things, right? We make a change and we see does it get better or worse, right? So we're going to talk about feature engineering here. This is a great topic. I think this is pretty fun. This is a fun topic to really kind of get your brain working a little bit. So let's look at this data right here. Some pretty simple stuff. We got date, visitors, and sales. We've got some sales that kind of stand out from others, but what's unique? Why are these sales sticking out? Any thoughts on this? Why this might be the case, just out of curiosity, and or what we could do here to help enhance this? What do you think? Okay, yeah. So I got one privately sent to me. Maybe there's like Labor Day sales, things like that, back to school, perhaps. Okay, gotcha. Yeah. What are some of the things we could do to help us understand this data better and help the algorithm understand the data better? Okay, there. Kip mentioned weekend. There we go. Are these weekends? Can you tell if these are weekends? So Kip is thinking maybe we do a binary for weekends, like weekend, yes or no. That'd be interesting. Yeah, you could. I could see that being a possible option. So scaling the data isn't going to be the solution for this specifically. We still might. In addition, okay, scaling would absolutely make an addition, but does scaling help us understand what's different between August 31st and September 4th? Why is it that August 31st had such larger numbers than September 4th? Scaling isn't going to fix that for us because it's not going to help tell a model why August 31st is better, right? Scaling is absolutely something we're going to need to talk about. But scaling doesn't solve the problem, okay? So yeah, Alexander's onto something here, right? It's a day of the week, okay? There we go. That's exactly where we were headed. You could do a binary, weekend or not weekend, or you create categories, day of the week, Saturday, Sunday, Monday, Tuesday, Wednesday, okay? That kind of thing, all right? So now the algorithm is going to start to recognize, wait a second, sales and visitors are way higher on Saturdays. I want to point out we had some discussions around this earlier in the week. So Kip's point about you could do a binary for weekend, and I absolutely agree that's a possible option. But if the weekend varies enough, that could be problematic still because maybe Sundays are still just not as performant as Saturdays, and maybe that matters to us. Maybe the actual day of the week matters to us, not just that it's a weekend. So think that through. On the same token, a weekend is easy to work with because it's simply binary, 0 or 1, versus a category is going to cause a whole nother set of challenges for us. And we're going to talk about that in more detail as well, because categories, now I can't just do a 0 or 1, right? So it's actually a new problem we're kind of introducing ourselves here. Okay. Genevieve, can you expand on that for me? So it was mentioned, dummy variables was a question. What are your thoughts on that? I want to kind of get some thought work going here on that. What do you think? What is your thought process on that? Maybe walk us through that. Again, I'm not trying to get you to, not putting you on the spot. I'm not trying to. I just want to get the thought process around dummy variables. Oh, okay. Yeah. Get dummies. Yeah. So we're going to talk about that. Yeah. Have a column for each day of the week. Yeah. So it's another term for that, by the way. And that's where I wanted to clarify just to make sure before I got ahead. So there's private messages coming to me. So not all of you can see it because it's sent to me, but it's called one-hot encoding. Yeah, exactly. So we'll get to one-hot encoding to handle the day of the week kind of scenario. We'll talk about that here in a little bit. Yeah. Fantastic. Good. Just making sure. All right. So, okay, so we have some feature engineering components. These are different strategies within the feature engineering phase of the pipeline. Feature extraction, feature selection, feature creation, and transformation. Okay, so the first two, feature extraction and selection, reduces the dimensionality of our data. Feature creation actually adds dimensionality, technically speaking, but usually it's not a problem. So when we talk about dimensionality, we're going to talk about that pretty heavily. But if we see this chart right here, usually the more features we have, we have an optimal point, and then it drops off pretty rapidly. So if I can train on one column, then let's train on one column, if that makes enough sense. Okay. But what we don't want to do is just add feature after feature after feature, thinking that's going to help us give us insight. Okay, this goes back to, I think I mentioned the whole in and out thing, right? Whether or not you're a fan of the company or of the food or whatever, it doesn't really matter. It's the choice thing, right? Less choices, it's a lot easier to see patterns, right? Imagine you as a human being. If I have a 2-column spreadsheet, and I'm trying to manually look for patterns with the data, just manually, 2 columns, it's going to be a lot easier than if it was 20, right? Well, it's the same thing for the algorithm. It doesn't change. It's the same issues. The more variables you have, the more features you have, the more combinations we're going to end up with, and no pattern really emerges, right? So if a pattern doesn't emerge, then of course our model isn't really going to be doing much. So we want to try and keep to the minimum amount of dimensions as possible to achieve our goal. Okay, that is the objective here. So feature extraction. In this case, it's just kind of an example. You've got this car, and we can extract features from the car and kind of say, okay, we've got windshield, headlights, and tire. And maybe that's all we need to be able to say, yeah, it's a car. Now, I would say maybe it's not a car, maybe it's a vehicle. Okay. Because of course a truck would probably have the same features. So, but kind of extract some features and figure out what it is going to be, what's going to be enough to tell you that, that the thing you're trying to predict is what it is. Right. And so, now this is very high level. Obviously, to identify a vehicle, you're probably going to have more than just windshield, headlight, and tire, but this is just to kind of illustrate the point of extract those features, kind of understand what it is we care about. Maybe there's features we don't care about at all. Reflectivity or something, there's a reflection in the, some sort of edge kind of thing. Maybe we don't really care about, so there's things that we're going to be able to kind of dump too, right? There's different feature extraction strategies, and this was brought up actually on the first day, the second one here. With structured data, you could use PCA or T-distributed stochastic neighbor embedding, which is TSNE. Either one of these, PCA or TSNE, these are good for extracting features as well. So in other words, run an algorithm, actually create a model around your data to be able to help us identify the features that make sense. Okay, I'm kind of just overly summarizing there. But you could use this to help identify correlated features as well, and what to do, which correlated feature makes the most sense to keep, and so on and so on. Okay, there's a lot you could do with these. And then when you're dealing with like text or words, things like that, natural language processing also can help us extract those features. And in this case, features might be words, very specific words, prepositions, and articles and prepositions being extracted or excluded, I should say, and then the popular words throughout would be kept. So there are, of course, strategies to help us extract those features. It doesn't have to be something done completely manually. All right, and then keep in mind too the differences between machine learning and deep learning. If you recall, the major difference there is with deep learning, the features are derived or created for us, right? So the features, deep learning actually identifies the features, as opposed to with machine learning, we define the features and let the data, find the patterns, if you will, right? Okay, and define the rules. Okay. So feature selection. So again, feature selection. This is about reducing dimensionality at this point. Feature selection, right? So we've actually used this a couple times in my discussions, in my examples. So we have day of the week, date, and visitors, and then we've got sales, revenue, and net. Okay. We do know that as sales goes up, revenue will go up. Okay. We are not going to have a sale go up and revenue go down, because revenue is just how much money you collected, right? If you collect even a penny for a sale, your revenue just went up. So as a sale goes up, revenue goes up every single time, right? Net is different, because that, of course, is your actual spend or actual profit, if you will. And maybe you care about this, maybe you don't. The problem I have with this couple of set of slides real quick is they don't actually tell us what we're trying to predict and what we're trying to do here. So so it's a little bit questionable, because on this next slide we say that net is not relevant. If we knew what we were trying to predict here, we could say it's not relevant. But the point is, maybe we're trying to predict the best day of the week for sales, or the best best date, even, what day of the month is the best sales day, or a best day to have a sale or something, like that. So in that regard, net wouldn't matter, right? So I just to clarify on this, because I think the authors of the class kind of made an assumption here without specifying it or telling it to everybody else, but this is where revenue was duplicating sales. And in all reality, it was too correlated. Okay. So as sales went up, revenue went up. So we said, well, you know what? Sales make more sense to me than revenue. Because again, you could make a lot of money and, revenue wise, you could collect a lot of money for the day and your net could be really low still. Maybe what we're really caring about is just the number of sales for the day. Okay. So number of sales is really our focus. And the number of visitors might help us as well. Hey, we're getting more people in here. So of course, more people means more sales, hopefully, right? And then they're saying net is not relevant. Okay, so we'll just kind of scrap that because maybe we're not trying to predict profits for the day. We're just trying to predict, best day for sales. Okay, that kind of thing. All right. So we're going to select. Now we're selecting these for features. Okay. We've dumped 2 off. Okay, so we went from 6 to 4. That's going to help us because again, extraneous information, too many features, we're just creating noise to the algorithm, and we're going to reduce patterns that we're going to spot, right? So imagine an algorithm being applied to this whole thing, and then you have your weights as a variable, right? But the algorithm is going to look at the day of the week, the date, visitors, sales, revenue, and net. And if you look at all of them, then revenue and net are included in that. And net didn't even matter to us. And revenue is just reinforcing sales. And so you could see how a calculation off of all of these values is going to be thrown off with these 2 extra columns, right? So we cut those out and we've got a lot more solid focus now. All right. Great point. So I do want to point out, Genevieve's got a really good point here. Maybe there's a staffing problem. Maybe there's something else going on. That's a different machine learning problem. Now, that's the thing I want to make sure we're very clear on. Many times, I'll create lots of models. Okay. It's not just about one model. So maybe we need to have a different model about staffing, but we can't answer any staffing problems with this data, can we? We don't have any knowledge of staffing here. So I completely agree, but that's where we have to make more than one model. We're not going to try and conflate these things. Okay. If you try and conflate them and you try and combine data into one to make one prediction, you're actually causing bigger issues. Okay. Because you're trying to solve more than one problem at once. Okay. In this case, we're just simply saying, as of the current status of the business, and everything remaining the same, as of right now, our best sales days are X. Now, the Y could be staffing issues, right? The reason for it could be something that we're not aware of. And we're not even trying to predict the Y here. The fact of the matter is that we have made more sales on those days, right? Regardless of why or how that happened. I want to point that out. So if we want to understand why or how that happened, that's another model. That's a completely different model, right? And of course, we're going to have to go dig up different data for that. Okay. So we go through the exact same exercise, the whole pipeline, right? So for that challenge, we would say, okay, we're making one model here saying this is our best sales day. Okay. And it might be because we have better staffing. It might be because we have better advertising, maybe better hours, who knows, right? There's a whole lot of reasons why the sales might be better on certain days than others, but we're not trying to predict that. So when we do want to predict that, we're going to come back to the pipeline. We're going to start all over again. And we're going to say, okay, what is our business problem? We want to know, what our staffing looks like, are there days where our staffing is overstaffed or understaffed, that kind of thing? Or is the business problem something more like, hours of operation, and do some analysis around that, right? So, and some of it may not be machine learning problems at all. Some of it might just be straight up analysis of, well, we have longer hours on the weekends, so we make more sales. Could that be, could the sales be inflated simply because we have more hours? That's an interesting one, because you could look at it, sales per hour, and maybe the sales per hour is the same, You just have minimal hours during the week and expanded hours on the weekends. I mean, there's a lot of things you could look at there, and some of it would be machine learning, some of it may not be. But the point is, when we are focused on a business problem, in this case, the business problem, again, they didn't state it for us. I kind of wish that every one of these examples, like when we're going through like this exercise, I kind of wish they would state the business problem for us and state the machine learning problem, because it would help us, think clearer on this. But they didn't do that. So I'm guessing, based on kind of the narrative of the slides, that the business objective here is, which day is the best sales, and not just, in general, be able to predict that in the future, being able to say the third Saturday of that month, based around, holiday schedules and everything else, that's going to be the best sales day, of the quarter or something like that. I don't know. But point is, the why has nothing to do with this. Okay. The why has nothing to do with this, but great point though. Okay. So, eliminating irrelevant data is important as well. Irrelevant data is going to increase processing time. Okay. Our CPU and compute requirements to train and test and all that are going to be increased. Plus, I mean, if we have, a ton of data here and half of it is irrelevant to us, then let's ignore the half that's irrelevant. Okay. But also it could actually dilute my information, right? Again, if we're trying to do clothing sales, rather our data is clothing sales. But if you're focused on swimsuit sales, we probably want to dump winter and fall, right? We're really kind of focusing on spring and summer. There may be a couple of sales in there in the fall and winter, but they're not going to be overly useful to us. And they could, like I said, dilute the predictive aspect of it. Plus, it's going to potentially create a class imbalance, right? Because we're going to have half the data set's not even going to contain swimsuit information. So when we talk about that class imbalance, this does go back to, should we delete data? Maybe, right? In this case, deleting data makes sense. It's getting rid of winter and fall. It doesn't make sense to include that at all to begin with. And now this is probably going to create a better class balance. This is going to reduce my computation requirements. This is going to give me a better representation of the data we're looking for. We're not going to have a whole bunch of data shoved in there that is not at all swimsuit sales, right? Which can delete my predictions and stuff as well. So just get rid of the irrelevant data. And this is where deleting data does make sense. Okay. And that might coincide with class imbalances. So go back to that question that we had earlier this morning. Just kind of bring that back full circle here, right? So get rid of spring and summer, or excuse me, I'm sorry, get rid of winter and fall, keep spring and summer, right? Now, dates. Dates are not helpful. They're really not helpful at all. This is a big mistake a lot of machine learning people do. And even if you change this date to a different date format, right? There's different strategies that you could do out there for date formats. What is a date? A date is a number. Algorithms deal with numbers. That's all they're dealing with, actually. This number is just a indefinitely incrementing number. An algorithm doesn't understand a date. It doesn't. It's just a number. So by having a date like this, it's really a very broken feature. Okay. A lot of people don't realize this. They're not thinking about it this way. They're like, oh, it's going to look for patterns and dates. No, it won't. It's going to see that the number just indefinitely increments. Okay. This date is represented as a single number. All right. We have to understand that's really, really important here, because dates are used all the time, and your feature engineering should probably deal with dates a little smoother than that. Okay. At the very least, maybe think of something like this model over here. Okay. Month, day, year. There's still an issue with this. An issue we can't really completely solve, but I'm gonna bring this up here in just a second. Month number. Numbers have a value to them, right? They're not just arbitrary. So if I give you the number 12 and I give you the number 1, which one has more value? And when you think in mathematical equations, which one has more value? 12 would be considered 12 times the size of 1, right? So even month numbers, like I said, we can't entirely get rid of this idea because, days, we're not going to be able to solve this for every single day of the month necessarily. But the 12th month, so let me put this into perspective. If something is sold in December and something is sold in January, 5 days apart from each other, the one sold in December somehow holds 12 times more weight than the thing sold in January. You see what I'm getting at? Mathematically, it's just a number. It's a number of a column. The algorithm doesn't know that this is a month. I mean, it's not that kind of thing. It's a mathematical equation. It's not, there's no understanding of context here, really. Okay. An algorithm is just that. It's a mathematical algorithm applied to the numbers. And it's looking for patterns based on when you adjust the weights, what's the outcome do, right? So this is tricky because we don't really want December to hold a better weight than January. And in fact, a weight of 12 times as much, right? And when I say the word weight there, I don't mean weights in the sense of the algorithm. I'm talking about just value of the number. The value of December is 12 times the value of January, right? So so this is better than the date column like this. So at the very least, don't leave date columns as date columns ever. I mean, in all reality, even if you change them, some people will say, well, there's ways to represent this, from what's that called? The point at which the numbers kind of start, if you will. I forget the name of it. I'm totally drawing a blank right now. It's early. It's been a long week. But that's still just an incrementing number. Okay. So we got to split this up, and at very least, let the algorithm start to see that, when a purchase happens and month value is 9, day value is 4, and year is a certain year, that there you go, epochs. Yeah, exactly. So thank you. I totally spacing this morning. I woke up this morning kind of thinking, man, I'm just kind of shot. I mean, I'll try and I'll hold it together for you all this week, but I don't know. It's just kind of a long week, not just in class, but stuff happening outside of class, family stuff and everything too. So anyways, we've all been there, right? but you won't notice it. I'll try and keep my wits about me for the day. But so we got 9 for 2019. At least now mathematically it can see that when 9 is, when 9 is 9 and the day, that it can actually have some sort of representation there as opposed to just a single number for the date. That number is just always incrementing, and that's that, Whereas month is kind of looked at a bit more like a category to some degree, right? We have 12 categories of months, right? Day, I mean, still you could argue the same thing, but we're not going to try and make 31 categories for day, so it gets a little bit tricky there. So numerical or categorical, okay? So here's the thing that we can look at. So when we're handling features with numerical data, all right, these are some techniques we can use to apply to the data. Now, a bunch of you throughout the class have mentioned scaling a bunch of times. That is one approach to handling large scales of data where you have big swaths of information, right? The low number is like 4 and the high number is in the millions. You're going to want to scale that, right? So that there's a scale there, not just the actual number. So we actually would replace the actual number with a scale instead. We'll talk more about that, but there's other approaches. Okay, so we got logarithmic transformations. We got squaring or cubing of data. binning data and scaling. Let's kind of show you these real quick. So logarithmic transformation, to basically deal with the log of it, right? So instead of the actual values, we're gonna log it. We could also do square root or cubed root. If we do square root, we can't do negative values. Okay, so this won't work if the feature has negative values within it. This will have a moderate impact on the distribution. Now, I don't like these examples because these examples are actually square area or cubic, it doesn't have to exclusively be applied to that kind of thing. So I think these examples kind of lead you to thinking, oh, well, if it's a square foot area, like an area of an apartment or a house or something, you can square it. And yeah, you can, but it doesn't have to start out as a squared value to do the square root of it, right? So I think these examples are kind of flawed in that they kind of lead people to thinking of thinking something that's not true here. So you could square the values, right? Do the square root of them, I should say, and just use the square root values for all of the values. You can't do this with negatives. And then cubed root, you can apply this to negative values though. Okay, so this has a high impact on distribution. And again, another example here, volume, a volume aspect. Of course, you could cube it, the cubed root of it, right? And bring up, create a different number out of this. But again, does it have to be a volume measurement to use the cubed root? No, just we're converting numbers here from one number to a different using consistent equation across all of the values, right? And then we have binning. So this is really, really helpful when we have ranges like this. And I would argue this could be potentially going back to the idea of weekend, not weekend, things like that. Depending on our scenario, it's possible I might just say, use some of that stuff to, is weekend, right? 0 or 1, right? And that was brought up as a possible option. But in this case, this is really good for like age columns. If you don't need to know the exact age, if we're not trying to predict an exact age, but maybe what we need to do is be able to understand that maybe this is a child, or this is an adult, or this is a senior citizen. Keep in mind, we're not necessarily predicting these things. This is just features of our data, right? And so whatever we're predicting, maybe we don't care when we're predicting something. We don't care the difference between a 5 and a 6-year-old. And we also don't really care the difference between a 25 or a 35-year-old. We just simply care they're a child, they're an adult, they're a senior citizen. And that's all we really need to know anyways. So this will make the algorithm a whole lot smarter because we're not going to have a column anymore that's just an age column with a bunch of random values in it, right? Because the age column could have 100 unique values in it or more, right? I mean, if you got people of all ages and there's people that are, 103, 105 years old, I mean, you're going to have a lot of unique values in here. And those are actually just going to kind of throw off the algorithm, right? You don't really need to know those specifics. Those specifics actually cause you issues here, right? So if we're just trying to predict that when an adult does something or when a child does something, it results in something else, do we really care if it's a 5 or a 6-year-old, right? Probably not. So so this is a really big one, okay? This is not the same as one-hot encoding, BJ. So one-hot encoding is very similar, but one-hot encoding maps to one-to-one. This is not a one-to-one. So when I say one-to-one, so we'll actually get to one-hot encoding here in a minute, which is also dummies. But the idea is with one-hot encoding, let's say I've got three categories. Each category would get a column. Okay. Here, we're not dealing with categories. We're dealing with a value, and we're going to bin that value. We're going to say all numbers within the 0 to 17 range are going to end up here, okay? And all values, so we're binning them. It's very similar output as one-hot encoding, but it kind of looks the same with the zeros and ones. But really what we're doing here, what's really cool about this model is we have in fact created 3 columns or 3 features, if you will, out of 1, right? So some people might say, well, Ryan, doesn't this create dimensionality? And we've just finished saying we want to reduce dimensionality, right? This does not create dimensionality. It actually helps reduce it. And here's the reason why. I mean, it's not truly reducing it because we still have more columns, but really in reality it is, because now this is the only column that's going to have a 1 in it. These others are all always going to be 0. Okay, and the nice thing about computers, 0s and 1s, on and off, binary. This is very easy for computers to understand, right? And for algorithms to understand. This number over here, right? We have a 5, we have a 14. Both of those numbers represent the same thing to us, right? So we don't need 5 and 17. We just need to say, yep, it's a child. Yep, it's a child. Okay. And so we make these bins of values. It's a collection of values, and we no longer care about the value at all. Okay. We just simply say, yep, that's a child. Yes, that's an adult. Yes, that's a senior citizen. And of course, only one of the 3 can actually contain a 1. Okay. So this is very, very clean for the algorithm. There's no ambiguity here in the sense that what bin it belongs to, and it simplifies things a lot. It makes our algorithm a lot more precise. Okay, it creates patterns in our data now that are a lot more precise. Okay, because this one, if I run an algorithm against somebody that's 5 and then run an algorithm against somebody that's 6, the algorithm answers are going to be different, right? Think about this for a second here. The actual result of the algorithm, the math is performed, the answer should be different for each one of those, right? Now, they're going to both result in the exact same answer. And that's good, because it's going to help us with our predictions be a lot more accurate. Oh, hey, in our predictions, if it's a child, we can just say if it's a child, then this thing will happen out there, right? As opposed to, well, if it's a 5-year-old, this happens. If it's a 6-year-old, we're not quite sure, and it gets really vague and very ambiguous, right? So very cool strategy for when you have groups of numbers or you have ranges of numbers where you really don't care about the exact number. You really can kind of group them into buckets, if you will, or bins, actually, of information. We just say, is it in that bin? Okay. Now, so this is another strategy. So again, log, we could do recap real quick. We could do the log of the data. We could square root it. We could cube root it. We could bin it. Okay. And then we could scale it, right? And so scaling's been brought up by a few of you as well. So scaling, look at things like this, like home price, right? That number versus that number. Okay. Pretty big ranges of numbers, even though let's say the number of bedrooms doesn't change that much. Okay. Now you could argue percentage wise, the number of bedrooms went up by 300% with the house versus apartment. But in all reality, that's not the way an algorithm is going to see it. Okay. An algorithm is just going to be like, it's a 1 or a 3. I mean, those are 2 pretty small numbers. Okay. So the scale between these 2 columns is very different. We want to try and normalize these as much as possible. Okay. And so, and in fact, you can see here apartment 1, and we've also got a 1, but the number over here went up quite a bit. All right. So we want to try and keep these scales a bit more even than that. Okay. And so there's different techniques we can scale our columns or features with, right? And these are a few of them. There's a lot more, but these are a few of them. And so we have our mean variance standardization. Basically, again, we're trying to get smaller values. We're trying to keep outlier information, but reduce its impact in the process. Okay. So I want to point out a couple of things. These few slides we're going to show you. We do show you the algorithm. Now, this is not a machine learning algorithm. This is just a regular, calculation that's taking place against the data for us. So we would actually do this step in a pre-processing phase, right? But in all reality, this is during, as far as the pipeline is concerned, this is during feature engineering, right? So we don't do this until we've created our first model usually, because we'll have a baseline and then we're going to come full circle back and start doing some of this work, right? So, so in this case, we have this calculation here. We don't really need to memorize the calculation, okay? But I just want to point out also that scikit-learn actually does this stuff for us, okay? So all these slides kind of show us some sample code just to kind of give us an idea, and it does this work, okay? It does this work. So now our results are going to look more like this, you know, and be a much smaller scale, okay? So basically, what we're going to do is have, with the way this works, you'll see there's negative and positive numbers there. So for this one specifically, the mean variance standardization is basically, there's a mean of 0, and then you have your standard deviation. Okay. So a mean of 0. So whatever that mean is, it kind of resets that mean to 0, and then the standard deviation off of that. So this is basically representing the standard deviation off of the mean, if that makes sense. Okay, so just kind of summarizing that. Then we also have a strategy called min-max scaling. So your minimum values now become, your minimum value becomes a 0, your maximum value becomes a 1, and then it's a scale between the two. Okay, so now we end up, again, much smaller numbers, single digits, comparing those bedrooms to the value. So I would probably do this, you know, do these things. One of these strategies, I'd probably play with the different strategies, but I'd probably play with these different strategies on the price column, okay, over here, just to make sure we're clear on this, so that when we're comparing with bedrooms, it makes a lot more sense. We probably don't really need to worry about scaling bedrooms. Right? It's a pretty small scale to begin with, pretty small number, but price is all over. And so creating a scale there so that these are more matched would make a lot more sense, right? And so min-max scaling again, and again, we could just use scikit-learn to use min-max scaler. This is what's really cool. These tools, we don't have to do this math, and that's again why this up here, you know, for the math junkies, you know, that makes it's kind of nice to see the actual formula, but you don't need to know this unless you really want to understand what it's doing behind the scenes. But if you want to just kind of summarize it, hey, look, it's taking the minimum, taking the maximum, and then a scale in between. And to do it with scikit-learn, all we got to do is use min-max scaler. All right, it just does it for us. So basically, robust also to very small standard deviations. Either one, we can kind of play with quite a bit here. All right. All right. Max ABS. All right. So again, nice thing here. Scikit-learn, pretty easy to make a call here. This is basically your absolute values, right? So it divides all the data in the feature by the maximum absolute value. Yeah, go ahead. Jump in.
I have a question. Could you go back to the mean variance standardization slide?
Yeah, this one right here.
Yeah. So these numbers are pretty close together.
Yep.
So if I had an outlier in here, wouldn't it have one of the values would be much higher than the others, right? It would be like, maybe if I had like 100 in here, because it using the standard deviation, I'd have a bigger number for that still, and that would be okay.
It's not just standard deviation. I want to make sure we're clear on this. Yes, an outlier would still be represented. So that's kind of what it's saying here. It does keep the outlier information, but the impact is going to be much smaller. And the reason for that is it's not just standard deviation. We're first taking the mean and then standard deviation of the mean. And so it reduces that impact of that outlier, but the outlier is still absolutely going to be there. Yeah. So is this great if you have a really, really far off outlier? This may still not be sufficient. There's other strategies to help with that. If we have some really, you know, if the majority of my numbers are like 100, and then I've got a 10 million value, you know, this is still probably going to be too big of an outlier to reduce its impact enough. Okay. So there are other strategies we'll talk about here coming up, but great point there. So just be aware that you will still have your outliers represented, right? It's just that because we're starting with the mean first, and then we're doing the standard deviation off of that, we're not just doing standard deviation across the numbers, right? If it was all you did was applied standard deviation across all of the numbers, the outlier would pretty much have the same weight, right, as it did before. All you're doing is saying, here's what the difference is between them, right? But because we're starting with a mean first, then the standard deviation from the mean, the outlier's impact is much lower. So kind of draw a middle, a dot in the middle, if you will, of your data, and then standard deviation from that, as opposed to, wow, the smallest value and the biggest value are really, really far apart from each other. So it may not have as much weight or as much impact. Yeah, great question though. Yeah. So, but yeah, if you have a big enough outlier, maybe that's not the right one. So that's where we're trying to go through. Here's a bunch of options for you, right? Trying to think that stuff through, because for that exact point, and I love the way you're thinking there, because to that exact point, maybe that's not the right option, right? There's other solutions. And so we got to kind of weigh those different options and understand which solution might be best for our particular scenario. Okay. So, all right. So I think we were on this one, right? Yeah. So max absolute scaling. Okay. So it divides all the data in the feature by the maximum absolute value found inside the feature. Okay. So it's absolute. So of course, the way absolute values work, right? But here's kind of the idea of how this would play out. Okay. So you have the numbers 2, 10, and -35. Okay. And then that's going to look more like, it's going to do something like this, and then your final numbers, right? So, so this is, again, dividing all the data in the feature, dividing. Okay. So that's where this division, this calculation right here is coming into play. Okay. It's dividing that by the maximum absolute. Okay. So that's why the 35 is here. Okay. Remember, absolute values are only positives. So if this -35 right here is what drives this calculation right there. Okay. So 2 is divided by 35, 10 is divided by 35. And of course, 35 divided by -35 divided by 35, right? We're just, so then we end up with our final values look more like that. So this scale looks a lot better than that scale, right? And so that's kind of what we're getting at. So it's just a standard mathematical equation applied to all of the values in the column, right? And that's for all of these things. So this one's called robust scaling. So this goes back to that conversation about outliers. This one can be maybe a little bit better on those really extreme outliers. And so in this case, we're going to basically find the median of the feature, and we're going to divide that by the differences between the 75th and 25th quartile. So in this case, you're basically finding the middle 50th percent, 50th or 50%, I should say, right? So the first quartile and the last quartile are kind of de-weighted, if you will. Okay, so we're finding kind of that spot in the middle. So those values still apply. Okay, so this is why we talked about outliers add richness to your data, but they also cause you problems. So we can leave the outliers in there. We don't need to get rid of them. We just need to make sure we scale them appropriately, right? And so when we do some of this stuff like robust scaler, it can help us deal with those really, really big outliers, so that they're, because those are going to be in the first quartile or the last quartile, leaving the two middle quartiles really as part of the main work. So all of the data is still accounted for here. I want to point that out. It's just that this one basically is the difference between those quartiles. And so it's really kind of de-weighting, if you will, kind of in a just a generalized idea about this. It's kind of de-weighting the first quartile and the last quartile. Okay. All right. All of these slides have a bunch of notes on them. Every one of these slides, well, I don't know every single one of them. I'm trying to look through the notes here real quick. But a lot of them have links and references to the scikit-learn information on that particular scaling mechanism. and has a lot of notes. And so some of the notes are also much more deep dive in terms of what's actually going on behind the scenes here and how the math is actually working. So if you're really interested in diving into all of these, I would recommend you do the slides, just starting with the slides. The notes on each slide is going to help you quite a bit. So I would say go read those. There's quite a bit of notes there. And then we have to think about categorical data and if it needs to be converted into numerical data. Well, it has to, rather, I should say that. It needs to be converted to numerical data. How is that going to be converted, though? So this is really important. We have what we call ordinal categories and nominal categories. So ordinal, so if I have a category that is, let's just look at this data right here, okay? So look at like this garden size, right there, right? Hold on 1 second here. All right. So garden size right here is small, medium, large, or it doesn't have one, right? Those are different categories. Algorithm can't use the word small. Okay. Algorithm can't use the word medium, nor does it know the difference between the word small and medium, right? So an algorithm is a mathematical thing, and small is just a word, but it doesn't represent anything to an algorithm. So it needs to be a number. It has to be a number. A mistake people will make is just say all categories get converted to an arbitrary number. And so you have categories 1 through 10, category 1 or 0, 2, 3, 4, whatever, maps to some category. But if you recall, we were just talking about this. Doesn't that then mean that one category weighs more or means more value-wise than another category? When it should mean more, then this makes sense. Like garden size. Small can be represented as a number, medium can be represented as a number, and large can be represented as a number, and those numbers should get bigger. And if we do that, it's proper representation of the actual ordinal categories. Ordinal, they have an order to them. They have an actual order to them. Okay, so that's okay. That's okay. So at that point, garden size may be 0 means there isn't one, right? 5 might be small, medium might be 10, and large might be 20. Okay, we don't want to just do arbitrary numbers for categories, though. Okay, we want to think this one through and kind of give it a representation of what we're trying to say. This clearly kind of tells the algorithm that a bigger garden size may attribute to a higher price, right? You see what we're getting with that? A larger garden size, because now we've given it an actual value. We're saying, yeah, that's worth 5, it's worth 10, it's worth 20, right? But this is why, again, like I was saying, even like months, 12 months, this could be a problem, because now we're saying that December is worth more than January, right? Same kind of issue here. So when it truly is worth more, we want to represent it this way. All right. So again, categories, you can't leave words as words. They need to be converted to numbers, and people make this mistake all the time. I see lots of machine learning people, again, very, very smart, brilliant people that just make this mistake. People have been doing this for a long time, and they never thought twice about it, and they're not quite sure why their algorithms don't perform as well as they could be. Well, there's a big reason behind it. You've actually inadvertently potentially given a value to something that shouldn't be. And that's why one-hot encoding and things are so important. So we'll get to those in a minute, or dummies, right? Used as different terms. So the garden size is ordinal. That's easy. Okay. But
can I ask?
Yeah, go ahead.
I just want to ask to make sure that I'm understanding properly. So you're saying that in the event a feature actually is something that does represent order, and in this specific way that kind of, larger is larger, right? That if you represent a certain number, a larger number is maybe more favorable, whatever.
Yeah.
You're going to use these scaling algorithms that you had mentioned previously, and that's going to be kind of how we decide to maybe create a new feature that represents garden size, or change the data in garden size and scale it appropriately such that the algorithm can use it as ordinal data. Is that correct?
Close. Not quite though. So the difference there is we're actually not talking about scale here.
Okay.
This is, I mean, it is a scale. It is ultimately a scale, right?
Okay.
But we're not talking about using a scaling mechanism,
Okay.
like applying a log to it or applying min-max scaler or things like that. None of that. All we're doing is we're saying we recognize that these words need to be converted to a number, right?
Okay.
And so instead of just arbitrarily doing it, because if we actually look on the far left where you've got like house, apartment, and condo, those are just different labels, right? They're different categories.
Sure.
But I don't want a house to be worth more than condo or apartment, or, you know, I want them to be independent.
Mhm.
And so those are not ordinal, right? And so I need them all kind of to hold the same value, versus garden size. We know, yeah, a smaller garden is smaller and a larger garden is larger, and that may directly affect some of our predictions here. Just like area square foot, it's okay to have bigger and smaller numbers. The scale isn't a problem here. So like if I equate this to 5, 10, and 20, that's a natural, like that's a scale that we created on our own, right? Just manually. Like we just come in here and we say, we're going to call garden size small. We're going to call it 5. And we're just going to call garden size medium a 10. And we're going to call garden size large a 20, just because we kind of thought this through and kind of created that scale ourselves.
Right.
So we're not using an algorithm to do this. We're not using some advanced, tooling. We're just simply giving it a number, but the number represents what the category is.
Okay. And then so when are we applying scaling, or how is that applied?
So scaling would be like under price. You have this big range of numbers,
Oh, okay.
and you want to make those a difference between 0 and 1.
Okay.
Right. That's really where the scaling comes into play, is because if you also look at all the other numbers in this this data set here, we have one scale over on bedrooms. That's just a scale between like 1. It's probably going to be between like 1 and 5, right?
Sure.
For the most part. I mean, you may have some outliers, but probably between 1 and 5 average. Meanwhile, the price is ranging between, I mean, if you look at the much bigger data set, probably between, 100 something thousand to many millions.
Yeah.
Right.
Sure.
And
Okay.
and that's a massive range, massive numbers in general. Even the lowest value in price is still much larger than bedrooms. And
Sure.
so we want to try and make these kind of on the same scale, right?
Okay.
If you would imagine, the way I look at this, the way I tend to kind of treat this myself, is if I were to graph all of these things on the same graph, imagine that, right?
Yeah. Sure.
You have this scale on the graph that you have to pick, and then you wouldn't even see bedrooms. Price would be the one thing that stands out. Everything else would kind of be down at the very bottom or not even visible, So if that's the case, we probably need to do something to kind of balance it more. And so we're going to scale price. And it's not just that the minimum and maximum are so great. That is part of the scaling discussion, but it is also because the numbers themselves are so much different than some of the other columns, that we want to try and make them more even if we can. And so if I do a scale of 0 to 1 with price, that's going to match, other numbers in the features as well. It's going to make those other numbers kind of more even as well. And so the algorithm gets a little happier that way.
Okay.
Yeah.
Sure. Thank you.
Yeah, absolutely. Absolutely. So garden size having some sort of ordinal value. Now I say ordinal, I say the word order, ordinal order. And then people immediately think, but Ryan, months are in order. Yeah, they're in order, but I don't want December to be worth 12 times more than January. Okay. And that's kind of what we mean by order. Is do I really want that value to be worth more than another in the same column, right? So in that same feature, we can recognize a large garden is worth more than a smaller garden in the sense of the value here. The value represents the actual amount of the garden, right? So that one makes sense. But we shift over here. If we just, this is the mistake a lot of people make here, is they have categories, and they have 5 categories, and so one of the categories gets a 0, one of the categories gets a 1, the other one gets a 2, a 3, and a 4, right? or maybe you start with 1. But regardless, they just arbitrarily assign a number to a category. I see this happen all the time. But now, again, what you've done is you've created a value system where one category is worth more than another. And that is going to throw off your mathematical algorithm. Okay. So we want to fix that, right? So one-hot encoding, or dummies, you've heard dummy variables also mentioned. They mean the same thing. Okay. Dummy variables is one-hot encoding. This is where a category is split up into multiple columns. Okay. Excuse me, I shouldn't say a category. A categorical column or categorical feature is split up into multiple columns. So in this case, each category gets its own column. So if it's a house, then the house column gets a 1, the other 2 are zeros. If it's an apartment, it gets a 1, the other 2 are zeros, and so on, right? Now, the more possible options in this category that exist, the more columns we're going to end up with, right? And so you could have a new problem that emerges. You know, if I'm dealing with something that's got 150 different possible options, I've got 150 new columns I just added. So we gotta play with this and understand that there are issues that will arise the more columns we get. Now, that doesn't necessarily become a dimensionality problem, because still all of those are going to be zeros except for one of the values. But it's just a processing problem, and just some new problems emerge from that, just in general. I'm just going to leave it at that for now. But so there's no magic number to say, oh, if it produces 10 columns, we're okay, but if it produces 11, we're not. There's not a magic number there. This is where experimentation just comes into play, right? Does it work? Is it causing you issues? Is it really slowing down your training or something? You know, it's hard to say. So this is the risk I was just mentioning, is too many columns. In the case of states, right? We probably have at least 50. I say at least 50 because maybe states also includes other territories and stuff, right? But regardless, we know we have at least 50. And so in the US anyways. And so we've got, we would end up just introducing 50 columns here that may not be ideal. So then we may back up and go, does the actual state actually matter to us? Right. And this goes back to the whole idea of kind of like binning. We call it grouping here, but it's really kind of the same idea as binning. Is you're creating these groups of maybe regionality, right? So in this case, Northeast, Southeast, Midwest, Northwest, Southwest. If I don't actually need to know the exact state that the data is coming from, but I just need to know the kind of the general geographic vicinity, or maybe they share certain traits, so we could group by similarities. So again, it all depends on what it is we're working with and why we're working with it, and kind of think that through. Does the actual state matter, or does the general area matter? Maybe we're going to handle stuff that's coastal different than inland or islands, or things like that, right? So so this, a lot of the same concepts come into play, but the main thing we're getting across here is, if I had states, again, an algorithm can't see the word Alabama, okay, you would have to give it a number. And if I simply gave all 50 states an arbitrary number, then some state is going to be mathematically worth 50 times more than another state. Does that really it doesn't really make sense. And this, again, massive mistake people make is they just assign a number to a category. And so that's the message here. Think about ways to handle that. And so you could do grouping of different attributes, if you will, versus the actual value. Okay. And so you could group them together that way. You could consider doing one for each, but again, 50 columns, what's that going to do? And I might just do an experimentation and just try it and see. But because like I said, there's no magic threshold here. But, that's a lot of columns. That's a lot of columns that we've just, because don't forget, it's not the only columns in your data. You've also got all your other columns too. So this is just going to do this for this one column, this one feature, right? So we got to kind of play around with that. All right. Okay. Break time, I think, and then we'll come back and do hyperparameter tuning discussion after break. It's probably a good stopping point right here. So Let's see you back here. Let's see. We are at 9:56 Eastern time. So let's come back at 10 after the hour. It gives you about a 14-minute break. Okay. So that'd be 10 Eastern. We'll see you back here.
Ryan, are you there?
All right, go ahead and mark that green check. Let me know you're back and ready to go. Good.
Ryan, real quick, do you have a moment?
Go for it. Yeah.
So you mentioned in the slides that there were notes. Is this in the student guide, or where is this?
In the student guide, yes. So all of these slides are in your student guide, every single one
Yeah.
of them,
Yeah, I
plus
saw
more.
that.
So when you find those slides, the notes are in there. So you find the slide and the associated notes. Some of them have more notes than others. And
Yeah.
then some of them have references and links to outside resources as well.
Okay, yeah.
Perfect. All right, great. I'm going to clear that green check from everybody. Okay, good. So let's talk hyperparameter tuning. I'm going to do a little demo on this here in a little bit. But let's just kind of talk through what this is all about first as well. So we've talked about hyperparameters a bit. Remember all those different values that could impact the model training process, right? So learning rate is defining how big of a step it should take, right? Remember to that error loss, the error process, right? We want to find that minima and how big of a step. Too big of a step, you're going to skip it. Too small of a step, you're just going to take way too long and too many resources and whatnot, right? Then we've got things like gradient descent, stochastic gradient descent, mini batch gradient descent, those types of options. We've got what if you're going to do mini batch? What is the size of the batch? Smaller or larger batch sizes may actually change the outcome. Okay, there's a ton of possible hyperparameters, and every single algorithm has its own hyperparameters defined. So that's the other thing too. You can't just say across the board here are the key hyperparameters, because every algorithm's different and every one of them has their own. And so hyperparameters are probably one of the most challenging pieces to all of this, because the numbers somewhat seem arbitrary. All right. We could just try and throw some stuff at the wall and see what sticks, kind of a thing. Just guess. And that's basically what this has been in the past. So in the past, hyperparameter tuning was basically a guess and check kind of scenario. You try an option, see how it goes, and then adjust and try again and adjust and try again, and kind of keep doing that and keep creating new models each time. You create a model, see how it is with those settings. Create another model, see how it is with those settings. And we talked about being able to use that k-fold cross-validation and things like that, maybe to kind of help compare those hyperparameters as well, right? So here's the thing. There's different categories of these hyperparameters. If I can get my slide to cooperate, there we go. So we have, first off, we have your model, and you've got categories that directly help define the model, right? So this is going to be things like filter size, pooling, stride, padding. If you don't know what these things are, that's perfectly fine. You can go research those another time. Just these are some categories of hyperparameters, okay? And then you can optimize on how the model learns patterns on the data. This is where you're going to find things like gradient descent, stochastic gradient descent, like we talked about, right? And then the data itself, attributes of the data itself, okay? So these are all kind of different categories that hyperparameters might fall into. So manually selecting hyperparameters based on your intuition or experience. As you do get more experience, you might start to realize kind of some of the numbers that might make sense, or some of the general ranges that might make sense. But typically speaking, this is really shallow. It's very inefficient. It's not going to get you very far. Okay. We need to use tooling to kind of help us get here a little better. All right. So it's very overwhelming if you try and just think you're going to go manually set all these hyperparameters. So we've talked about all these up until now, and that may have been something running through your mind for some of you. You might be going, wow, there's all these options. How do I know what they all are, what they should be? Well, nobody knows what they all are, should be. Well, you can know what they all are by looking at the algorithm and saying, here are all my choices. But what should they be? What should the values be? Which ones should you even tweak? Some of them you could just leave the defaults and call it a day. Others you might want to modify, but what do you modify them to? What value do you put in there? and is kind of somewhat seemingly arbitrary because it's just all part of the overall calculation. Again, what does the effect of having a bigger or smaller learning rate have? Too big and you miss your mark, right? So too small and you're taking forever. What's the difference, in the outcomes of mini batch gradient descent versus stochastic gradient descent? In mini batch, do I do batch sizes of 10 or 1,000? Those can have big impacts on the outcome. So it's a lot of guessing sometimes. So there's a couple of strategies or methods to tune these. First off, so there's what we call grid search. And the idea of grid search is you pick two hyperparameters. So again, first off, something this isn't even really bringing up is you also have to pick two hyperparameters. Okay, so there might be 20 to choose from, 30 to choose from, and you're going to say, look, I'm just going to try and hone in my efforts around like one or two. Okay, if you're just imagine if you have a wall of switchboards and you're trying to control something with them, and you just start randomly flipping all the different switches, and then you go, well, that didn't work. Well, let me randomly flip them all again. It's not going to work for you. Okay. At some point you have to say, all right, let me just see what happens when I flip this one switch on or off. Right. Well, let me see what happens when I switch these two in combination with each other and kind of find different combinations of the two. That's going to be a lot more efficient than trying to just mess with them all. Okay. And so you can experiment with this and play with them, find different parameters, hyperparameters that you might decide to tune and tweak. But at some point you need to hone in and just kind of focus on a couple at a time. Okay. So pick two and then make a grid out of them basically. Right. So just for the sake of easy discussion, imagine if these lines are whole numbers. So, we have like 0, 1, 2, 3, 4, 5. And then we've also got, I'm drawing along the top because the bottom there has writing on it. 0, 1, 2, 3, 4, and 5, right? Something like that. So, of course, 0 and 1 or 0 and 0, we don't have dots there, but you get the idea. 0 and 1, 0 and 2, 0 and 3, find those combinations, and then you go, 1 and 1, 1 and 2, and then 2 and 1, 2 and 2, 2 and 3. You get the idea. Okay. So you end up with these grids. And so you try the different combinations. I want to point out what we're really talking about here, just to level set here, because some of you might be lost. Like, what are we really talking about? Each one of these will produce a model. Okay. So you're going to set these settings. And you're going to say, okay, those settings right there, that combination of settings, let's produce a model. And then this combination of settings and produce a model. This combination of settings and produce a model, right? We're training each time. And we're looking at the outcomes. And we're going to evaluate the outcomes using our evaluation methods like, accuracy or R squared if it's regressive or regression rather, so and so on. So each one of these dots results in a training process with a model being produced that may or may not be any good. Okay. The problem with grid search is a couple of things. It is very thorough in that you're kind of going through each setting, right? But it's extremely inefficient. You're making tons of models here. And here's the next problem. What if my optimal setting is like right there? Okay. Where I just drew that red dot. I'm never going to hit it, am I? Right. I might find something close. In fact, chances are that one maybe is where we end up finding our best results. Maybe. I say maybe because I actually have seen cases where just mathematically, let's say our best option is right there, but we're never going to touch it. And this one is actually really bad. Even though it doesn't seem like it's very far off visually here, it is different number values. And those algorithmically do have an impact that's, you can't just assume because it's close to that is correct. We may actually find because we never actually hit that value that the best value is actually over there. The best combination. I've seen things like that occur. So just don't assume, right? but in all reality, the actual may not ever be touched here. The actual best may never be reached because the grid is very precise. So maybe these are only whole numbers, but it's actually going to be a decimal that is going to be the right one, or the best, most optimal, right? So random search is, as the name implies, random combinations of these two hyperparameters, and you kind of just try a bunch of random combinations of these two. Statistically speaking, this actually has proven to find the best options fastest. Okay. And in some cases, straight up just the best option, not just fast. I mean, even if it's not faster, it's typically going to hone in on the best options, mostly because the grid is just so mundane in the way that it does it, that normally this strategy takes so darn long that the gaps between each one of these settings here, people will make really large, right? And so you're going to miss a lot of optimal setting combinations. And don't forget, this is probably going to be, maybe a setting it's a combination. It's a combination between the two that we also have to think about. It's not just that we, like I said, how maybe this right here is the optimal on grid there, that's the optimal, actual optimal that we never touch. It doesn't mean that under all conditions that, if this is 2 like that, that 2 should always be this hyperparameters setting. It doesn't mean that. It's a combination. 2 in conjunction with hyperparameter 1's setting, in fact, let me just, less confusion here. Let's just hone in and say that right there is in fact the best option. Okay. And again, 0, 1, 2, 3, 0, 1, 2, 3, 4. We are not saying that hyperparameter 1 set at 4 is always the right setting, or that hyperparameter 2 set at 3 is the right setting. We are saying that when combined with each other, 4 and 3 are the right settings. Okay. That's what's interesting, is one impacts the other probably, right? And so as you adjust one, the other needs to be adjusted. So under another condition with maybe a different hyperparameter, or if we adjust hyperparameter 2 to a different value, then hyperparameter 1's optimal value might be different, right? So it's always this kind of give and take. And so random is more likely to hit closer to a value that is optimal, because rarely would our optimal value be right at this intersection point. And so by doing random, statistically speaking, we actually get better results, ironically enough. So random grid is not even an option in SageMaker. Little side note on this, because it is so inefficient, that statistically we're better off just going with random. So random is one of the options. And then there's a third option called Bayesian search. Bayesian search actually uses mathematical regressions to actually hone in on the proper answer, right? What makes the best settings here. Again, recap, we are talking about combination of settings for the model training process. What combination of settings is ideal? We don't know. So we're going to run it through a system where we create a model, and we look at those setting values, and whichever one produces the model that is best is the settings that we're going to use. Okay. So whether we do that through grid, random, or Bayesian. Bayesian, like I said, is actually the most, really kind of the most intelligent. It's going to make initial guesses and then use regressions to refine those. It doesn't mean it's perfect, because it's kind of still based on those initial guesses, right? Because it's using the initial guesses and then regressions, assuming that the initial guesses might have been close, maybe, right? But maybe they were way off. And so, yeah, we're honing in on the best within that guess range, if that makes sense, right? Whereas in all reality, the best still may have been totally different. So I'm going to show you how this kind of plays out with SageMaker and how we can kind of play with this. but ultimately it's what we call automatic hyperparameter tuning. What ultimately it's doing, yeah, so Genevieve, this is always comparing two parameters. Yeah, only two, because like I said, you put too many in there and the combinations are just out of control, right? Just mathematically, as soon as you introduce a third, even the combination values, again, we're talking, decimals and some very, very fine numbers that can have massive impacts on the outcomes. And two is plenty. So no, these systems are always just really kind of comparing two hyperparameters, typically speaking. Now, can we do more than that? Yeah, but typically we would want to do those in multiple phases, if you will, right? So compare two and then compare two, and now you're ultimately comparing 3 or 4, right? So I could compare two and then do a whole different job of comparing completely different two, or maybe I compare two and then do another job where I'm comparing two, but one of the values is different, or one of the parameters is different, right? So they may share a common parameter, but things like that, right? Yeah, exactly. Yeah, A and B, and then B and C, that kind of thing. So you could play around with that. Technically speaking, you can play with more than two, but now you've got this really complex scenario where it's usually going to backfire on you, right? Okay, so SageMaker's automated hyperparameter tuning. So ultimately what it's doing is you create a hyperparameter tuning job, and that tuning job actually does a bunch of training jobs. It spawns these training jobs for you, compares the outcome. So this is where there was a discussion a couple days ago, I think. The question was asked, how do we know what our target should be? How do we know if it's getting better or worse, right? Well, we're going to give it that value. We're going to tell it what metric to pay attention to. And do we want that metric to get bigger or smaller, kind of a thing, right? And so all of these training jobs are running. It's trying some values. It's running the training job. It's looking at the outcome of the training job. Did that number get better or worse? Make an adjustment to the hyperparameter settings, do another training job with new settings, and kind of see, did it get better or worse, right? And that kind of thing. And what it'll do is it'll spawn a whole bunch of these training jobs on your behalf and just ultimately tell you what the proper settings should be for those two hyperparameters. You will get varying results because I can do this once, let's say I do one hyperparameter tuning job with 10 training jobs. So it does this 10 times. Don't forget, let's say I choose Bayesian, right? The initial guess may influence this quite a bit. So the second time I do a hyperparameter tuning job and I run 10 jobs, I may actually get very different numbers. But at some point, I'm going to notice that I've kind of reached the best. Okay. And I'll show you this firsthand and how this works. Okay. But ultimately, this is we call it an objective metric. This is what we consider good. This is considering the metric we care about getting either higher or lower. Okay. So in this example, we say, okay, objective metric, area under the curve. I want this to be the minimum. So run this process until the minimum is achieved. Okay. And whichever training job with whichever values achieves the lowest, that's what we're going to go with. Okay. So then we could use those values. Now, here's the thing, because it is producing a training job or many training jobs here, whichever training job had those values, you could just use that model if you wanted to. So this will actually produce a usable model when it's all done. But you could also take the values that it created or that it utilized in the hyperparameters and stash those aside so that future models you decide to create using fresh data. So let's say you want to refresh the model and you just want to use new data. You could use those values now without having to do hyperparameter tuning each time, right? You just say, okay, I've got those values. I already kind of know what's ideal here. Let's run some new data through the training process using those values and create a new fresh model using all the same settings. Okay, so that's kind of how this would typically play out in real life. Okay, we'll show you this firsthand. First off, tuning doesn't always improve your model. There's no guarantees that this is going to make things better. You could just use all the defaults and call it a day. and then do a bunch of tuning and realize you didn't do anything any different. So, you know, it was wasted effort, if you will, but you got to try. Okay. You know, I should back that statement up. You don't have to try. If you're achieving your business requirements and your model looks pretty darn good out of the box, you know, just right away, I don't know if I'd spend the effort to tune it, right? But if you're looking at it going, it's good, but it could be better, maybe we try some tuning and just see, you know. So some best practices, again, don't adjust every hyperparameter, limit your range of values to what's most effective. So you notice here the word values. So when you have a particular hyperparameter, you're going to have a range, and you're going to specify that range that you want the system to kind of hone in on. So it's not open-ended, right? You don't want the parameter values to, you don't want it to just try, like, let's say you're doing random. You don't want it to try a value of 1 and then a value of 10,000, you know, and then a value of 50 and a value of 1,500 and kind of bouncing all over the place, right? I would give it a range of maybe, you know, 0 through 10, you know, or something like that. Kind of try different ranges, but you're kind of honing it in so that you can say, okay, within this range, find what's best. And this is where there's still some experience needed, even with automatic hyperparameter tuning, to understand what ranges are good. And experimentation is going to help you learn that, right? So you may not know the actual proper value that it should be, but you may know kind of a general range of what's ideal. So take a mini batch gradient descent. You know, maybe you've learned over time, especially with your data sets and things like that that you're working with, that, you know, some kind of batch size between 100 and 500. I just don't know exactly what it needs to be, but I'm not going to do batch sizes of 10,000, and I don't want to do batch sizes of 5. You know, so I kind of learn what's ideal, you know, kind of over time. And that's just experience. Okay. And that's just experiment, trial and error kind of stuff you'll learn over time. Okay. Run one training job at a time rather than parallel. Let me discuss this one real quick for you here. This one's a pretty good one, pretty confusing one. This is considering what we would say is a best practice. Okay. Now, do you always have to do best practices? Maybe not. Let me explain this one real quick. So just think mathematically, put kind of like a math hat on for just a second here. In fact, let me just kind of draw this out. It might help make this make a little more sense. Let's say I want to run 10 separate jobs, testing 10 separate values, right? If I do them in series with one another, and what I mean is you do one training job, get the results of that training job, and then do the next. Okay. So really what you end up with is, you know, training job 1 to 2 to 3 to 4 and so on, right? The results of training job 1 get fed into 2, and then the results of 2 get fed into 3 and so on. Okay. And what we mean by results, we take the answer, you know, of our settings, and we look at this, you know, objective metric, and we say, here's our objective metric. Then we make an adjustment, and that adjustment may make it better or worse. And so we're going to learn that after each and every training job. After each and every training job, we're going to learn if we made it better or worse. There is an option to do this in parallel. So what if I say I want to do 10 training jobs, but I'm going to do 3 jobs and take the results of all 3 and launch 3 more, and take the results of all 3 of those and launch 3 more. Okay. What are we doing here? We've just launched 9 total jobs in the time it took us to do 3. Okay. Because they're in parallel, all 3 run at the same time. Now there's a good and bad to this. The option, I'm going to draw a line here. The one up top here, where I did not do them in parallel, I will probably find a better answer, a more accurate answer, I should say, because I'm only doing one job, looking at the settings and adjusting, doing another job, running the settings and adjusting. And so I effectively get 9 adjustments along the way with 10 models, right? Here, I've only got 3 adjustments that we can make along the way. Does it make sense? Actually, 2 adjustments, excuse me. So we go from 9 adjustments to 2 adjustments. Granted, I'm only doing 9 jobs here, not 10. So let's just say they're both doing 9. Okay, just for sake of even. So so that means that the one above has 8 adjustments, the one down below only has 2. Now, so what it's going to do is it's going to look at these, and let's just say the value of these first run value is 5, 10, and 1. Okay, they're all 3 values, 1, 5, and 10, and we're trying to go with the minimum, right? Well, it's going to go, oh, wait a second. This one down here, that got a value of 1. Okay, it's supposed to be V, a V1. Okay, so it got a value of 1. So let's use this value as kind of a starting point for our next one here, right? So now the next 3, maybe it tries a value of 0.5 2, because I mean, you see that just because 1 was best doesn't mean 1 is best. I mean, we only tried 10 up here, so maybe also it tries 5. Okay, and so it's having to make some more guesses along the way. It's not able to just hone in faster, right? Whereas up top here, we try we try one direction, we go, oh, we went the wrong way, go the other. And we're not having to just randomly kind of try each time, each phase kind of within the scope. We just do one at a time. So I'm going to kind of leave it at that. This gets a little bit confusing, but ultimately the chances to make an adjustment are less with parallel. Okay, I'm just going to kind of summarize it there. The chances to make an adjustment are less. So we're still going to try variations each time. We're going to try 3 variations and see which one's best, and then try 3 more variations and see which one's best, as opposed to try 1, adjust, try 1, adjust, try 1, adjust, try 1, adjust. So even though both of them only produce 9 models, the one up top is probably going to produce the most accurate model, but in a lot more time. So the one down below is going to do it in the time it took to only do 3 models, not the time it takes to do 9. So time versus ideal setting, I have found a lot of times that this option down here gets us close enough in a much faster time period. The cost is the same because 9 models versus 9 models, same charge. Okay, but I got it done in a third of the time, and that can make a difference when you're experimenting a lot. I get my answer pretty quickly. I can go back and try some other things and do it all over again. And in the course of an afternoon, I might get a lot more work done by doing it in parallel and still getting close enough. Now, I like to play around with this and kind of prove it. I'll do it 9 in series, and I'll do 9 in parallel where I'm doing 3, 3, and 3, and see how far off did my objective metric actually get. If I'm still pretty darn close between the two, kind of shows you that, yeah, I might be a little bit more precise with the top option, but was it worth the extra time? Okay, so that's kind of what I'm getting at with this bullet is if you have the time, do them in series. If it doesn't matter, if you're just going to kick it off and you're going to be done for the day and you're going to go home, or you're going to, shut off your computer for the day and check out what it looked like in the morning, just do one at a time. But if you're trying to get as much done as you can in a short window of time, I would probably say parallel can be a benefit there too. But I wouldn't do 10 in parallel, because then none of them got a chance to actually feed into one another. So if I'm just doing 9 or 10 models, I don't want to do them all in parallel, right? I would still want to do a couple of chances to allow it to make adjustments, right? Otherwise, it's not really doing what we want it to do. Okay. In distributed training jobs. Now, I want to point out this word distributed, very important, right? Distributed means that the training job is actually taking place across nodes. This also means that I'm using an algorithm that supports that, and many do not. Most do not, actually. Okay. So the thing about distributed training jobs too is if I select an objective metric in my hyperparameter tuning, but that objective metric is actually not reported back in the distributed way, So in other words, each node may actually not be reporting this. It may be reporting something else. Then I can't really use that metric, but I might select it, but it's not going to help me because it's not actually reporting that back properly, right? So when you're bottom line, if you're doing distributed training jobs, there's going to be a little bit more work you're going to have to do here to make sure that you're not leading yourself astray, you know. Convert log scaled hyperparameters to linear scaled if you can. Okay, but you know, it's just a little suggestion there. Let's demo this all out for you so you get a chance to actually see this stuff in practice. Okay. So we're going to come down here to training and I'm going to do hyperparameter tuning jobs. Now, like I said, I've been using this account for my machine learning stuff. This particular demo account I've got set up. I've got a bunch of them. I do this one with a lot of my ML classes. So I've actually already got different other previous past training jobs I've done in here. And so I'm actually going to look at those and kind of show you some things. But here's one I ran this morning before we started class. Okay, so it was running. And look at this. It took an hour to run because I did 9 jobs in series. Okay, I did not do any parallel. I did not do anything in parallel. So it took a full hour for me to get my answers off of 9 jobs. I want to point out, look at this one. I did this job back in September, and I ran 15 jobs here. I'm wanting to say I probably did this with pools of 5 jobs each. I mean, I can go dig into it here. We can see. Yeah, it looks like there's 5 here that ran at the same time, right? So 5 at a time times 3 chunks, if you will, took 16 minutes. So I got 15 jobs run here in about a quarter of the time. It took 9 to run up here. And interestingly enough, I'm not going to show you the values right now, but this one actually got the best result and it got it in 16 minutes. I didn't have to do 15 though. You notice right here, I did 9 as well. And that one's in 16 minutes versus an hour. So, you know, I did this so that you can kind of see the comparison in time. So if something only takes me 16 minutes to run nine jobs, nine training jobs, right? So it's don't forget, it's actually performing a trained model here using different hyperparameter settings each time for me on my behalf, and honing in on what the best settings might be. It did that 9 times in 16 minutes. So I go get some coffee, you know, come back and it's done. It's ready to go. And I can move on and I can go do more experimentation and try more things. This one up here may not have been as accurate. Excuse me, may have been more accurate. I say may very loosely because it may not have been, but it may have been more accurate, but it took a full hour. Now, imagine if I have to do a bunch of tasks throughout the day and I'm waiting on this thing to finish before I can take my next step because I need the values from it, right? Now I've got big intervals. And I think this is a big factor no one really talks about is, you know, it's time. Time matters to business. Time matters to what we're doing. We don't have unlimited time, okay? So yes, the ideal best practice is to do them one at a time if you have the time, okay? But that's not always going to be ideal in the real work scenario, right? Okay, so I ran this one this morning. I'm going to go through and just like we did with the training job, let's go create one and do this ourselves right now. And while it's running, we'll go look at the results that I did earlier. I did this one before class so that I knew it could run for a long time. Right, I didn't have to sit. I mean, there's no way I want to do this as a demo and have you wait an hour for us to see the results. So I did this one, but the one we're going to do now is going to be different than this one. I'm going to go ahead and do it with batches, if you will, and I'm going to do some stuff in parallel, and we'll kind of compare the results. Okay, that'll be 16 minutes or approximately, you know, somewhere in this 15 to 20 minute range, probably to complete 9 in the time period, to complete those 9, but we're not going to wait the full time. We'll come back and check on it later in the day, probably. But let's go ahead and create one real quick here. Okay. So first off, there's this optional setting. It's actually fairly new. It's called warm start. It's kind of cool. You can use the results of a previous tuning job. I want to point out, it doesn't say training. It says tuning. The reason this is important is a previous hyperparameter tuning job may have come up with some answers, some predicted, I shouldn't say word predicted. It came up with some estimated hyperparameter settings that seem to be the best. I say estimated because if I say do 10 jobs, it's going to take the best one of the 10. It doesn't mean it is the best. I still may do this a couple more times, or I may do a little bit more experimentation to realize that maybe it wasn't the best. Okay. Maybe I adjust my ranges, or who knows. Okay. So let's give this thing a name. Actually, before I do this, I like to try and keep my namings the same. So I'm actually going to create hyperparameters. I'm going to do this in a new tab so I can go back and forth. Okay. So I'm going to copy this, give it a name. This time, I'm going to call it live. Kind of like what I did yesterday. That should work in theory. Sometimes you end up with too long, like because it adds this name to the name of the training jobs. So it could get too long. If you make this really long, then you end up with a limit, and it'll tell you. So it says right here the name must be from 1 to 32 characters. So I'm hoping that didn't make it too long. We'll see. It'll give me an error if it is. In fact, let me just see, is it going to error out here in the browser? Probably not until I hit next. Okay, we'll find out. Early stopping. So the idea here is if it keeps making adjustments and your objective metric is not getting better, let's not just keep going. Okay. So in other words, what if I tell it to do 50 training jobs or 100 training jobs, and it's just going to keep on going, right? So if 10 training jobs in, it's pretty much gotten to the lowest objective metric it seems like it can get to. It's just going to keep trying new values, but the objective metric just keeps getting worse and then better again, but not better than what we found. Then at some point we might want to tell it, just cut it off, just stop, right? That'll save me money and time. So you could say auto at that point and just kind of let it make its own decision around that. Okay. Tuning strategy. We talked about this, right? The grid is not on here because it's just a waste of resources. So random statistically is better than grid. And then you have Bayesian, which again is going to apply regressions to its estimates to try and hone in on the right answer. Not always saying Bayesian is always better than random. I mean, you could try both and kind of see, So then we're basically creating this hyperparameter tuning job. Within this job, we're going to define what our training job needs to look like. So I'm going to add that training job here. And so this is where the training job, I'm just going to kind of, like I said, keep with the naming standards. Let me see what I did earlier for this. HP demo. Yeah, I guess that's what HP for hyperparameter tuning. So let's come back over here. I'm just going to say LD for live, just make it a little shorter, live demo. I'm going to give it permissions. I'm not going to worry about special network settings and stuff for this. It doesn't really need to be addressed. Algorithm. We're going to actually do the same training jobs we did yesterday on my demo. So I used linear learner yesterday, so we're just going to kind of stick with that. And then we'll do streaming, or we'll do piping rather, when we get down to the input channels, right? So we're going to come down. These right here, remember, these are all metrics. So these are metrics we can actually use for our hyperparameter to use as an objective metric. Okay. So my objective metric for this particular task, let me see, I put it in my notes, make sure I keep it consistent. Hyperparameter tuning. What did I use for my objective metric? Let me just make sure. Validation objective loss. Okay. So right here, this one. So this is just the metric I'm saying this. I want to get this objective loss to the minimum through my validation process. So again, the validation data, I want that objective loss to be minimized. All right. Now here's all my hyperparameters that I could potentially have it try and play with, if you will. Okay. Now what we're going to do is, in this case, I'm going to keep with a lot of the same stuff we did earlier for the regular training job. So that's just an actual value. I'm saying let's not do hyperparameter tuning on this. That we're just setting that. So there's a few things we're just going to set. This is a multi-class classifier, and we did classes of 10 classes. And again, this is just what we did yesterday. Okay, so that's just fixed values, no ranges there, right? But what I'm going to go ahead and do is try and get it to find a good mini batch size and a good learning rate. So I think batch size was up here. Let's see, batch size right here. So I want to actually have it find a batch size, and I'm going to give it a range of 200 to 500. Now, again, what is this? Remember that mini batch sizes, to recap what that is, it allows, instead of having to do the entire epoch or the entire data set before it can adjust the weights during the training process, it's going to do a smaller subset of records and then adjust the weights each time. So what's the right size of that batch? Is it going to be 200? Is it going to be 300, 400? Is it going to be someplace in the middle? Find that ideal number here for me. Okay, so this is the one range that I'm going to have it look for, and I'm going to give it a range to try within. So this is where, again, playing with these range values, kind of learning what's good values to test within, just kind of comes with practice and experimentation. Okay, maybe the ideal value right now is actually 50, and I'm omitting that, right? So that's the thing you have to kind of understand, is that I'm going to try and hone in this hyperparameter tuning job, but maybe I do another one and try a completely different range as well. You know, so kind of keep that in mind too. I'm not stuck with just this one choice. I could have many different experiments that I run, right? And then the other hyperparameter I want to go ahead and play with is the learning rate. So we're going to find that. I think that's down here. My memory serves me right. I hate that it's not in alphabetical order. It always drives me crazy. I'm sure I'm passing it. Oh, it's right in the middle, it looks like. Okay, it's right there. Yeah. So I'm going to give this a range of 0.001 to 0.1. That's actually quite a big range, isn't it? Right. So I'm going to do that. All right. So that's my learning rate range. And again, you can look through recommendations that are out there, blogs, documentation, all kinds of things as to what, you know, good values might be. But again, just experiment too, and you'll kind of learn that for yourself. All right. So come down here. I'm going to go ahead and just do those two values. Okay. The other static values, it's not trying to do anything with. I entered, you know, feature dimensions and number of classes. I just put those in as my own settings, and that's that. Hyperparameter tuning is not going to try and mess with those. All right. So then I have my, again, I'm working on my training job settings right now. So each training job is going to be doing these things, right? And so we have a train channel. I'm going to go ahead and pipe that text CSV for my content type. We did that yesterday. And then bucket location of the training data. So I'm just going to copy from my notes here where I'm storing that data. Put that in there. I'm going to add a channel, my validation channel. So again, I'm going to call this validation, no typos, validation, looks good. Pipe. We're starting to understand what some of this stuff means now, right? What the pipe means. And this is just specifying what the input is, basically what kind of file type it is, right? Is it going to be that record protobuf, or is it going to be CSV, right? And then I'm going to put my validation data in here. Okay, good. We're not going to bother with checkpoints, and I need a place to output it. So I'm going to put this in my S3 bucket here. Okay, and we'll go next. All right, so this is going to define the resources for the individual training job. So just like before, I'm giving it an M4 extra large, one instance, not giving it extra storage and all that. Stopping condition, I like to do something on this example. It should never run more than like 4 or 5 minutes max for the training duration. So I'm just going to set it at like 15 minutes. That should be fine. So there is my actual training job, the training job. keep in mind, which is inside of the hyperparameter tuning job. Now, I'm going to specify how many parallel training jobs I want it to run. So this is where normally, best practice, if you have the time, I could say go ahead and run 9 and really no parallelism, right? We're not going to do that for this demo. I'm going to actually change this to 3 parallel training jobs, and we're going to say a total of 9. Okay. So each, this is the total maximum training jobs is the total number of training jobs it can run. And then the parallel, it can run 3 at a time. So this will run 3 cycles basically until it reaches 9. Okay. But I mean, I could put, tons in here. I could put 50, put 100. Look at this. Maximum is 500. 500 times. Okay. If I do that, I might want a little more parallelism, something like that, but I'm not going to do that. For the sake of demo, we got to go a little faster than that. Okay. And so we're going to go ahead and do that. And now we'll kind of just review what we've done. So I've given it a name. I'm using Bayesian. Here is my training job definition. And I'm only doing 1 instance because it's not a distributed algorithm. I can only do 1 anyways with linear learners, so that's fine. Maximum of 3 parallel training jobs with a total. Oh, did I there we go. Good thing I was reviewing it. That's not right. 9. Let's fix that. Okay. That's why you review. Okay. Otherwise, this would have just run 3 and then been done, and we probably wouldn't have really gotten a good answer, because what it would have done is it would have tried 3 random values basically. Remember, Bayesian, it's doing random first and then it's honing in. And so it would have done 3 jobs in parallel, each one with a random value, and just said which of these is better. And it would have given us the best of the 3. It doesn't mean we did any kind of real work though. It really just randomly tried 3 values. It didn't actually apply the Bayesian process to it, and it didn't try and adjust at all, right? So there we go. So we're going to go and create this, and it should kick off if I did everything right. Okay. So that is going. This is the one I did earlier. And let's take a look. I haven't looked at the results yet. So this is blind to me. So let's come in here and we'll see this objective metric value. I'm trying to get this to the lowest possible value. You notice some of them, look at this. This one's way up there. Okay. It went the wrong direction, obviously. So whoa, okay, that's not good. Go the other way. So what's the best one here? I mean, we can of course visually look and see, but in all reality, if you just come over here, it'll tell you the best. And of course, programmatically, you can have it tell you the best. So the best one is with a objective metric value of 0.223 right there. Okay. So this was the best objective metric of with this validation objective loss value we got. Okay. This is the best one. All right. Using this learning rate and this mini batch size. Okay. I want to show you something here real quick. We're going to leave this up on the screen here. And I'm going to come back to my tuning jobs, and I want to show you one. I keep a lot of my old ones just so I can kind of go back and poke around and look at them. There's no reason to clean these up. They're not costing me any money. They're just, they're just there. So I don't try and filter them out or anything like that. I mean, technically there's not really a delete. I don't believe but I don't even try and filter them or anything from my view, because they're kind of handy to look at. Now there's this one right here. This one was a shocker to me when I was teaching a class back in September. It was the first time I'd ever achieved the result I got out of this. Take a look at this one. You look at all these values here. We got 0.88. We got 1.5 is way off. Is this the one? Maybe I'm clicked on the wrong one. Let me just see best training job. Okay, no, this isn't the one. That's a 0.22 value. So sorry, I went at the wrong one. Let me find the right one. It was right here, November. This is the one. It ended in just demo, so I thought it was that one, but it's this one right here, the November one. So this is the one. Look at this, 0.18. Now I know that this may not mean much to you, but I have run this demo, gosh, I mean, I've been teaching this class a while. I probably, and including time in class and outside of class, playing around, it's probably at least 100 times, if not more. And I never seem to be able to get below like 0.22. In this one class, I did this demo. This was during class live. And I looked at this and was like, oh my gosh, I breached the 0.2 mark. You know, I got below it. So this was really good. Look at the settings here. Look at these settings. Learning rate, 0.04 and mini batch size of 493. This is what I was talking about, how if we come back and look at this other one over here, this is the one I left up that we did, that I did before class. This one says the mini batch size should be 226. This is why I was saying it's about the combination of your settings. 226 versus 493, pretty big difference here. And by the way, these are both using the same settings. When I did the hyperparameter tuning job, they were both using that range of 200 to 500. So it's within that, right? So this is at the low end of that range, and this other one was at the high end of this range. So the one that got the best value was almost near that 500 range, right? Meanwhile, the learning rate, 0.0405 versus 0.08923. So it's the combination of these two things that ultimately is going to result in some algorithmic effect, right? Keep that in mind, that these are values going into the model training process. It's going to affect how it learns, right? Again, the learning rate is the size of the step, while the mini batch size is the size of the data set that it's using, right? Out of your whole data set, how often does it adjust the weights? Okay. So so this one was kind of cool to me. And I like that, you know, look how far off it is. It kind of illustrates that point, that don't just think, okay, we've now discovered the perfect mini batch size. Not necessarily. And in fact, I might adjust a third hyperparameter somewhere and suddenly all things change, right? It might give you something to start with, but just know that, you know, it's not a magic number. Okay. It's about a combination of these settings, and they all influence one another. Okay. My learning rate, again, is the step that I take in my adjustments. And how often do I make that adjustment? Well, I'm making that adjustment in between each mini batch size. So you can kind of see how these correlate with one another, right? So if my mini batch size is smaller, I'm adjusting more often with fewer records. And my learning rate is the size of the jump. Okay. So when I make the adjustment, what's the new value going to be? How big of a new value jump do I need to make? Right. And so these directly influence one another. So as one changes, the other has to change, right, to get to an optimal outcome. All right. So anyhow, just kind of wanted to share that one with you. So come back to the main hyperparameter tuning jobs page. This one's still running. We got, why did I say 5? Did I tell it 5? What did I do here? I totally must have messed this up. I could have swore I checked that. Unless maybe it's because it's still running. Maybe I'm reading it wrong. Oh, okay. Yeah, that's right. Okay. It's just because it's only working on 5. 2 have been completed. It's working on 3 more. So of 5 at the moment. It's not done yet. Okay. So we'll let that one just continue to run. So anyhow, you know, the idea here is trying to finding the right values. That's what it comes down to. We'll just let this one run. It's been going for 7 minutes approximately. We'll come in and check on that here in a little bit, right? But the main thing here is don't try and tune these hyperparameters yourself. Don't be overwhelmed with figuring out what values they need to be. Just try, experiment, let the system try and identify these for you. If I come back to these ones that I did before, this November one, I want to show you this real quick. So the best objective metric that we found right here was this one right here. And again, like that's the best out of years of teaching this class. That's the best one I ever came across. And it was just back in November. So we go into this here and you'll notice that if I scroll down here, the model artifact So I've got this in a bucket. I don't think I've deleted it. So I can go ahead and use this model right here, and send new data through it with that objective metric. Now, here's with that with all those settings, those were used to train the model. So those have been used for this model. Now, what I would probably do then is moving forward. This was back in November. Maybe the data has evolved, right? Maybe people have evolved and patterns have evolved, whatever. So what I might do is create a refresh of this model today. I could go through and do a refresh of this model using all the same settings. So I would come in, I wouldn't bother doing the hyperparameter tuning again necessarily. I mean, if I want to occasionally experiment, I could. But what I'd probably just make sure I do is use these hyperparameters. And again, the ones that it came up with, 493 and the learning rate right here. I would make sure I use those two values using fresh data and do a fresh training job. That's all I would have to do. Nothing too earth shattering. I just say, let's go ahead and take January data now, retrain the model using January data, not data back from November, and use these values to train and produce a model, and I'm done. Okay, and that model just takes a couple minutes. Okay, so so that's what I would do to refresh it. I wouldn't have to worry about doing hyperparameter tuning each and every time. This is maybe when I'm trying to first find out what the right settings should be for my model. Okay. So so there you go. All right. Any questions on any of this stuff? I'm sure some of you, your heads are just spinning. It depends on, your backgrounds on some of this and how new you are to it. Any thoughts, questions, feedback? No. Okay. I'll take the silences. You're good to go. Good to move on. So this is still running. We'll check in on this a little later on in the day. I think I'll just kind of let it be. You're going to do this stuff in your own labs as well. Okay. So Kip, yeah, we talked about this one, about the hyperparameters. Just think of combinations, right? So going back to the only altering two, you don't want to alter a whole lot of hyperparameters. Okay. So I used this example earlier. I'll kind of repeat it. Imagine you were physically at like some sort of switchboard, okay? And you had all these switches that could do all kinds of things. And that's basically what these things are, right? Switches and knobs and dials and stuff, right? Some are on and off. Some will be a dial that could be at some setting. And let's say I've got a wall of 30 different knobs and switches. And I just randomly change a bunch of them and then go do the work. And I come back and I go, I think the number can be better. Now let's just randomly change a bunch more. And it gets better. Can you tell me what exact combination caused it to get better? Probably not. Even mathematically, even scientifically, you're not going to be able to understand this because it's a combination of these settings, right? As I mentioned, one setting influences another. So what I'd rather do is take a much more methodical approach here and have this wall of settings, but hone in on one or two of them. Really just kind of pick two because it's a combination of the two, or combination of all of your settings, really. But hone in on like two and figure out what the right combination of those settings would be. It's going to be a lot more scientific, right? It's not just going to be like randomly setting everything and hoping that it looks good. And then if that doesn't look good, randomly setting it again, going all over the place, right? You got to have some sort of methodical approach to this. And so it's really about that intersection, right? And so, yeah, you could tune more. You could absolutely tune more. But because they all influence each other, let's just say I tune two of them. And then I go back and I do another hyperparameter tuning job to find the right settings for two more. If those two more are adjusted, is it possible that they also affect the first two? And this is where it gets a little crazy. There's no can or can't here. Okay. Do whatever you want. Experiment. Okay. You may magically find the right combination. But my point is, now you find the right settings for two more. It doesn't mean that the first two should remain the same. So now what I might do is, and this is where, again, a lot of experimentation might come into play, is I might go back to the first two, use the ideal settings of the next two, and just hard code them. The ones that I found through the hyperparameter tuning job, hard code them, and then start adjusting the other two and seeing if we can make it better, right? Or kind of just go back and forth like that, and kind of keep iterating across that process. But just know that what's ideal with the first two, as soon as I adjust the other two, it might make the first two settings bad, if you will. So you got to kind of play around with that. So the point is, are you getting better or worse? That's all we really care about at the end of the day, is our tuning effort making it better or worse? So if you want to do the first two, so here, let's walk you through just to clarify this one, just kind of maybe hopefully take a little bit of the confusion out of this. So I've got this first training job that we did, okay? And this one was the one I did today. So it didn't get down to that 0.18, it's like 0.22 something. But let's just say I take the values from this. So I got 226 as my mini batch size and learning rate of 0.89, 0.089, so on, right? So I take this learning rate and our hard code. So let's say we go create a whole new hyperparameter tuning job using two completely different hyperparameters now. I will hard code this learning rate into that hyperparameter tuning job, and I will hard code this mini batch size into it so that these are now static and it's only going to try and adjust two. And we'll see, do we get better or not? Again, there's no guarantees that adjusting any of this stuff is going to make us better. So it's an experimentation process. So, but just logically think through how you're doing it. So I wouldn't want to go into that second hyperparameter tuning exercise with arbitrary learning and mini batch size numbers. I would want something with intelligence plugged in. So I would take these and hard code them into it and run a totally different hyperparameter tuning job, now trying to look at two other values. We should always pretty much focus on two, all right? Because again, three, the system will actually let us do more than two, I believe. I actually can't tell you the last time I tried because it's a nightmare. I mean, there's just way too many possible fluctuations there. If you just think mathematically about the number of combinations, right? When you have two numbers, your combinations of those numbers is a certain amount. And keep in mind, we're not talking whole values here. We're talking decimals. And then you add in a third number, and the possible combinations to that is amplified many, many, many times over. If you know the basic math between combinations, even whole numbers, when you do three, you have a lot more than you when you have two, right? So, and then four, of course, oh my gosh, right? So, but now we're not talking whole numbers. We're talking, decimals that can go out many decimal places. This can be really, really troublesome. So stick with two, but you could absolutely go and experiment some more and keep playing and see if other hyperparameters have different influences, and maybe you're able to get this number way lower, right? But if you don't get it better, at some point you got to say, all right, we've pretty much found our optimal, the best we're going to do right now. At the end of the day, you could probably always get better. But is it going to take you years to find that answer? And what does better actually result in? If at the end of the day, it means that out of 1 million predictions, I get one more right, was it really worth your efforts? So at some point, go back to that whole, are we meeting the business requirements? Let's not over-engineer this, and because you could go forever on this. You could literally go forever. There is no end. There is no end to this. The end is when you say you're done. The end is when you say you're at the end, So at some point, you got to draw a line in the sand and say, okay, that's good. Those tunings helped us. Awesome. We did something to make it better. Okay. If we're meeting the business requirements, then just move on. All right. That's kind of the way I do this. We got other work to do. Okay. All right. So hopefully that's making sense. I'm open. So this is also another one of those that can be a lot to take in. All right. So feature engineering was part of this conversation, right? We got into different techniques to handle numerical features. Again, we talked about some of these techniques. I want to point out, nothing we're talking about in here is the end of it. We're giving you some examples. Take like those scaling approaches, those different options. Those are just a few. There's a whole lot more out there, and a lot of your toolings, a lot of your libraries and whatnot, scikit-learn and whatnot. I mean, there's a lot more than what we covered. Okay. So we're just kind of giving you an idea that, yeah, there's these different techniques you can apply to these things. And you got to kind of think through what those different options might be and what might be the ideal option. And again, you don't have to just purely speculate. Science is not as precise as people like to give it credit for, right? A lot of science is, let's create a hypothesis, which is what? An educated guess, right? It's just an educated guess. Create a hypothesis and perform an experiment, which means let's go play around and see what the results are. It's a guess and check, right? So that's what we're doing here. I mean, at the end of the day, we're gonna have some education, some educated guesses being made here, but it's about playing around. I mean, you don't have to stress over this. Okay, this is about experimenting. This is about playing with some different numbers and seeing, did that make it better or worse? That's what we care about. Okay, at the end of the day, how you got there, I mean, I don't really care. If you got better, then awesome, you're better, right? And then again, one other just re-highlight is, do we need to get better, right? If we're meeting the business requirements and we feel like we've kind of put our due diligence in to be as good as we need to be, just stop. Okay, just move on. Like I said, there is no end to this. And there are people I've seen that just get really twitchy. Get really they like precision, and I understand that. That's the kind of mentality of a lot of people in this industry, right? I say the word precision loosely. I'm not meaning the definition of precision. I mean just they like to be precise in what they do, and if they feel like I could be better, I could be better. And so, like I said, suddenly they spend a week on something, and now out of a million predictions, they got one more right, and it's a marketing campaign, and it didn't, it just meant that it didn't even convert to a sale. Maybe, it just meant that you got to one more correct person, something like that. So understand the importance of what you're doing. Understand, do you have to get better? I would argue you're doing, medical life and death stuff, right? You're doing aviation stuff that could, lives can be at risk. I mean, you probably want to spend a lot more effort on this. But again, even then, you cannot have an end to this stuff. There is no end. You cannot go through all the combinations. You cannot go through all the combinations. If you look at those values that I was showing you, when it comes to like the hyperparameter tuning jobs and all of that, and look at this learning rate. Are we going to try every single possible decimal combination that exists? Are we going to try every single possible mini batch size that exists? Well, you can't. Numbers are infinite. So at some point, you have to say we've gotten as good as we're going to get. Okay. All right. So lab 4, the labs are spun up, ready for you. Again, I'm going to edit this page here. Now, today you have to change your S3 bucket name. Okay. So I'm going to change this just real quick here briefly. So upload your project file from yesterday, right? We are going to have you run your project, right? So there we go. So you're going to log into SageMaker. You're going to upload your SageMaker. You're going to go into your SageMaker notebook, right? And you're going to upload your project file from yesterday. You're going to modify the S3 bucket, and you're going to run the project. Now, again, same thing like yesterday. This one's going to take even longer to run. This is actually going to perform the training jobs that you did yesterday. It's going to do it all over again. Okay. So you got to run from the top down. You got to go all the way through all the cells until the end of lab 3 from yesterday. So find that mark, that kind of delineation point of where you ended yesterday. And then if you click on the cell below it and then say run all cells above, that's just kind of the easiest way to do it. And then just leave that tab open. And open a new, I like to just leave it open anyways, so you have less issues. Open a new tab and go into your exercise for the day, and it's going to be labeled PE-FE-HPO. Okay, so it is a personal exercise dealing with feature engineering and hyperparameter tuning. Okay, so go through that exercise. That exercise should take you about 40 minutes. Like I said in past exercises, please don't let this exercise hold you up for too terribly long. That will result in you getting less time for your project. So this is meant to teach you some things, but again, don't sit for half an hour on one step trying to figure out what they're doing. Okay, you get a chance to work with that in your project, and you'll be better off when you're trying to muck with the code and stuff yourself, anyways. Okay, then go ahead and apply that knowledge over to your project and work on your project. Okay, as far as timing goes, let me talk about that real quick. We are at 11:20. This obviously is going to include lunch. Okay, we're going to overlap with lunch. So I don't expect you to work during lunch, but in the past days, we've been taking an hour for lunch. If you want, I'm going to account for that hour, but some of you have needed more time than others during these project windows. So normally we try, like I said, estimated completion time is 2 hours for both of these tasks, right? For the personal exercise as well as your project. So I'll give 2 hours for it and an hour for lunch. So that's a 3-hour window. If you want to just reduce your lunch down to, let's say, a half an hour today, that gives you 2.5 hours in this window of time to work on things, right? So it gives you an extra half hour. So feel free to use that as you like, but we're going to reconvene in 3 hours. Okay. And just for easy numbers, really, it's going to be 3 hours and 8 minutes because we're at 11:22. I'm going to call it 11:30 for the sake of easy numbers. So 11:30 to 12:30 to 1:30 to 2:30. Okay. So that takes us out to 2:30. And then we'll have one topic left. We have one more conversation left and we're done. So we will probably end a little bit early in terms of our official class discussion. We're going to do, after that, we're going to do a little bit more on the study prep kind of stuff. We'll talk about the exam a bit more, and then we'll button up class. I am hoping we'll get out of class a little bit earlier than we have the past days, but we are going to try and leverage some of that time for exam prep discussion as well. Okay, so we'll still have a fairly full day. I do hope to get us out of here a little bit early, but I'm not going to promise that to you. Just it's possible. Okay, so so let's see you back here at 2:30. Use that time how you like. Take breaks when you need. Take your lunch however you like. I mean, if you want to only take a half hour for lunch or even 20 minutes, whatever suits you, that will give you more time to work. If you're one of those people that have been working faster and you're done earlier, you just get a little bit more time for lunch. Okay. So there we go. All right. So 3 hours from now, we'll reconvene. One final note I wanted to point out. Back to the discussion that was brought up with me yesterday. I was chatting about that, about the airline delayed flights project. And we got onto some topics. I was talking with an individual. We were talking about some topics about feature engineering, actually. Keep in mind, the past days, we have not done any feature engineering, okay? But the task at hand that we were supposed to do up until this point was to work with the data presented to us, not create features, not do any feature engineering. And that was by design. Keep in mind, in the proper pipeline process, you don't want to do feature engineering early. You might do some initial selection. Like, I mean, at the very beginning, you might say, look, we're going to throw out some of the obvious features that have no relevance. And we may throw out correlated, highly correlated features, maybe. Well, actually, we probably should, even in the first phase. But after that, we're not going to really do true feature engineering. We're going to just create our model, and we're going to kind of use that as a starting point. Because how do you know you're making it better if you don't have a starting point? Some people will jump in and start doing feature engineering on that very first part of the phase. And so I want to highlight this before we let you go, because I want you in the right mindset with all of this. You know, if you look back at the pipeline here, this is why we reserve feature engineering for the end, right? We do it back here after you've already done an initial tuning, or excuse me, after you've already done an initial training job, right? So we do this on purpose. We don't want you doing feature engineering too soon, because now you're going to introduce bias potentially and not know it, because you're engineering features without a baseline. Okay. You've got to create a baseline first. So that's why we go through this whole process and then engineer our features, which is where we're at now. Okay. So like I said, there was conversations that I was having yesterday with people about things you could do with the data. And I completely agree, but you shouldn't have done it yesterday or the day before. You should have been waiting and holding back and reserving, because that's by design. Yes, there's more you could do with the data. Yes, there's features you could create and engineer to help make the data more sound, to help the algorithm be more accurate. But you shouldn't do that without a baseline first, because what if the engineering you're doing is making it worse and you don't know it? Okay, you got to have a baseline. So I just wanted to highlight that. It's very critical that you don't do this too soon. But now we're finally at that phase. So you're going to improve your model. In theory, your model should get better if you've done the work properly. And so there we are. Okay. So have fun with this. Let me know if you have any questions. I'll be around. At some point, I will step away from my lunch. I'm not going to take a full hour myself. I'll probably just step away, get some food for like 30 minutes or so, and come back. So if you try and reach me and I'm not responding, it probably just means I temporarily stepped away. But I will answer you. But that's where too, if you pose questions to the group, maybe your peers can help as well if for some reason I'm not around. But I will intend to be around the entire window minus just a little bit of lunch. Okay. So everybody, we'll see you back here at 2:30 Eastern time, and then we'll have our final discussion after that. Have a wonderful lab time and lunch. See you then.
Yes. So I just wanted to highlight. So Anna asked a question to me. Is this when we should be uploading our? Excuse me. I'm sorry. Is this when we should be modifying our S3 bucket? Yes, absolutely. So today you're going to modify the S3 bucket value because yesterday's bucket is no longer in existence. It's gone. It doesn't. It's nowhere to be found. So go look at the new S3 bucket value. It's provided in Quick Labs and modify your code with that new value. That's very important. And then run your project. Okay, run it all the way up to the end of yesterday. So yes, absolutely make sure you get that S3 bucket modified. Very important. Otherwise it will break. By the way, one other thing, as these jobs are running, so as you're doing these jobs and your code is just sitting there churning away, right? And you're just kind of sitting and waiting. You can go into the AWS web console and go look at those jobs and see them from a different perspective, right? So let's say you have a training job running or you have a hyperparameter tuning job running or something. Go into that same web console that I was showing you, and you'll see them running in there. So keep in mind your notebook instance just acts as a client. It's not actually performing this work. Okay. Even if it's just sitting there and it seems to be going, it's not doing anything. It's waiting for a return. It's waiting for an answer back from the service. It's just invoked it. Okay. The notebook instance acts as a client. It doesn't do any of this work. All right. And as a client, the web console is also a client. They are both the same thing, just different visuals. But at the end of the day, they're both just acting as clients. You could have an application that's a client, right? You can have an application that goes and invokes this in your automated code script sitting on your laptop or sitting anywhere in the world. And it could invoke this training job or this hyperparameter tuning job, and it will it'll perform it over in SageMaker. Okay. So keep that in mind that this notebook instance is not doing the work. Right? It is just simply invoking it. And you're just basically monitoring it as you see those, as you see those steps coming through. But if you want to go look at it visually, go into the AWS web console and go find those jobs, and you'll kind of see that they're running. It's just another way to visualize some of this stuff. Okay. All right. And of course, if you really want, you could then also go look at the logs in CloudWatch logs. If you want to go find that job, look at the logs for that job and see exactly what's going on. It's kind of interesting when you go look at that level, right? You kind of start to understand what's happening behind the scenes a little bit more. So just some other things you can go look at. All right. Let me know if you have any questions. Right. Apologies. I was gone for a few minutes, went and grabbed some food, came back and saw a bunch of messages here. So a couple things. When you go to change your S3 bucket, it's not the TC large objects bucket that you're changing. You needed to change the one that's your bucket, the one that's specific to the stuff that you're saving your outputs to. The AWS-TC large objects bucket is where the source data is stored, and that's always going to be consistent. So you want to make sure that you don't try and change that or it just won't work. So you got to leave that one alone. The bucket you're changing is the one that's your lab bucket, which is defined. Usually it starts with QLS dash something. So you're going to find an existing QLS dash something and replace it with your own. Okay. All right. All right, just looking through some of the other statements here. Yeah, the notebook changed notification. I hadn't seen that before. So only if something actually had gotten modified on the system. So what happens commonly is if you have two tabs open, maybe you're changing it in one tab and then the other tab doesn't like that because something got changed inconsistently. Okay. That's usually something along those lines. So it usually just means that somebody or something is changing it outside of the window you're in. It's usually you because nobody else has access to your notebook, just you. All of you are working on your own independent notebooks. So not sure what would cause that. So just looking through the errors here. Okay, yeah, it looks like a couple people were having, yeah. So specifically the S3. So Nirali, I hope you got that. So the AWS TC large objects, I'll put it in the chat real quick. That can't change. Okay, that can't change because that's the source. That's where your source data lives, and it will always be there. It's there globally for everybody. You need to change a totally different bucket. All right. So it's a different bucket definition. It's your lab bucket definition that you specified yesterday. It's the same one you did yesterday, but yesterday it would have been labeled QLS dash something. It needs to be changed to the one today that's QLS dash something, but it's just going to be a different actual bucket name. Okay, yeah. Yeah, so you should have had to change the bucket. It just would have been the bucket from yesterday is going to be different than the one today. So any work you did yesterday would have had to been modified because the output needs a place to go. And if you specify your lab bucket from yesterday, that bucket no longer exists and it's going to error out. Okay. So I think I'm all caught up in all the chats. Genevieve, so let's see, you only got it open in one window. Yeah, I'd say, I mean, you could do override option. I don't see why not. Yeah, it's not going to really permanently break anything. But I mean, you should be able to save what you've got. I would just save what you've got and, see if that makes sense. I don't know why it would differ, but. All right. But yeah, I just want to comment on the changing the bucket. You do not change the bucket. That is the AWS S3 CP command, right? I just want to make sure we're clear on this. I'm going to put this in the chat here real quick for everybody because there seems to be some confusion around this. I'm going to put this in here. You do not change that. Okay. You're going to change a totally different location. That's actually going to be your lab bucket output. So when your model gets created, it needs a place to save the model. And that model is actually getting put back on S3 and it needs a place to go for that. And so you defined that bucket yesterday. And like I said, it will be QLS dash something. Okay. Lab bucket name, QLS something. Okay. Oops, I didn't type that right. But hopefully you get the idea. Okay. So that needs to be changed. That's the only thing. It's one spot, like midway through. I think it's just after the beginning of lab 3. You'll find it. Depending on the project you're working on, you'll probably find it somewhere there in the lab 3 content. All of the projects contain this. So it's not just unique to a particular project. All of your projects are going to contain it, and you must update that or it won't have a place to save the model. And then you're going to have a problem deploying the model and doing all that. Okay. So if any of you are having problems saving the model or anything like that, that's probably related to that. Okay. But the source, the copies that are taking place, that's just copying from a source file location, and that file location hasn't changed. It's always there. It's just a public S3 bucket that the data sits on, and you're just downloading it. It's the place that you need a destination. Okay. All right. So hopefully that helps maybe somebody. All right. So if you have any other questions, I'm here. Anybody have anything? Odette, okay. Just out of curiosity, so it's using the bucket name from yesterday then? And I'm not referring to the TC large objects one, right? Just to clarify. It'll be that lab bucket name. Interesting. And you can see the model? Because that bucket name should not be the same. I'm really surprised. Okay, you didn't modify it? Have you trained a model and finished that yet? Have you trained any new models yet? So yeah, just checking in on that. Have you made any? Have you trained anything yet? Got it. I'm guessing your output's probably somehow broken. Just a thought. Yeah, I would check into that. You may need to change that bucket name and then update the variable so that when you save when the model's done, the problem is you probably have to retrain. Any training that you did will probably have to be done again because it's done now and it needs to do it again. So your hypervisor, if you're doing, hypervisor, if you're doing automatic hyperparameter tuning, that's going to need a place to save those models as well. So any of that stuff's probably going to be, there's probably not going to be any models for you to look at. They probably errored somewhere in the logs. If they didn't give you an error on the actual command, the logs probably contain that error, but I would check on that. It's extremely unlikely or improbable that you would have gotten the exact same bucket name because it's completely randomized and randomly generated. And when your lab ends, the bucket gets deleted. So, and you don't have permissions to other buckets. So that's probably not working entirely like you think it is. Yeah. Make sure you update the bucket. Okay. All right. If anybody runs anything, gets stuck or anything, just let me know.
I got a question. Can you hear me all right?
Yeah, go ahead.
Yeah. So I'm wondering, in the previous labs, we've set up training, validation, and test sets, and I guess there's a little bit of lingering confusion in my mind, and part of it could be because I'm just not familiar with the various algorithms that, like how they're implemented on AWS. I'm used to working in like scikit-learn or something like that. What I'm wondering is, only now have we, like in lab 4, are we actually doing any sort of hyperparameter tuning? And so I'm wondering, like in the previous training jobs that we've initiated, what purpose did the validation set actually like serve? Because usually the times that I have a validation set are when I'm doing some sort of crossfold. And number one, I don't think we actually defined any folds in the earlier
no
labs.
folds.
And so like, and then but also that we'd be comparing like multiple models. And historically in the earlier labs, we were just training one single model.
Correct.
And so it seems like we're just like validating the model and then comparing that model against a test set, but you could just have one big test set or something like that, right?
So
Like
the validation, as we talked about with like our splits, I was trying to see if I could find the slides for it. Let me see. I think it's in this one. Just to recap on it, I just got to find like the simple holdout as an example.
Sure.
Just 2 seconds here to find this. I'm just digging through my slide decks. If I have something on screen to kind of talk through, it's a little easier than abstractly talking about it. Oh boy, let's see here. Well, as I'm looking here, I think I can kind of talk as I'm going. So your validation happens within the training process. Okay, so as the algorithm is doing its work, and by the way, I want to point out Amazon's implementation of the algorithms is not unique. It is the raw base algorithm. It's the exact same no matter where you go. Okay.
Okay.
So I want to point that out. XGBoost, Linear Learner, any of these algorithms, these are the public use of these algorithms. The only thing is they are containerized, and SageMaker deals with the inputs and outputs. That's it.
Okay. So then,
so starting with that.
Okay. So then starting with that, I'm guessing that there's some sort of like early stop condition being implemented here, right? So that it has to check against the validation set to figure out when to stop.
Not when to stop. That's going to be based on, there's actually default hyperparameters on basically how long to go, because you can go indefinitely. There is no answer. It's finding the lowest, the best validation. So validation is always used during those cycles. So it adjusts the weights, it learns some more, and it uses the validation set along the way to see how it's doing.
Right. Okay. Yeah.
The validation set is going to help you with your error rate to help you understand if you're erroring or not. Right.
So I guess what I'm wondering is in the case where like let's say I'm training like a K nearest neighbors or something like that, there is no like update your weights so far as I know.
You don't update your weights. The algorithm does that.
Well, yeah. But what I mean is like in using scikit-learn, like some of the simpler models like KNN or support vector machine or random forest or whatever, there's no like learning where there's like a continually updating of weights. There's just like a dissection of data somehow. And there's some boundary condition that's figured out by the algorithm, but there's no like weights per se, or you're not constantly like updating a model, right? So what
one
I'm
model,
saying
it's one
is
model creation. So the confusion here is those weights are done transparently inside the training process. That's what the training process does. You don't update those. It's a continual cycle as to how it's the algorithm is actually identifying the results, and the weights are just simply parameters. Not hyperparameters, they're parameters inside the system. And those are done dynamically inside the system to produce one model.
Sure. But what I'm saying is there are some models that exist, and I thought I saw at least some of them on Amazon's registry. There are some models that exist that only have hyperparameters and not parameters.
Hyperparameters are just your settings, or just your inputs. As far as what algorithms support what parameters, it does depend on the algorithm for sure. Yeah.
Okay.
I'm trying to remember KNN off the top of my head. I was just kind of looking it up here to see what parameters it has, and what those look like. But that would be just some basic Google searching, because it doesn't even have to be SageMaker specific. It's just here's the algorithm.
In K nearest neighbors, it's literally just counting like the nearest neighbor elements and using the majority class of the neighbors to determine the thing. So there's no weights to update in that case. So in that case, I'm not wrong in thinking that you wouldn't need a validation set there, right? 'Cause
Probably
there's-
not. In
Okay.
fact, let me just say, just out of curiosity,
I think, by the way, I think you have answered my question, because it sounds like the models that we're using, they have built-in weights and parameters. And so in that case, you would want to check it against a validation set as you're
Exactly. As you're going,
updating.
yeah, as the weights are being updated. So the validation is used to help you understand, are you what's your error, right? You're when you're dealing with the whole error, we're trying to find the error minima, right? And the only way to know that is, how does it know if it's correct or not, right? And that's via your validation set. As far as that goes, KNN is another algorithm we could choose, right? So again, this isn't specific implementations to SageMaker. Every one of these major algorithms are in here. And so KNN, you can come in here and you could see, what are its inputs and outputs. And so I would look here and see
Yeah,
what
I'll
channels.
take a look at that.
So in this case, I would say, just out of curiosity, I don't think so. Yeah. There we go. It supports train and test. It doesn't even support a validation.
Oh, okay. All right. So that makes a lot more sense now. So in the case of something where you're constantly updating parameters, you would want to check against the validation set to prevent overfitting. But in something like this, there's no parameters. There's just hyperparameters. So
yeah, it's the way that it works. Yeah, exactly. Okay. So it's all about the algorithm. I couldn't remember KNN off the top of my head, but everybody's got their different circles of what algorithms they tend to find themselves working with a lot. So that's one of the drawbacks of if you do a lot of work in one particular algorithm, it's really easy to start to think that's the way it works, and that's the way that algorithm works. But that's not necessarily the way it works. Not necessarily the way it works across the board for everything,
Right.
And so every one of them's got a little bit different features, and the way when I say features, they're obviously not talking about data, just functionality, if you will, and the way that it works and the way it does what it does. And so yeah, some of these cases you're going to have varying degrees of whatever parameters it supports and hyperparameters that it supports. And so we haven't been using KNN. We've been using depending on the project you've been working on, and or the exercises, there's different algorithms we've been working with, but most of them is going to be like XGBoost or linear learner on most of these examples, or like I said, depending on one of those projects, there's different algorithms people are using. Sure. So that's where also I usually recommend everybody does all three projects at some point. You have 3 months worth of access to these labs. I'm going to talk about how to do these projects in your own accounts as well. So if you have a sandbox account or something, just go ahead and pull these things up in your own accounts. It's pretty straightforward, but I'll walk everybody through it. So let's say you're doing that, just for sake of discussion, let's say you're doing the fraud one today. You could, next week or next, couple weeks or whatever, go in and jump in and do the flight or do the recommendations ones, right? So that way you've kind of got exposure to all of them, and you kind of see, because each one's going to be different. There's different algorithms being used for different types of problems, right? So yeah, all really good stuff. Great point though. Yeah. So to that point to everybody, every algorithm has different inputs, if you will, and different ways it works. And so that's where I always come in here to the documentation here. And if you just look at its inputs, every one of these algorithms, I think I am sharing my screen, right? Yeah. Okay. So every one of these algorithms, if you just go to the main kind of root of the algorithm documentation. Now, again, this is SageMaker documentation, but most of this information is just pulled from the public realm. And then they add in SageMaker notes, if you will, right? So, but because KNN in this case is the same here as it is anywhere else that you'll find KNN. So, but you come in here, inputs, outputs. That's kind of where I like to go, and you can kind of see what the channels are supported, and that's a good place to come to see what channels it's going to support. In this case, it's just train, and then test is once the model's created, you're going to run your tests, right? That's it. But we could come over here to random cut forest, right? It's very, very different yet, completely different in what it does. Look at the inputs, outputs, right? And it kind of talks about what we need to do. It talks about some recommendations on instance types and families and stuff to use, and what kind of sources and outputs you need to work with here, right? But this one supports only train and test as well. No validation here. Okay, so and then file types and things like that are also mentioned in here. So this is a really good place to come just to kind of quickly identify what you need to do to use a particular algorithm, start playing with it. Right.
Just to clarify, is random cut forest the same as random forest? I don't think I've ever heard it called random cut forest before.
I don't believe they're the same, actually. So yeah, I mean, this is specifically referenced as RCF. I mean, that's a very common term for it. So if you haven't heard that, I believe you're referring. I've actually not heard it the other way. So I'm pretty sure they're different. In fact, just out of curiosity, I'm just kind of curious what good old Google comes back with on that one, because I'm not sure. So I just did the kind of a search here versus the two. I don't know. Have to kind of do some research on that one.
Yeah, it could be just a degeneracy of language. I'm not sure.
It could be. Yeah, it's possible. But I think, once you're calling it, is a special type of random forest. And it says, according to this, right here, let's just take a quick look. Looks like, even ironically enough,
I see.
Amazon documentation, but it's a special type of random forest algorithm. I think random forest is kind of more of a generalized term, right? But random cut forest is an actual specific algorithm that we select in here. So like I said, I've never heard it referenced this other way, but that's because I'm usually specifically using this algorithm. So whenever I have used it, I haven't used it that much, to be honest, but yeah. So there we go. All right. Yeah, some of those questions, I'm not going to have all the answers to, but we could dig them up together and try and find some of those things too. So, but I'll let everybody get back to work. We're going to get started back up again in about 10 minutes or so. So here's the deal. If you're not done when that time hits, then then I would say you could kind of just hold off where you're at. We have probably about an hour worth of discussion, plus or minus, that's left. And then then at that point, you kind of are going to be free to do what you want. So you could finish up working on the project and so on. So we'll talk about some final discussion topics, talk about some stuff more about the exam. I'll give you more resources. And as I mentioned, I'm going to talk about how to do a lot of the stuff in your own accounts as well. So you don't even need Quick Labs to do these things. Quick Labs is helpful, but because you only have 3 executions for each one, what you're going to have to do is probably go into lab 4 for the next project that you might want to do. You could launch it, and you could technically go, lab 1, 2, or lab 2, 3, and 4 in the same order on your own in your own time if you wanted to. But just know that you only get 3 executions for each one. So that would be 3 projects, 3 executions. That's it. But it'd be nice to know how to do it in your own accounts. And then at that point, you're not really limited by anything Quick Labs related, and you can kind of explore a little bit more and things like that. So I'll talk about that when we later today as well. We'll see you back here in about 8 minutes now, I guess. So if you're still working, try and get to kind of at least a stopping point. You don't have to finish. So if you are still working, like I said, you can just kind of leave it where it's at. And then when we're done with our discussions for the day, you could wrap things up if you wanted to then. Okay. So we'll get started in about 8 minutes. Yeah, VJ, we could probably take a look at that. No problem at all.
Cool, thanks.
Let's see here. Looking at some of the other comments. Sorry, I had to step away for getting my coffee refilled and all that stuff. Get ready for the afternoon here. Yeah, and then Genevieve, not quite sure why it would be so hung on yours. Is it still in the same kind of state? It's like about that was only stated about a minute ago in my chat, so I'm guessing so. So yeah, if it's taking that long, something's probably not right. I'm not sure. I unfortunately don't have an answer to that one. Yeah, so that's a good question, actually. If you have multiple notebooks running, I could see that one being a problem. The notebooks that we have you use in the labs are not very powerful, and they're not doing a lot of the work. They don't need to be usually because the work is actually being done over at SageMaker, right? It's being done on that end. Your notebook is kind of just keeping the connection open, if you will, kind of waiting for results back. But yeah, if you have multiple notebooks, sometimes they can fight with each other on that node. Yeah, that might help. It's kind of weird though. It kind of depends on what you got going on because technically speaking, the notebook isn't doing the work. The SageMaker side is. So maybe it's just not keeping the communication line open very well or something. I'm not sure. SageMaker technically, I would actually go look into the web console and see if those look like they're done. See if they're farther along than your notebook is saying. That would be something I would be curious about. Because it's possible that it's just not getting updated on your notebook, that it's not getting the return information, that you kicked it off and now it's going. And because technically you can do this stuff. Quick note on this one, you can do this asynchronously. You have the ability to kick off training jobs and then just go leave, right? And close everything out, shut everything down. You don't need to do things synchronously. The way the labs are, there's no reason why you should you would need to do that because asynchronously, because you got to wait until it's done regardless, right? But you could absolutely do that and then just check on the status of it. Once the model's done, you could get that information from it and move on. The notebook isn't doing any of the work. And that's one of the things that's kind of funny is it kind of looks like it is because it's giving you those, the progress, if you will. It's giving you that information. That's information coming back from the APIs from SageMaker. It's not the notebook generating that information. Okay, just to clarify on that. All right. So anyhow, so we had questions during the last couple of minutes around validation sets and stuff. Just keep in mind that each algorithm is unique on its own. It is not unique to SageMaker. It is just unique in that each algorithm is unique. That's just the way it is. Quick note on that one is kind of funny because different circles, right? We were talking about like random cut forest versus random forest. I started thinking about it. I'm going, okay, yeah, I have heard random forest mentioned, but here's the thing. Most of my machine learning experience actually comes from AWS. And so I find myself, I've occasionally used the random cut forest algorithm, and that's pretty much my exposure to that. So some of you probably have more broad exposure on that. And so, that's where sometimes circles of, what you've got exposure to can influence quite a bit of your understanding on this stuff. So it's funny because you have some people that only work with certain algorithms and you go to another pool of people and they've got exposure with only a different set of algorithms and their knowledge is very, very different. All right, so let me go ahead and pull up our next discussion. While I'm doing that though, any thoughts, feedback, issues with that lab? Of course, if it's still running for you and you're just letting it run, just let it keep going. And then when we're done with our discussion, you can go ahead and jump back in and kind of work on finishing that up. But any thoughts, feedback, questions, issues, anything there? All right, just getting the next module loaded up here. That is our last one. All right. So before we do this last one, actually entirely, let's go ahead and do our last checkpoint. Just kind of talk about this one. Let me pull up the link for this. We'll send it to the chat. All right, so go ahead and take a few minutes, go over this. Like I said, like the other checkpoints, let's just take like 10 minutes, see how we're hanging on to these things and have more discussion. All right. I'll give you a few minutes to do this. When you're done, go ahead and use that green check to let me know. Check in about 10 minutes or less, depending on how quickly you get it done.
Hi, Ryan, are you available?
Yeah, sure am.
So as we're preparing for this this ML pipeline certification, should we be doing this from the perspective that it's all particular to Amazon AWS? So should we be trying to, in our own studies, do everything in SageMaker specifically, or is there a larger ecosystem on which we're being tested? And this whole suite of technologies is kind of fair game for that certification.
Got it. Great question. So it is an AWS certification, right? So always keep that in mind. And that's kind of goes with anything we're working with. So any AWS tooling is fair game. Okay. However, when it comes to ML, there's no other ML tools we use. Like SageMaker is the machine learning tool in AWS. So there is an old legacy one called AWS ML, actually, and it's been around a lot longer. SageMaker is not new anymore. It's probably, I don't know, 4 years old or so. But AWS ML has been around for probably 8. We don't use that one anymore at all. I mean, it's not removed, like it's not considered sunsetted or removed in any way. People that are still using it can still use it. Amazon tries not to remove products because if you build something on it, then they have to tell you to get off of it. And they don't like doing that. They like saying, you know, if you're still using it, we'll still support it. We just don't want a bunch of new users on it. It also means that probably a bunch of new features probably won't be expected, right? And so in doing so, usually people naturally progress off of it because it's going to eventually lack a bunch of features. SageMaker is the core machine learning tool in AWS. You will be expected to know some of the stuff that surrounds it, though, like storage. That's why we had like some slides and discussions on S3, as well as EFS, as well as FSX for Lustre. And so those are supporting technologies that will help us work in our ML pipeline. But ultimately, none of those are actually performing machine learning, right? The only tool in AWS that really performs machine learning is SageMaker. Now, could you go launch your own TensorFlow implementation on a Docker container of your own and run it on a virtual machine, or run it in Fargate, or run it in any of the other technologies that can run containers? You absolutely could. But that isn't part of this scope, because that would just be testing your knowledge on running a Docker container in one of those technologies. That would be something more along the lines of the architecture classes or tests. We're not expected to do that here, because that's just, I mean, at the end of the day, it doesn't really matter what's inside of a Docker container. Amazon doesn't care. It doesn't affect anything we do. What happens, what we care about at that point is just running the container. So whether it's a machine learning model or training process or something like that, or whether it's just some web app running in a container, it doesn't really change the way we run it, right? So, Jeffrey, yes. So I'll show you that here in just a second. So total side note, I have another conversation going on with Jeffrey that I wanted to bring up. Just a great question, but we'll take a look at that. But yeah, so from the exam perspective, SageMaker is kind of your go-to for all of this. I wouldn't try and run a bunch of separate kind of one-off things, running your own, Docker images or virtual machines or things. That wouldn't really be testing your knowledge of anything AWS. That would be testing your knowledge of how to do containers and maybe how to do TensorFlow on your own. So that's the thing. It's not really a generalized ML certification. So there's a lot of general stuff out there about ML that you don't need to know, because SageMaker does it for you, or it's completely custom, right? So you need to know how to do things custom, let's say in SageMaker, like in other words, what would be involved in doing it. But as soon as you go custom, then your knowledge of things like TensorFlow might be required more so than normal. Like we haven't done anything with TensorFlow in here, or PyTorch, or any of those things, because all we're doing is we're saying, hey, here's the algorithm, go use it. we would be expected that you know how to go about building your own containers. But at the end of the day, those are just containers, and we don't really care what's inside of them. That's up to you at that point. So there's not going to be a lot of understanding around that kind of stuff, right? So it's good to know what some of your options are out there and concepts, but that's about as far as I would really say you need to go on that. So we'll talk more about the exam after we're done with this next discussion, but just kind of frame that a bit. Always keep in mind it's an AWS certification, not a machine learning certification, right? I mean, although it is ML, it's ML on AWS. It's a specialty for AWS, and so you do need to know the a lot of these concepts we've gone over, but ultimately it's about implementing them in AWS. And so what is unique there? And that's where, understanding SageMaker is going to be key.
Okay.
And hopefully that kind of helps. Yeah.
Yes, thank you.
Okay, good. So let me just real quick, just total side note, just a thing that was brought up. Here's the personal exercise we did in this last effort here is project exercise. Excuse me. I keep saying personal project exercise. So you do this work, and we went through these first few steps here, right? And you kind of work through, working through some of these steps. Went through, okay, and you went through these different solutions here, right? And then at the end of all of this, so we get to the kind of the end of the feature engineering steps, if you will. Just before tuning our hyperparameters, we go through and we do our split training, our split here. And this is splitting our training, validation, and test. So here's the deal. When you're doing feature engineering, you're going to do all your feature engineering, and then you're still going to want to do that across your entire data set, right? You're going to do your feature engineering across your entire data set, and then you're going to randomize it, and you're going to perform your splits at the very end before you try and do any training, because it all has to be randomized, right? What you don't want to do is leave it unrandomized, or have randomized it and then do your feature engineering where now your features are not randomized, and there could be some weird stuff going on there. It should still be relatively randomized in general, just because like one hot encoding a column, if it's already been randomized, that column is already randomized. And so it shouldn't be a problem, but I would still usually say do a final randomization and then do your split just before, right? Just to make sure there's no weird oddities that come about with that, and you don't end up creating some sort of overfitting scenario or something like that. And then we went through and started doing parameter optimization, hyperparameter optimization. And this is where you're going to ultimately be creating models, right? So this process does a training process, right? And it's now training based on different settings. So up until the very end here, this is when we did our final split, right? And then we trained it. So, right, we're randomizing it, right? Randomizing it. And then we're creating a test, train, and validation record sets. We've done the split up here, right? And then we're doing the dot fit. Okay. So we're splitting it just before actually training. Okay, this is the training entry right here. That's when training takes place. And just before that, we've got all of our records all split up. Okay. So we're randomizing it and then splitting it and then telling it to go train. Okay. And then we're going to get some results from this. And then we're of course going to have, to optimize the hyperparameters at that point. So Jeffrey, does that help you? I don't know if anybody else was struggling with kind of the order of operations that are going on there.
Yeah, I follow the order of operations. I was merely commenting that in the feature engineering, they do a group by average of price according to zip code. So they group by zip code and then take the mean, and then they put that as a separate feature. And I think that's fine to do. It's just that if you do your train test splits such that each zip code has samples in both the training and test sets, you would end up with a sort of information leakage, because the average price per zip code was computed using samples in the test set.
But it would be actually using samples of all of the data, wouldn't it? And that's kind of the point. It's the
Uh,
entire data set, not just a test or just, it's the whole data set.
Right, but that's still an information leakage. Like if your average is computed using samples in the test set, and then you try and get your metrics on the test set using a model that you trained that contains averages that include samples from the test set, that I would call that an information leakage.
Yeah, I guess it's kind of subjective. I understand what you're saying now.
Yeah.
The problem is, I mean, so of course it's going to be a bigger issue with smaller data, right? But let's just say I've got 1,000 records. I get an average. I'm doing means off of that, and I create a feature, and now I'm doing all of that, and then I populate it all, and then I randomize it all, and then I do my test, my validation. The mean should be the same across the board in any of those the test sets. If the math, it should be very, very close, if not identical. But I can understand where it could be thrown off if you have a very small test set. But in all reality, because I mean, that's the whole point, is that tests should be an identical. It should be different records, but an identical outlook as my training. Right.
I mean, well, so I've seen data science workflows where they actually fit a standard scaler to just the training set, and then they transform the test set using the average and mean that they got from the training set.
Yeah.
So in that way, the test set doesn't actually factor into the scaling for the training.
Yeah, I get what you're saying.
So you're using the same scaler for both, and it is like
Right.
a small thing, and it may not really affect the outcome, but
it could.
Yeah,
But it could. Yeah, I see what you're getting at.
and the other thing I was just thinking that, like, if you split by zip code, it's a better test of whether or not the model can generalize to unseen zip codes.
I see what you're saying.
But yeah,
Gotcha.
Anyways, those are just
no, those
comments
are
that
great
I had.
thoughts. Those are great thoughts. Yeah, and I think a part of it depends on how you're using it too, because if you do it by zip code, on the flip side of it, you could argue you're introducing bias.
Yes.
Right. So
Yes,
it's
that's
catch-22. It's, I mean, and this is where there's nothing, a lot of this stuff, there's no hard, steadfast rule or answer. And in fact, if somebody says there is, that's usually a sign of somebody that doesn't have as much, exposure to it. Because, in one argument, you're absolutely right. If you split it up and you do that stuff by data set and you do all that, you're now not having a data leakage, but you're also introducing bias, right? And then in fact, your training set now is lacking information. You've removed information, which ultimately creates a bias as well. So, and if you do it by zip code, then you could say, well, that zip code looks different than that zip code, and we've created a bias there. So,
it depends on the problem you're trying to solve.
Nothing's perfect. Yeah, exactly. The problem you're trying to solve, and ultimately, nothing's perfect. And so that's where you could experiment with both and ultimately see which one performs better at the end of the day. That's something to always keep in mind is training is just training, right? It's not like generating a report for your business to make big business decisions off of. It's training a model so that future predictions are accurate. I mean, in the general sense, that's the goal here. So at the end of the day, if my model performs well, then we've done our job. There may be some flaws here or there, or there may be some decisions where either decision wasn't great because each one had its own flaws. But at the end of the day, if my model's predicting accurately, we've done our job, right? And so that's something we always need to think about is, unlike errors in data that will throw off, a report, if we're saying we made more money than we did, and someone's looking at financial forecasts, so they're trying to, public stock price, and we're trying to report on stuff and our reporting is wrong, there's huge issues with that. Training, you can have a little bit of fluctuation, you can have a little bit of issues there. And at the end of the day, if my model's predicting correctly, then it's still working, right? But yeah, those are all great thoughts for sure. But we need to, there's always a give and take in a lot of cases. Like in that case, if you do it just by the training set, just by the test set, just by the validation set, as an example, there's going to be a level of bias there that could be introduced. On the flip side of it, you could also argue that you don't have data leakage. So I don't know, right? I would try both. See, what I try and do personally, is my opinion. Everybody's got different opinions on things. my opinion is I try not to make too many assumptions along the way. So things like that, I mean, you could say this could be a problem as long as you know it, you understand that, but there could be another problem in another way. So I usually just try and let the data, I try and let the models kind of direct me, in some cases you just, create two different models with two different data sets done, two different exercises done against the data, I should say. If you have a question there, do you want to go, well, this is data leakage, and so let's do it a different way, and then produce two different models completely and see which one ultimately performs better. But be careful, because if you're relying exclusively on that test set, right, the test set itself can give you misleading results, right? So that's where sometimes we have to do A/B testing. We're actually about to talk about that right now. So it's a perfect segue, actually, because at some point, we're going to say, my tests look good. This has got to go into production. But we want to continue to monitor it in production and identify if it's performing equally as well, right? And we've had some cases where, your test looks good, your validation looks good, everything's fine, go into production and it doesn't match. So reality doesn't match my test. It means I've done something in the process to probably introduce bias or introduce other things that just made us fall short of reality, right? And so that's the next thing. At some point you say, I'm ready to put this into production, but maybe you want to do like A/B testing in production. You have two models. You're not really certain which one's going to be performing best. You could deploy them both and send 50% of your traffic to one model, 50% to the other, and ultimately measure the outcomes of those long term and see how they're performing and do some production testing that way. All right, we're going to get into that. So great topics there. Let's talk briefly about this checkpoint. We're not going to take too terribly long on this, but ultimately, a couple just quick things on here. This kind of talks about this is a class imbalance going on here, right? And if you have a class imbalance, accuracy is probably one of the worst measurements of success, because you have so few of actual choices on the other end, right? So one end, not offensive here in this case, is a massive training that is 10 to 1, right? So basically 90% of the data is not offensive, and then you have one offensive, and so it's a very big class imbalance. Accuracy and class imbalances, that's kind of like a immediate. You should be able to immediately know that accuracy, the way that accuracy works, class imbalances are going to be a huge problem here. Okay, so if you have a class imbalance, accuracy is probably the worst way to measure that. Okay. And then this one, we talked about, a couple of the different options for regression models. To be honest, just kind of comparing with our materials in class, we know that precision was for categorical stuff, right? So you can kind of scratch that off. I don't even think we talked about sigmoid. Wasn't even brought up. And then cross entropy log loss. I don't remember if we talked about that one either, right? But we had really kind of two primary options we were talking about. Mean squared error and R squared. And those are pretty much the only two we talked about for regression models. So you go, well, this is an easy kind of deduction reasoning at that point. But it's good to obviously know what each one of these are to help you better answer the question. But point is, sometimes you can just narrow it down to just, also going, well, I know this is a fact when it comes to regression. Maybe that's what you guess, right? So on the exam, you may have a couple questions you can't directly answer. You don't really know the answer. Try and learn how to kind of whittle it down, and maybe you go, well, I don't know about these others, but I know that one matches up with regression. As far as this one goes, it's not generalizing well on the test set. I mean, that's just fact of the matter. We don't need to go too crazy into this one. It's just understanding this. If you're not really understanding this context, there's a little bit more studying you're going to want to do on that one. So I'm just going to kind of skip past one. The curse of dimensionality. Ultimately, dimensionality is about number of features in your data set. Okay, we want to always have a few features as possible. More features typically results in lower quality models. Okay, there is usually a balancing point there. There might be, 2 might be better than 1, but 4 might be better or might be worse, right? And so there's usually kind of some sort of a peak, if you will, and then it starts kind of trailing off. Too many features is not a good thing. Okay. And then also this is month as a categorical. Okay, it kind of gives us the clear understanding here. 12 categories. We talked specifically about this, right? We do not want to do this right here. Just have 1 through 12 as a column where we just have values 1 through 12 representing months, right? We need this to be one hot encoded if we want to make sure that there's no value difference between January and December, right? The ultimate idea here is grid search, like we talked about, is so inefficient. It's not even an option in SageMaker, but ultimately part of the problem too is that it doesn't explore all the regions. No matter what we do the whole grid. There's massive regions that are unexplored, right? So if we do random, more of those regions are going to be explored. If we do Bayesian, it's actually going to try and use some mathematical regressions to actually hone in on the answer. So less regions go unexplored. Okay, so much smaller gaps, if you will. Right. And then if you know about XGBoost, it's really about classification. Typically, it's a classification algorithm, and ultimately, with classification, we're typically going to use a confusion matrix to visualize those values, and that's where again you have your true positive, true negative, false positive, false negatives. Right there we go. Other visualizations work for other things, but when we're talking about classification, we're talking confusion matrix. Okay. Correlation matrix again is very different. That's talking about correlations between features, right? And then you kind of just visualize and think about what a box plot looks like and what a scatter plot looks like. It's not going to help you at all with what we're trying to do here. Okay. High level there. If there's anything that you missed there and you didn't quite grasp, it just gives you a chance to understand where you need to maybe dive and study a little bit more. All right. All right, so let's get into model deployment. So model deployment is assuming that we've created a model we like. Okay, it's meeting our business requirements. So now we finally get to say yes here. Okay, now we're going to go ahead and deploy it. So you've been deploying these models already, whether you realized it or not. You were actually going through a deployment process. Okay. To perform your tests and whatnot, it was actually being deployed, and you were running your test data through that deployment. So we'll show you that in more detail here, but we'll show you some of the different options when it comes to deploying. So you have your trained model, you've tuned it, it's ready to go. Okay, it's been fully tested, we're good. So at this point, we want to put it into a production environment so that you can use it to create new predictions off of unseen data, right? So you have your main production infrastructure here. You have maybe some application. Now this is not SageMaker. This is nothing. This is just whatever, some odd app, right? Whatever it is. And it's generating data. Okay, whatever that is. So wherever the data is being generated from, we now have this production data, right? Well, from there, we're going to take that data, new data, and we're going to run it through an inferencing endpoint. Okay, and we'll talk more about this in a little bit here, but ultimately this is where the model is being hosted. Okay, so the model is ultimately being run here. The data gets run through it, the predictions get made, and sent back. So the predictions are right here. Okay, so the app is able to send its data to the inferencing endpoint and get results back, get predictions back. Okay, what else is going on here though? We're going to monitor this model's performance. So we're going to have metrics to monitor off of here. And we have this whole monitoring platform we're going to use to watch all of this. And we're also going to scale as well. So here's the thing, that inferencing endpoint right here. If the load, we're actually talking about scaling here. We're not talking about scaling the data. We're talking about actually scaling the systems. So if the load of the inferences increases or decreases, we can add or remove resources as we need, so that we never run out of resources. We can infer as quickly as we need to based on the requests coming in. Okay. And so this monitoring is going to include that. We're going to watch these resources and trigger scaling when we need to. Okay. And then also, we want to identify errors, anomalies, and what we call concept drift. The idea of concept drift can otherwise, I've also heard it as model rot. Okay, it doesn't mean I don't like the idea of model rot. The word model rot I think is a little bit misleading, so I try not to use it. But I've heard people hear that term, so I try and connect the dots there. It's also called concept drift. The reason I don't like model rot is the model has not rotted, right? There's no rotting taking care of, they're happening against the model. The model is what it is. It's always the same from that point forward. It's reusable forever. However, the world around the model is always changing. Okay. Just like anything else, if we don't adapt with things around us, we're the ones that ultimately change without changing, right? Same thing here with the model is if the model doesn't adapt, it's going to eventually stop predicting as accurately. Okay. So the idea here, I use this example a couple times in class, but when major things happen, economies change, health changes, things like COVID came about, anything. I mean, ups and downs in our world, things that we predicted 6 months ago would probably be errors today in a lot of cases, right? Not 100%, but you're going to gradually get worse here. Okay. Over time, the model just will not perform as well. So you produce a model today, you can't just put it in a production forever and just leave it as is. You need to update it on a regular basis. Now, when we update it, it doesn't mean that we have to go through the whole exercise again, because really all we need is new data. And most likely, all of our other stuff can kind of remain the same. A lot of times our hyperparameters can remain the same. And we just simply say, retrain. Here's our train set, right? And so we do some new data and we randomize it and we split it and we perform our training job, right? And that can be all automated. So this monitoring service here has the ability of actually monitoring the model's performance. And if the model starts to drop below a certain threshold, as an example, it could trigger automatic retraining of the model and automatic redeployment of the model. And this is all stuff SageMaker will do for us. 1 second here, gotta get a quick drink. All right. Usually towards the end of 4 days, voice starts trying to give out a little bit. So I gotta keep the liquids going. Okay. So unmanaged ML deployments on AWS. If we have to update anything, we're gonna have to create an image probably of our own, and that image could be an EC2 instance running an AMI, which is a virtual machine in AWS running its own image. We could also then run multiple instances with that image, and we may have to make changes, to if we are using Docker, we'll have to make update those Docker images on a regular basis, things like that. The point is, you're going to have to be stuck doing all the work, right? And then of course scaling as well. So if you're using your own, you've kind of built out your own ML infrastructure, you could do that. There's nobody stopping you. You go run some virtual machines, install your necessary tooling. You could run your own endpoint to produce your inferences or your predictions, no problem. But that means you're taking on the need to scale the resources, update the resources, create new images on a regular basis, all that stuff. It's going to be all on you. Okay. So the idea here with AWS is that AWS can help you along here, right? And so we have SageMaker. And again, the idea here is that you can deploy a model. If you're in the web console, it's literally just one click. If you're in code, a single API call will deploy that model. Okay, makes it that simple. And then it can auto scale the necessary resources. Okay. So it will host those resources. It'll provide you a secure endpoint for that model. Okay. So you have an HTTPS endpoint, it's all encrypted. You can also host multiple models from a single endpoint. So you could have an auto-scaled endpoint, handling multiple models. You could also have multiple endpoints, each with their own model, however you want to do that, or multiple endpoints, each with multiple models. I mean, unlimited amounts of options here and unlimited amount of models that you could host. So plenty of flexibility on how you might want to do that. So there is a create model API. Now in the SDKs, a lot of times it's another call than this because the SDK is wrapping it and including this API call inside the SDK. So it kind of just depends on, again, we're a lot of times doing like the .fit to actually train as an example, but what's happening behind the scenes is .fit is just an SDK action, and it's making multiple API calls a lot of times behind the scenes to make this all happen. All right. We're going to name the model, tell SageMaker where it is. Okay. If you're hosting on SageMaker or if you're running a batch inference job, explaining this one real quick. I think we already briefly covered this before, but again, we can have an endpoint that is accepting live requests 24 hours a day, 7 days a week, and it could be near real time. I could be dealing with 1 million requests a second. I could be dealing with 10 requests a second, doesn't matter. Or I could be dealing with 1 request a day. The problem if I'm only doing 1 request a day is it's probably going to cost me a lot of money comparatively or proportionally of what it should. If I run an endpoint 24 hours a day, 7 days a week, just to simply support 1 call a day, I'm going to have to run those resources all the time, and I'm paying for those. This is one area, I'm going to be honest, I think SageMaker needs to be improved. I don't think they've had any announcements or changes on this. I'm hoping that it's soon. I'm almost guaranteed. I mean, well, I'm not going to say that. It's bad form. I personally am very confident that this is going to have to come soon. Almost everything in it, everything else in AWS, there's ways to pay just per API request. Let me just double check on this one because now I'm starting to doubt myself. I just want to double check. Pay per inference is what I'm looking for. I just want to make sure before I state this for too long, because a lot of things in AWS are constantly evolving, and something that's true today won't be tomorrow. Okay. When I say something like if I said you can't do this today, tomorrow you might be able to, right? And now the statement tomorrow is wrong. So I just want to double check on this one just to make sure nothing's changed. There we go. Okay. So I had a feeling. I was like, I think I remember seeing something on this. So it's still not in production. That's probably why in my head it's not there yet. But it is around the corner because it's in what we call preview. So what this is, serverless inference, while it's performing an inference job, you're going to pay a price per second. So it's really kind of per inference request here. If you do this model, this is going to be way more efficient because you won't necessarily have to pay for resources just to run 24 hours a day, 7 days a week, waiting for a request. Okay. And so you could just watch for this. It's in preview, which means it's not yet general use or general availability. So not yet. Okay. So for right now, what we have to do is do real-time inference is what we call it. And you're going to actually run some virtual machines here. You're going to tell it how many resources you want it to have. Okay. You're not going to have to patch these or manage them in any way. Amazon does that. SageMaker does that. But you're going to pay for this at, in this example, if I just do a single endpoint, a single inference endpoint, running this simple MLT2 medium, not a very big system, it's going to cost me about 5.6 cents an hour. And I'm going to have to run that 24 hours a day, 7 days a week. Now, that's a pretty small implementation, a really heavily used model inference endpoint's probably going to use at least multiple systems and or larger systems. I probably could see myself running a couple of T2 extra larges, and now you're looking at 22 cents an hour. That starts to add up, especially if you only have a couple inferences a day. Okay, that is assuming you need this kind of real time. I need it right now, right this second. When I need it, right? So typically, this kind of idea is when you have stuff happening in near real time all the time, right? You've got an e-commerce website that people are going to, and you're making real-time recommendations at the time they're interfacing with the system. That's going to be different than like daily orders Hey, I'm going to prepare what orders I need to purchase for tomorrow. I need to place an order. And so I don't really need to do that real time. I could just batch that up at the end of the night, right? So, different purposes there. It's serverless inference. That's the one I would keep an eye on. It's in preview. It's not general release yet, so technically it's not there. Let me explain one more thing about the exam on this. Amazon has a rule in the exam. You will not ever be quizzed on or have an exam question on a product or feature that has not been around at least 6 months. Okay, the rule is 6 months. That is the hard line in the sand. So let's say this goes general release tomorrow. It won't be on your exam. Okay, so you don't have to worry about that. So it's nice to know just as a general knowledge of using this stuff in AWS, but you don't have to worry about studying how serverless inference works. Okay, so kind of scratch that off your list. Just it's good to know that it's there, but from a certification point, forget it. Okay, so this is again deploying and hosting SageMaker on AWS, or deploying and hosting on SageMaker. Step one, create the model, right? And then we're going to create an HTTPS endpoint configuration. Okay, this is endpoint configuration. So this is not the actual endpoint yet. It's the configuration, and we're going to associate it with the model. All right, and then we can set what we call one or more production variants for each model. We'll talk about production variants here in just a second. And then for each variant, we can specify instance types and the initial count that we might want to have it use. So let's say we've got multiple virtual machines we're using here. We could also set weights on how it balances and basically load balances your models and things like that. Okay, so here's a kind of just a standard deployment. We have this endpoint configuration name. We have a production variant, but you notice here it's just a single node and we're sending all the traffic to it. So this is a variant without, basically it doesn't have multiple options. It's not auto scaled. It's not load balanced. It's just a good old single implementation. Okay, it was still called a production variant, but ultimately we're typically going to use production variants beyond this, where we might want to have multiple choices here. Okay, multiple instances, different models, be able to route different requests and load balance and all that stuff. So this will ultimately create a new endpoint or replace the current one. So this is an important one, is new or replacing. There's time involved in this because entire machines, entire virtual infrastructures have to be torn down and rebuilt. And that takes time, and it does, it says absolute minimum downtime, but you notice it doesn't say no downtime. So this can result in downtime because we're tearing something down and building something up, and we're going to switch endpoints when we do that. So in this case, it's all or nothing. So traffic is served either by the new model or the old. There's no load balancing taking place here. And by default, it's just one variant per endpoint. So really, the whole idea of a variant is actually it's a newer concept that was layered onto the technology after the fact. And so they made it a default where it's a one-to-one. You build an endpoint, it's just got this production variant, which is really nothing more than the configuration for the endpoint. But we have the ability of doing multiple production and variants as an enhanced feature. So this one is kind of good to understand how AWS does what it does. So let me back up and give you just a little bit of kind of concept or a little bit of a background on conceptually how Amazon does a lot of this stuff. So Amazon has this philosophy where the idea is nothing ever changes. And you might hear that and you go, wait a second, a lot of things change in AWS on a regular basis. So there's a difference between changing and adding, right? So Amazon tries not to ever change anything. They just add. So one thing is everything in AWS is API first. That means 100% of what we can do in AWS is automatable because it all comes back to an API. First thing that gets created is an API. Then things like the web console, the CLIs, the SDKs, all that stuff are just skins on those APIs, okay? And then let's say they want to add a feature. All they do to add a feature is maybe add another API request, okay? They don't have to modify the first one. They just add to it, and it's an indefinite add to model. It's really, really nice. There's some drawbacks that come with it, but they're pretty minor. It's a huge benefit by doing this because things we build today won't just suddenly break when there's a change, because changes don't occur. It's add to. So if I'm currently using 3 features today and Amazon adds 10 more, they didn't modify the 3 I'm using. I can just keep on using the 3. It didn't impact the 3 I'm using. There's 10 more I can choose from, but I can choose to use those when I wish. Okay. Now, understanding that concept, one drawback to this whole model is that defaults can never change. Think about it for a second. If Amazon builds a technology today and down the road, they want to change a default, if they were to change that default, it would break my stuff all of a sudden because I might be automating against it. And, day one, I'm automating using the defaults. And then when they change the defaults, my automation is still using those defaults, but now they're different. Amazon indirectly just changed my implementation, right? So the rule is also defaults can't change. Well, originally, when they first released SageMaker years ago, you would create an endpoint and it was 1 model per endpoint. And you wanted to create another model or you wanted to deploy another model, you had to create another endpoint. And it was always this one-to-one deal. Production variants really didn't even exist at the time. It was just, here's my endpoint, and that endpoint hosts a particular model. That's it. So they added the flexibility or the feature of what we call production variants now. And that allows me to have more than 1 model per endpoint. But the defaults have to have the same exact behavior as the original implementation of SageMaker. So understanding that bigger picture of AWS, I think it helps in a lot of contexts because this is not just SageMaker specific. This is everything AWS, these kind of things you'll see on a regular basis. So people go, wow, the defaults really aren't all that great. Yeah, a lot of times the defaults aren't all that great because the defaults are however it was day one it was released. And they may have come out with better and newer features, but the defaults don't include them because they weren't there on day one, right? So it's a catch-22. It's one of those older, one of those issues that does come with their model. It's worth it because there's a whole bunch of benefits we gain by doing the whole API first, nothing changes kind of idea. But there's some negatives, and this is one of them. Okay. So here we have this production variant, and the default is that there is no variant. Okay. That's ultimately what it's saying. That the default is 1 variant per endpoint by default, but we can change this behavior. Okay. So I want to point out, we were first just kind of talking about the create endpoint config API here. Okay. So we create the config and then create endpoint actually creates it using the configuration. So we specify the endpoint configuration, model name, any tags, all that stuff you might want to include. And now it deploys the endpoint using the configuration. Okay. Now, how does that work when it comes down to the actual code? Well, we noticed we talked about .fit, right? Again, the SDK .fit is actually initiating the necessary API call behind the scenes. And then we've got this PCA.deploy. PCA.deploy deploys the model. You'll notice up here, we have this estimator and we start to see some of this stuff, right? That's all hardware for the training, right? So keep that in mind. Although this looks similar to like this, they are not the same. So SageMaker very clearly separates out its services. SageMaker is not just one big service, okay? It has notebook instances. Those are separate by themselves. You have training instances and training processes, right? Those are completely by themselves. So then we have actual inference model hosting, right? So this hardware being defined up here, I want to point out, because you've seen this a lot in your labs and your exercises and whatnot, that is purely for training, okay? That has nothing to do with my actual inference hosting or my deployments, okay? So my deployment down here, though, you see right here, instance type is being defined right there, PCA.deploy, okay? So it's what we call, we're naming it a predictor at that point. So we want to do this with minimal downtime. Again, if I'm not doing anything special and I just do this right here and I swap out, let's say I want to use a new model. By default, that new model is going to actually have to replace the current one, meaning the endpoint is going to have to be torn down and a new one's brought back up using the new model name. It's not super slow, but this is about it is going to have downtime. So I know it's kind of funny because it does say absolute minimum downtime. It doesn't say no downtime. Words matter. We're saying, look, it's going to work as quickly as it can here, but there will result in some downtime because it's a one-to-one. It's kind of like taking a virtual machine and doing a major upgrade on it and rebooting it, or shutting it down, changing some things and starting it up again. It's the same kind of equivalent in that if I don't have any resiliency or load balancing going on, it is what it is, right? But if I take that same virtual machine and put it behind a load balancer and auto scaling and all that, I might be able to do some work on one while another one is handling the requests. When that first one is back up and running and back into production, then I do the second one. And I could do that with zero downtime, right? So some of you may be familiar with deployment mechanisms or deployment models like blue-green. The way blue-green works is exactly that. Usually you have, V1, and then V2, okay? That's not a Z, that's supposed to be a 2. But we have 1 and 2. Blue is your original environment. Green is your new. And so what we're going to do is shift our requests over to green. So what you do, the neat thing about this model, don't confuse the word model here, this architectural model is we can put green in place without anybody using it. So we can spin the whole thing up. We can have endpoints ready to go. We can do whatever we need to do and then start sending requests to it when we're ready. And that request shift can be done gradually. It does not need to be done all at once. It's not like a hard cut. So maybe 1 out of every 10 requests goes to green. And if all looks good, maybe 3 out of 10, 5 out of 10, 8 out of 10, and eventually 10 out of 10. Then blue is no longer needed. Blue, all the traffic, all the requests have been shifted over to green now, and blue can then be gracefully shut down whenever I'm ready. And I just did that without any downtime. But the benefit to that is, let's say we find ourselves with a problem. Let's say we discover there's an issue with this whole thing, and we have scaled green. So green is now receiving half the requests. So 5 out of 10 requests are going to green, but we notice there's a problem with green. We can make a hard cut right back to blue and send all those requests back to blue instantly without any kind of rollback mechanism. That is our rollback mechanism. We don't need to restore anything. We don't need to rehost anything. This is all done in parallel so that nothing green does impacts blue and vice versa, so that blue is continuing to run until we no longer want it. And so at any point in time, we can just flip right back to blue. So if model version 1 is blue, model version 2 is green, and we notice there's a problem with version 2, we just go right back to version 1 instantly. Really easy. So that's built into SageMaker as well. And then Canary, the idea of Canary is actually very similar, except for the fact that it's not going to do the full transition. So Canary might be that initial step where I might say, you know what, I'm going to test a couple different models. I'm just going to do like 1 out of every 10 requests or 1 out of every 20 requests, something really small, and just kind of see how this thing is going to behave. The objective of Canary by itself is not to shift everything. It's to kind of do a test in production, basically. So it's not our first test, of course, right? But once we feel like something is ready for production, we can kind of slip it in a Canary fashion where it's only a very small fraction of the requests that are actually hitting that new model, right? And then if we are happy with something and we want to actually implement it, we could apply the blue-green methodology to actually shift to it, okay? So we could do both of these. All right, so this is what I just described. Blue is version N, green is N+1, okay? It's exact copy of the environment plus the new version, okay? So implementing this, so we have this endpoint configuration, okay? And we're communicating with it, right? This endpoint. We create and test a new green environment. So far, no requests are going to it. Nice thing about this is we don't have to have any downtime, right? We're creating it, we're getting it online, the endpoint's been created. We run a bunch of tests against it. We think we're good to go. Then we can adjust our web app to start talking to green. Now, maybe we do like 50-50 here at first, and then eventually get rid of blue, and now we're on green. Okay. Now, I want to point out something here. If I back up a slide, this particular strategy that we're showing you is actually relying on the web app to make the shift. So these endpoints are in the form of an HTTPS endpoint. It's a URL. Okay. So our web app may have to make an adjustment and call a different URL or something, but that's not a requirement of SageMaker. I just want to point out there's different strategies here. By doing this, you have a completely independent environment and you're in full control over how that's going to work. Okay. So your web app is going to make those decisions perhaps, or maybe you create some sort of DNS entry that does this for you, or who knows, there's a bunch of different ways you could tackle this, but ultimately you're doing the shift yourself. Okay. And then another option though, is to do things like A/B testing. Like in this case, this is like various weighting. Maybe I send percentages of requests to different models, right? Different versions of the same feature, potentially compare different performances of those different versions, monitoring the high level traffic along the way and doing all that. So with a Canary, I can do kind of some of that stuff too, right? Canary is the same idea as blue green to some extent, except for the fact that, again, it's just much smaller. So I route a very small portion of my users to green. If there's a failure, we just put everybody back to blue. So the idea here is that if there is a failure, it's a very small percentage of the requests. It's a very small percentage of my users that actually experience any kind of issue versus all or nothing, right? And then of course, no failures, we go ahead and move everybody over, and that's our blue green, right? But this is where we can actually do what we call production variants in a more advanced way, right? So those production variants, now what we can do is we can actually create multiple production variants on a single endpoint if we wanted to. Okay, so I want to back up. If you have two endpoints, your web app is pretty much going to have to handle those. Okay. Now, even then, there's some things you could do with Route 53 and some other services in Amazon on the name side of the house, where you can kind of force the balancing there. Your web app wouldn't necessarily have to be knowledgeable of it, but there's some other strategies. Bottom line, SageMaker itself doesn't actually contain that load balancer across endpoints, and that's by design so that you can control those endpoints individually how you want. But if you do production variants, this is going to allow you to actually have a single endpoint if you want, or multiple endpoints. Okay, so in this case, instance, one endpoint splitting across two instances is kind of what we're talking about here. Okay, so your I'm going to say EP for endpoint. Okay, and then behind that you've got model A hosted there and model B hosted here. Okay, and so your web app just talks to the endpoint, and then these are hosted by different instances, actually different systems altogether. Okay, so that's kind of the general idea there. And so you see there's a number of instances that we can specify, weights. So this is basically sending requests by percentages. It's not specified in terms of percentages, it's specified in terms of weights. But if I have a 1-to-1 weight, we're talking 50-50, right? We're talking 50%. But if you could do a weight like 2 and 1, 5 and 1, 10 and 1, something like, the weights are going to ultimately result in some sort of percentage of traffic going to one versus the other. Okay. But different models are being hosted here. Okay. And so we have what we call multi-model endpoints with that. And so we could use, again, only a single endpoint. Your web app doesn't need to know the difference with this model, with this idea. So you have your application talking to your endpoint. From there, you can have multiple models being served up. Okay. Memory is going to be automatically managed based on the traffic. So you got some traffic monitoring happening there, memory management happening there. Also, we can save money doing this, because instead of having to deploy separate instances for each model or separate instances for each endpoint, we could actually share multiple models on a single instance if we would like with this idea. So we could just host, a couple of instances and host potentially hundreds of models, and not have to worry about that. But just know that from a resiliency or fault tolerance kind of perspective, that if a model, if an instance, the hosted resources here fails, then all the models on this will fail. Okay, so just keep that in mind when you're building architectural design. Sometimes we want things independent and separate. Other times we want them together, but we have to think that through. Okay. So inferences, again, we got batch versus real time. We've already talked about this for the most part, but batch where you've got multiple rows you want to predict. So you probably have like a CSV with a bunch of data in it. You go send it to the system. It'll give you predictions back for each row. Okay. Real time, we're going to submit it record by record. Okay. Row by row. So this is for new data, right? So moving forward, all of our data up until now in the class, for the most part, we've been saying, here's how you train it, right? So of course you train it with a bunch of data, but future predictions, I might just send it one row and get a prediction back. Okay. That could be that real time record by record. Okay. So inferences and batches. So, in this case, we're doing something overnight. Orders are a big one. People are ordering inventory or something like that. You're probably not going to have to order that all throughout the day. You could probably wait till the day's up and then make your order for tomorrow. That makes sense just to do batches. Batches are going to be cheaper most of the time, at least with today's model. The real-time endpoints, right? Because of the pricing we were talking about, right? Coming back here, today, real-time inference, I have to have at least one instance running here, at least one, all the time to be able to have the inference available, right? Otherwise, it's not there. And I can't wait to spin it up until a request comes in because I need it right now. So real time as of today is going to be probably way more expensive than batch a lot of times, because batch I can just say, here's when I need it, run the predictions and then go away, right? Real time, whether or not anybody's using it right now, you're still going to have to pay because it's running right now. That's why I'm really keeping an eye on the serverless one that we talked about right here, serverless inference, and this one's going to be more on a per request, per inference kind of basis. Okay, so how much memory did the inference actually require, and for how long to make the prediction? Okay, that's what this is about. So if it just needs it, for a fraction of a second, needs it for like 100 milliseconds or whatever, and it makes its inference and you get your answers back, then that's what you're going to pay for, as opposed to having to run resources all the time, 24 hours a day, 7 days a week, right? And so typically, if you can do it with batch, do it with batch. That may change, like I said, once serverless is live, general release. Then at that point, I would do some deeper dive on the math and see, does it make sense just to make predictions as you go, or at the end of the day, right? Excuse me. So just some examples: batch transform, if you want to get inferences for an entire data set, if you don't need a persistent endpoint, if you don't need sub-second latency, right? So these are good for that. Okay. Also, this last bullet's not entirely accurate today, but it says when you pre-process your data before using it, that's not actually a requirement for batch transform anymore. We'll talk about that here in a second. Okay. So on a schedule, if I wanted to, I could go ahead and make inferences, right? So I could have my data sitting in an S3 bucket. I send that ultimately to the batch predictions, performing predictions, put your results back onto S3. Okay, that's it in a nutshell. All right. So these resources will spin up when you need them to, and then go away when you're done. So you don't have to really worry about running these all the time. All right. So if there's no predictions to be made right now, no costs right now. Okay. But here's an example of like one of our smart devices, something like Alexa or Google Home or things like that. Imagine if somebody said, hey, Alexa, play some music to distract crying toddlers. Well, we're not giving it an exact song name or a musician or band or something. We're just saying, hey, I just want something that matches this, right? That's one thing that's kind of cool about these devices is they have lots of machine learning built into them, and they can interpret what you're asking for. And so then what if it was like a 2-minute wait before this stuff came on? That'd be really ridiculous. these devices would not be overly popular, right? They would be pretty poor if we had to wait 2 minutes to get some kind of prediction done. And so that's where the real-time predictions make sense if we need them right now, right? So something like Alexa is a great example. Chat bots are a good example. A lot of companies are starting to leverage those. We've got things like phone. We use that phone example, right? Where maybe somebody's calling in and you got a call center and you want to make sure you get to the right place as quickly as possible. That's probably going to be a real-time prediction. But like I said, if you're just making an order for the next day, you could probably just do that at night under batch and call it a day, right? So we're going to have this endpoint we're going to talk to. And then again, just like everything else in in SageMaker, things are being pulled in, right? So dynamically, it's going to pull the model from the bucket, and it's going to pull the inference code from an image. So you got an image over here on ECR for inference. So there's two types of Docker images that SageMaker uses. There's training images that are Docker images, and you have inference images. Those are the two, training and inference, okay? So if you make your own custom images, same thing. You're going to have to make, are you deciding if you're making an inference image or are you making a training image? What are you doing here, right? So inference obviously is just simply running your model while training is going to actually perform all those training activities against the data to create the model, right? So you're going to have this endpoint running, and again, it's dynamically pulling these resources in, okay? Some best practices around this: training versus inferencing. Okay, inferencing is usually run on a single input in near real time, while training basically high amounts of processing power, right? So I know it says parallelism, but I'm going to kind of leave that one alone. If you're doing deep learning or you're doing distributed algorithms, then it will be a lot of parallelism. Otherwise, none at all. But the bottom line here with this first kind of line is really trying to say is large batch processing, going on with your training. Real time inferencing is going to be probably record by record, very quick, right? A single input, right? The training process is really where most of your compute and memory is required. Okay, training is where most of your resources are needed. To actually make inferences, it really doesn't take a whole lot of resources, typically speaking, to make an actual prediction. Okay, because the model's already been created. Think about like real life. Once you learn something, you can apply that learned behavior or that thing instantly without a whole lot of work, right? But to learn it is the hard part, right? People go to years and years of schooling for something, and then in the moment you can apply that stuff very quickly if you're good, right? So same idea here. Training is always the most intensive here, right? And so your resources are going to be very different needs for training than inferencing. Okay, training can typically be done standalone. It doesn't have to be integrated into an application stack, but it can be. If you want to automate it as part of an overall pipeline automation, you could certainly do that. But ultimately, actually making the predictions as you go is more common, right? So even if you are fully automating your training process, training probably isn't happening hundreds of times a day, right? Inferencing might be happening millions of times a day, right? So very commonly inferencing will be integrated automatically very easily. Training, maybe not, right? Depends on what you decide to do there. As far as inferencing goes, you could also run this stuff all over the place. It could be in the cloud. It could be on edge devices. You could have little tiny sensors running models, right? You could have cameras running models. You could have all kinds of things, at the edge, not just in the cloud. You're not going to train at the edge. You're not going to train on a camera. You're not going to train on some sensor somewhere, okay? That's the place you're going to make the predictions, but not the training, right? So again, inferencing might be running all the time, while training is really just whenever you need to train. That might be once a week, once a month, once a quarter. You may not train all that often. It just kind of depends on how much the data is changing, how much the model needs to change, I should say, right? Keep in mind though, the model created today could be used 3 months from now and it'll still work. It's just the question is whether or not the environment's changed so much around it that whether it's accurate or not, right? As far as auto scaling goes, when do we need to do auto scaling? And this is again another concept you should know for certification, kind of understand what's going on here. A notebook, you don't need to auto scale. You're not needing resources to come and go all the time on a notebook. Okay, you're doing something static, you're logging into it, you're doing some work, you're maybe visualizing some stuff, and then just kind of sitting there reviewing the visualizations, not really doing anything. So it is a little bit kind of burstable, but you're not going to scale because auto scaling would actually mean multiple systems. So I want to clarify what auto scaling actually means. Some of you are newer to AWS. The phrase auto scaling in AWS means adding nodes. Okay. So this doesn't mean making your system bigger. This wouldn't be like making my notebook automatically have another CPU or an extra few gigs of RAM. That's not what we're talking about with auto scaling. With auto scaling, we're talking about adding another node. So auto scaling a notebook would make no sense. So just understanding that okay, so now I have 2 notebooks. Whatever, I still can only use one. It doesn't matter if I have a second one sitting there. Okay, auto scaling would make no sense for a notebook. Training, if it is a distributed algorithm, you may use multiple nodes, but it still is not going to auto scale. And again, auto scaling, you're adding nodes or removing nodes, but also it's going to be usually in response to demand or something like that. Well, training is very consistent, very predictable. Okay. It's not like user behavior where you don't know if suddenly you're going to have this huge influx of users. Okay. With training, you know what's required for that training job. And it doesn't need to scale during the training job. So even if you do have a distributed algorithm, the algorithm is going to want to know exactly how many nodes it's using. So maybe I deploy 5 nodes for my training job. Those 5 or those 5 or those 5. Okay, it's not going to dynamically add a 6th as we go. That again doesn't make sense. The algorithm wouldn't be able to handle that. Our algorithms today aren't really that smart, not to that degree, to be able to dynamically add and remove systems on the fly while the algorithm's trying to calculate stuff, right? That'd be pretty difficult to do. Now, there are some variations of this with things like Hadoop, because that's what Hadoop does, is able to scale and is able to run multiple nodes. And so there are some variations to what I was just describing that do some of that with like Spark and stuff. But ultimately, typical training, very predictable workloads. You're going to say, here's how many nodes I need. Like I said, many of the algorithms, you're just going to use one node anyways. That's all it can handle. But if it is a distributed algorithm where you're doing deep learning or something, you're still going to have some sort of predictable capacity needs, typically speaking. As far as inferencing goes, though, this is where if I'm doing real-time requests, like that Alexa example, or maybe I'm doing purchase predictions and things like that, and suddenly my user load quadruples all of a sudden, I may need to add resources to handle that load change, right? That is something that's unpredictable. I don't know how many users are going to need to use this model. So inferencing can use auto scaling, then it's really the only place that it makes sense to use it. Okay. And then coming back, we saw this page earlier in the class. It's just kind of a recap. It was actually color coded earlier in the class, but we're showing it again. Basically kind of saying, here are the instance types. Again, kind of recapping on which instance types might be best for what activities. We've already seen this. You can come back and study these more. And again, like we talked about earlier in the class, it would be a good idea for you to know the overall family. Like, remember that R is RAM, C is compute, P is high performance, M stands for multi-purpose, G stands for GPU, T is actually technically tiny, but it's the only kind that can be burstable, right? And then elastic inference is actually a fractional GPUs. So we can apply a certain amount of GPU capacity to other nodes. So we could attach an elastic inference to the R family as an example, right? And then when should we consider GPUs? So GPUs, there's a big misnomer kind of rolling around out there where everybody says, machine learning, you need GPUs. That's like a rule of thumb that I've heard a lot of times. It's completely false. Okay. It's part of that's come from because the big wave of deep learning. Deep learning has really accelerated over the years. And so deep learning does typically need GPUs. Okay, just putting that out there. But typical machine learning, no. Okay, in fact, most of your algorithms cannot even take advantage of a GPU. So it just depends on what kind of work it's doing and what kind of algorithm you're doing and what you're doing. And so make sure you're not wasting money by just getting a bunch of GPUs and thinking it's going to help you. Make sure you know that the GPUs can be leveraged. Okay, so under the training jobs kind of heading, if you're doing regular, if you're doing like image processing or audio processing and things like that, and of course deep learning, then GPUs might make sense. But if it's not one of those things, you probably don't need a GPU. Okay, so those are pretty specific, right? Image related stuff, audio related stuff, deep learning, something like that, GPUs might make sense. But beyond that, if you're just predicting sales or something, GPUs probably won't help you one bit. Okay, so training jobs, that's on the training job side of the house. And then on the inferencing side, again, if you're deep learning jobs, elastic inferences might make sense for you there because, again, those are kind of fractionalized GPUs that we can leverage. Otherwise, if it's not deep learning inferencing, you probably don't need a GPU. Okay, some of this stuff is going to be important on the exam. Amazon wants to make sure we know how to make good choices on what resources we want to use. Here's an interesting thing. Something, a little total side note. I get into this a lot more in my architecture discussions and stuff, but Amazon actually does not want us to overspend. A lot of people think that, oh, Amazon would love for us just to overspend and not care. That's actually not true. And it's partly because of the healthy competition that's going on. There's other reasons, but there's two primary reasons why Amazon does not want us wasting resources. Some people might say Amazon would love for us to waste resources because our bill will go up. Sort of. Amazon's biggest problem is not getting customers today. Their biggest problem is making data centers fast enough. So they would actually rather you more optimally use those resources so that they can get more customers on the same hardware. All right, think about that for a second. If you're not consuming those resources, they can sell those resources to another customer and maybe even lower their prices a bit to attract more customers. There's a lot of economists out there have said, yeah, Amazon's prices are good. They're great. They're very cost effective and they're better than running on premises typically. But they probably have room to trim more numbers off. Interestingly enough, Amazon actually uses their costs as a way to control load on their systems. So if they wanted to attract more customers, they would just lower their costs a little bit and more people would start to use the system or use more products or what have you, right? But if you keep something a little bit more expensive, you're going to reduce the pool of people that use it. Ironically enough, this is one of those situations where in some cases they know if they lowered their rates on some things, they would make more money. Okay, it's that classic idea of, if you go out and sell a product and you say, I want to sell it for $80 and it really is only worth 10, you're not going to make very many sales. If you lower it to 10, you'll make a lot more sales and you'll probably make a lot more overall money, right? Same idea. So Amazon, in a lot of cases, is actually not making as much money as they could if they lowered their prices, but it's a strategic way to actually control your load. It's one of many methods. So if there's certain products out there that are a little bit more expensive, you kind of have people on the fence, companies that are like, hey, I don't know if I want to use that. Then they lower their costs. And then what do you know? Everybody starts using it, right? So product by product, technology by technology, they do that with, or feature by feature even. Number two, so if you actually weren't wasting resources, this is number one, actually, if, back to recap on that. If you weren't wasting resources, another customer could use it. They could take those customers on and they would love that. But again, their problem is not obtaining customers. It's actually having a place for those customers to run their stuff. So building data centers and having compute, that's the biggest challenge. Number two, they also know that if you're over engineered and you're spending way too much money, it would also be easy for Microsoft or Google to come to that customer and say, wow, Amazon's sure costing you a lot of money. You know, if you did that in our platform, it would be cheaper. And they provide them some sort of quotes. And maybe you're spending 100,000 a month and they come back and they say you could be doing it for 50. Amazon doesn't want you to overspend because it makes you a candidate for that, right? They want you to be optimized. They actually want you to be spending what you should be spending and not more, because then at that point, it's much harder for Amazon or Google to come, Azure or Google to come swooping in and take you away as a customer. So there's a couple of reasons why Amazon does not want you to waste resources, okay? This is one of those. GPUs can be quite expensive, just in general. GPUs are a lot more expensive than CPUs. And use them when you need to, but don't overuse them, okay? And Amazon doesn't want you to do that, all right? And I don't want you to do that. It's a bad idea. So elastic inference, we can reduce costs up to 75%. Part of this is because we're doing more with less. It's much more efficient than CPUs when this is needed. When we do need CPUs, when we do need GPUs, these are going to perform better than CPUs. So you're going to get more out of what you're paying for. But also, elastic inference allows me to kind of fractionalize this stuff. Instead of having to go out and buy a big GPU platform of some sort, we're able to use fractions of it. And basically, it's like a shared platform. So it's much more efficient that way. Okay. So that's the idea. And then as far as this goes, this is actually out of date. I keep telling Amazon they got to update this page and they keep forgetting to. I'm sure it's on their low priority list. But PyTorch has actually been supported on elastic inferences for a few years now. So it's not coming soon. It's here. Okay, it's been here for a long time, and there's actually others as well that are not on this list. So TensorFlow, Apache MXNet, and PyTorch to start with, but there's others. Go look in the documentation. You'll see what supports elastic inferences. And then what if your data isn't properly formatted and cleaned, right? So we've been doing this all along. So this is a really, really important topic with everything we've been doing, because some of you may be very confused still. You're going, we're doing all this pre-processing work. What about new data coming in? I have to do this work against all that data. And this is a big question that kind of looms over a lot of people until we get to this point in the class. I briefly mentioned this earlier in the class, but some of you may not have caught it. All this pre-processing work we've done, you've essentially created a script in all your steps, right? All those cells going through pre-processing your data, stripping, taking care of your blanks, inserting, inputting means or medians, or doing some feature engineering, doing all that stuff, right? You do not need to do this separately outside of SageMaker. You can if you want. If you want to do that work as kind of like part of like an ETL process over in what we call EMR or Glue or something like that, Spark, you could do that, but you don't have to. That's the beauty of SageMaker here too, is you can go ahead and send your raw, dirty data to SageMaker, and your code will run against that data before it actually is inferred. So what we can do is actually create what we call a data processing container. So, and this can contain a bunch of tools like scikit-learn and others. We can perform our one-hot encoding. We can perform our scaling, right? We can take care of our blanks and do all that. Then it'll go ahead and send it to the actual inference container. So this is a single endpoint, okay? A SageMaker inference endpoint. And by the way, you can do this with batch as well, okay? And it'll run the first part and then the second part. The first part being the data preprocessing, and then the second part being the actual model, okay? So all I have to do is just send that raw data to the system. It takes care of the rest. All right. Like I said, the notebook instance is not where this is going to happen. The notebook instance is where we're going to do our initial exploration, our initial experimentation, but we're going to get this right there. And then once we feel good about all the steps that need to take place against the data, we can go ahead and generate this data pre-processing container and make it part of the endpoint. And then SageMaker inference pipelines. Also, we can go ahead and set up a pipeline. This is basically a workflow engine that will handle all of the steps along the way. One second here. My apologies. Getting a drink. So we can create these inference pipelines. Again, pass the raw data, tell it that we want it to go through the pre-processing container, then go through the inference, take the results, put them somewhere asynchronously if we want, however we want to handle this, right? Again, works with real-time or batch. We can use built-in or custom. Okay, so work with this however we want. All right. As far as monitoring all this stuff goes, just because we deployed the model doesn't mean we're done, right? We want to monitor for things like concept drift, right? We want to also look at the actual systems in play too. So that is included. I want to point that out. But model monitoring is kind of what we're focusing on here. Okay. CloudWatch will actually monitor the resources. So I showed you CloudWatch earlier in the class just a little bit. There's CloudWatch logs. All my logs will end up over there. These will be systems logs. In the case of training, all your training logs, all the outputs. In the case of running things like Lambda and AWS or other systems, your logs will go here. CloudWatch events will actually be an event trigger. So we have what we call these events and we have alarms. I'll just kind of explain the differences between the two. An event is like something happens, some actual event occurs. And so as an example, a training job is initiated. That is an event, okay? A system is started or stopped. Those are events, okay? A file or object is placed on S3. That can be an event, okay? All of those things are events that I can trigger automation from. So a little note on that, I have many automated pipelines set up where all I need to do is drop a CSV on S3. And depending on how I've named it or where I've placed it, I've got some automatic pipelines that if I place it in the right place, it automatically triggers a retraining job. So all I do is I put the CSV on S3 in a training location as an example, and a training job gets kicked off and it produces a model. I don't have to touch anything. I just put the data there. Next thing I know, a model shows up. Another event model, an automatic pipeline, is actually for inference. I take some data, I drop it on S3, and a batch job gets kicked off that actually creates, that actually does the predictions in a batch model. Okay, so those are events. Now that doesn't really work so much with just one record, because one record I'm going to want to send directly to the endpoint. But those types of events, those are great ways to do that. A Lambda function being executed can be an event. I mean, tons of things can be events. An alarm is similar. So both an event and an alarm have the ability of triggering automation. In other words, if the event is triggered or an alarm threshold is exceeded, go do something. Okay. So an alarm is very similar to an event in its after the fact, the actual trigger that takes place, but it's the trigger that takes place that's different. So the event is an actual thing, a moment in time that happens. An alarm is a threshold. Okay, so they're very similar, but a threshold, no activity actually happened per se. It just meant that maybe we exceeded some threshold. Okay, so maybe I have queuing services and I exceed a certain depth of the queue. That's a threshold. Go do something. Maybe CPU load exceeds a certain amount for a certain period of time. go do something. So those alarms can be triggered based on those thresholds, and those thresholds can be upper or lower end thresholds, right? So above or below that threshold, I can go ahead and trigger an alarm. All right. And so these are all part of my automation. Okay. CloudTrail in AWS is a service that logs all of the AWS API requests. So every single request that's sent to AWS is an API request. Whether you're in the web console, the SDKs, the CLIs, doesn't matter. All of that is logged. So I can see every single SageMaker in the logs. Now, I mean, I say I can't. I'm not in your accounts, right? But as an organization, an organization can set up CloudTrail, and somebody using SageMaker as an example with some code written in a notebook or even on their laptop, when the API calls are initiated, when those calls are made, those are going to be in CloudTrail. Okay, so CloudTrail captures those API requests. It captures the fact that the request was made, by whom, at what time, timestamps, all that, the protocols used or clients that are used. Is it encrypted or secured in various ways? All that kind of stuff. It'll also produce the response. So the response of the API request will also be included in the log. So, if I'm asking for some information, some metadata, the request response will end up in the log. And that's important to understand because if I send that request and you send that request, if we have different permissions, we might have different responses. So knowing what data was exposed or what information was provided, I should say, is a better way to put that. It's not really data exposure because we're talking about metadata. Responses to API requests is metadata. It's not typically actually data. Okay. A little note on that. Was there a question? I heard an open mic just to see if was there anybody that needs to jump in.
Yeah, quick question.
Yeah, go for it.
So I think, I'm not sure if it was this or another resource that they had, questions about, CloudTrail and CloudWatch. If there's any mention within the question of an API and it has to do with either CloudWatch or CloudTrail, is that just an automatic, it has to be CloudTrail kind of thing? Or is there any instances in which an API would be involved with CloudWatch?
Interesting. So the way I look at this, if it requires AWS credentials, so API keys and things like that, like a secret access key and access keys, access key ID and secret access key as the two. That includes roles, which is far beyond the scope of this class. But all of those are going to be in CloudTrail, no matter what. Those always go through CloudTrail. This where things can get a little bit interesting is, let's say I take, we haven't talked about Lambda in this class. This class doesn't really get into all that. But just a real quick note on this for everybody that's listening. Lambda is a way for me to run a function of code without any servers. It's serverless. I just simply say, go invoke this. And it's a function of, some Python code or something that'll just run at the time I tell it to run. So knowing that context, high level, when I invoke that Lambda function, it is an API request to do it. However, the Lambda function making requests to other services, you're actually going to see it in two places. You will still see that in CloudTrail because the API requests that are being made there are still AWS API requests. Whether you're doing them or Lambda's doing them, they're still going to be in CloudTrail. But however, anything that Lambda does, you can't see stuff that's going to the screen because it's running behind the scenes. So any outputs that go to the screen, standard out as an example, get captured in CloudWatch logs. So when those API requests are being made, there may be some stuff in standard out that will end up going over to CloudWatch logs. That's kind of the case with any AWS service that is running kind of serverlessly. The logs for that service will actually be found in CloudWatch logs. And that's kind of, it's anything going to standard out. So anything that would normally go to the screen would go to the log. And that's where we noticed if you go into, during the training process, you could go look at the logs for the training process. All that stuff that normally would be piped to the screen as it's running through is going to end up in those logs. And so the API request itself goes to CloudTrail, and that's the AWS API as well. If you build your own API front ends and things like that, those API requests may be in CloudWatch logs because they're not AWS APIs, so yours, right? So at the end of the day, if it is truly an AWS API request, it will always be CloudTrail. But sometimes there's stuff that surrounds that will end up over in CloudWatch logs. Think of CloudWatch logs as more like your systems logs in the big picture of things. Application and systems logs, CloudTrail is your API logs, your AWS API logs. So that's the difference. This is where this exam may touch on this. Probably not a whole lot, but I just want to recap. I'm going to go full circle here for just a second, because this does kind of lead me down a path I think is important for you to again grasp for everybody here. Remembering the certification path, remember. And so, as I mentioned earlier in the week, this is the specialty certification over here. It used to be you had to have at least one of these associate exams passed first before you could take a specialty. That requirement does not exist anymore. And the only reason it doesn't exist is, people were kind of saying, hey, look, I know this content. I don't want to get one cert just to get another. You're making me spend my money and time and energy. All I want to do is go get my machine learning specialty cert, and that's all I want. I know the content I need for it. Just let me go take the cert, right? But what some people believe, by removing that requirement, some people believe that the requirement no longer exists, right? Well, it does still exist in the form of knowledge. It doesn't exist in the form of taking the cert. I mean, anybody can take any AWS cert at any time. If you don't have any AWS certification, you can go jump right on into one of these professionals. Okay. But it doesn't mean that the knowledge doesn't need to be there. Okay. So in fact, all this stuff builds. So the reason I bring this up is all of these associate level certifications kind of contain some of those basics, and even Cloud Practitioner. Things around like CloudTrail and CloudWatch, those are things covered in those certifications, in those exams. So you could find yourself getting hit with some of those questions at a higher level. Not a whole lot, because that's not the focus of the cert, but it is foundational knowledge that things are built on top of. So it is important to know. So that's kind of why these few slides just kind of call out a few of those things, just to kind of remind you, hey, yeah, there's a few things outside of SageMaker we still need to understand and know. Okay. So just keep that in mind, that there could be some knowledge there that kind of comes from one of those lower levels. So what I would recommend is, I wouldn't even bother with operations or developer. I would say just take a peek at the architect here and go pull up the exam guide for it. Download the exam guide right here. And get an idea of some of the things that it wants you to know. Now, this one can get a little bit off the rails. You got to be careful here, because obviously not everything in here is going to be needed for the ML exam. Okay, so I'd kind of look at some of the core stuff in here though, and kind of focus on some of that stuff, basic design principles, and kind of just get an idea of some of this stuff, high level. Okay, I don't want to inundate you with, hey, you got to go study for one cert just to get this one, right? But I do want you to understand that the dependency is there. Okay. So, Amazon, there is a hierarchy here. Okay. So this machine learning specialty is a leg off of these things down here. I know that there's no like direct arrow showing you that, but just keep in mind, it used to be you had to have at least one of these. Now, it wasn't a particular cert they required, though. It was just that you had to have any of the associate certs. And the reason is all three of these associate certs have about 30 to 40% overlap. So if you kind of keep an eye on some of that overlap, maybe that'll help you, right? Because that would be kind of your dependency knowledge over here. You're still unlikely to get a whole lot of questions relevant to this stuff down here, simply because that's not what they're trying to test you on. but it may be embedded in some of the questions, and it may make it a little bit harder to answer some of the questions if you don't have that knowledge. Okay. At the very least, I would say definitely know what CloudWatch is for, know what CloudTrail is for, kind of know the differences between those. And if that means go experiment a little bit more, go read up more, watch some videos, do all that kind of stuff, I would say that. Also, for any of you that do not, I think a couple of you said you had your cloud practitioner cert. I don't expect anybody here to have it, but this one is designed to be a fairly easy cert. Okay. The differences between these certs are night and day. This one is pretty easy. Machine learning specialty is pretty hard. It's not going to be easy for you. There's a big reason why, Booz had so much emphasis on you getting this. Cloud practitioner, it's kind of like, okay, awesome. But the study efforts for cloud practitioner are pretty much self-paced for the most part, right? And I'm not saying go get this cert necessarily. You don't need to spend the money, but there's a lot of like digital content that you could watch for free that kind of helps you with this basic core understanding. And so this kind of course also still continues to kind of build. So just knowing the hierarchy between those certifications is helpful. Definitely kind of focus on the stuff we call out in the slides. If they're in the slides for this course, you can absolutely assume that there's going to be something on the exam about it. So the other stuff, take it light. Don't go spending weeks studying for the cloud practitioner and then the associate cloud architect certification. I'm not saying that. I'm just saying maybe kind of use them as kind of a augmentation and just kind of look at some of the core stuff that's being brought up there. Okay. So concept drift. We've talked about this. How often should I retrain my model? So most models, you could just do some sort of schedule and just say, hey, you know what? Go find the data over here. And once a day, once a week, once a month, something like that, just go retrain. And when it retrains, take the new model and drop it into your endpoint or start using it in your batch transforms or however you want to use it, right? So this stuff, you're updating the model on a regular basis with current data, right? Again, we're probably going to continue to use the same hyperparameters and things like that. Those don't necessarily need to be reestablished every single time. Just retraining with new data. Okay, it's all about the data at this point. So competitive pricing, right? That stuff's going to obviously change substantially. So there is a service in SageMaker called Model Monitor. Okay, and its whole purpose is exactly this. It's to collect performance data of your models, and it'll help you automatically define baselines and build some rules and basically set triggers based on thresholds of statistics and stuff, so that when a model needs to be retrained, it can go ahead and do that. So it'll automate those corrective actions based on CloudWatch alerts that get established based on this. Okay, so this is where, for a lot of things, you just do a schedule. This Model Monitor is probably overkill for a lot of things, but for stuff where a schedule isn't going to be sufficient, or maybe it's something where you really don't need to train very often, so a schedule you kind of don't know when. Maybe in one case, maybe you had to train it 3 weeks in a row, and another case you were able to go a whole entire quarter without retraining it. And so if you want that flexibility and you want more specific times to retrain, if the monitoring says it's time to retrain, then retrain, right? So Model Monitor can be very helpful for that. Other ideas of deployments, you can have ML on the edge. This is where, deploying an ML model to, again, something like a camera or a sensor or device of some sort, you can do that. And this service called IoT Greengrass can help us with that. So in this case, it'll actually allows you to infer locally on your devices, and you can use SageMaker to deploy to it. So SageMaker will be able to deploy the models to Greengrass IoT devices out of the edge. You could have 1 million devices out across the world and take one model, and deploy it across those 1 million devices if you want to do that in just one API call. It doesn't need to be complex. So this is where scale kind of doesn't matter to us anymore. We kind of get to the point where if you can scale to, 2 things, you could scale to 2,000 things or 2 million things in a lot of cases. It's just a matter of having a system that can kind of understand each and every device and whether it's received that model or not, and if it needs to go through a process to get it there, right? So we can use ML models from anywhere. We can use them from SageMaker. We can use models from a deep learning AMI. Now, this is beyond the scope of this class, but the deep learning AMI is an image that will run on a virtual machine in AWS. So it's an EC2 image, but it's an image built specifically for deep learning. All right, so you can build some of your own deep learning environments. SageMaker does do deep learning too, though. So we haven't done any deep learning in here with SageMaker, but it will absolutely do deep learning, okay? The other thing about Greengrass, it has this workflow that you can work with here, where what you can do is you take SageMaker, you deploy the models through Greengrass to the field device. The field device can do inferences, but if you have certain outliers, things that kind of give those inferences troubles, the field device has the ability to actually send back to SageMaker so that you could have like an endpoint over in SageMaker that has more capabilities, more horsepower, if you will, to be able to perform that inference if it requires more resources. Okay. And then we also have SageMaker Neo. Now, again, we're just going through here, throwing a bunch of products at you, a bunch of features at you, just so you understand what they are and what capabilities exist. Because we obviously didn't spend a lot of time on these, we're not expecting you to really know them. Okay. Keep that in mind. Sometimes it's just about product knowledge. What product will solve this job, right? That kind of thing. What product will solve this problem of ours? You don't necessarily need to know the product inside and out. Sometimes it's just a matter of knowing what it is. So SageMaker Neo, basically it's a special compiler and a special runtime to actually use a lot less resources. So we'll optimize these models on for edge devices and other things. And basically the idea here is just simply use less resources. So the runtime's optimized. It's a special compiler to convert the models to a super efficient format. So this is something special by SageMaker. Industry standard models are going to be converted here. Okay, so once it's converted, it's now using its own kind of SageMaker thing. Its own SageMaker Neo environment, but it is a lot more efficient than the standard model out there. Okay, so feel free to go explore with Neo as well. You have to have a model to then use, and then you could use this to compile this and use a special runtime to save some resources. Okay, so that is it. That is it for our discussions as far as SageMaker, the ML pipeline. We're done with all that. Okay, you've still got your project you're working on. Okay, so if some of you aren't done with that, you could definitely jump into that. I think there was a couple of questions that some people had on there as they were still working on their project. We wanted to see if we could maybe work together on figuring some stuff out. I can commit a little bit of time to that. I usually have a few students after class that are almost always kind of coming, asking questions. So I can't focus on just one student for too terribly long, but I can see what I can do to help. I want to make sure I'm kind of spread out and I can help others as needed. I'm not going away, so I'm going to stick around until the standard scheduled 5 o'clock hour. So I'll be here until 5. We're at 4:30, so that's really not that much earlier than planned. Let's talk a little bit more. I talked a little bit just a few minutes ago about kind of the certification path and some of that stuff a bit more. Don't forget about the resources you have available through WebAge. Now, I wanted to tackle that real quick for us. So give me just a moment to kind of shift gears and pull up some WebAge stuff here. So a couple of things I just want to make sure everybody knows about. Some of you may have already dove in here and done some of this. But let's see, I'm teaching the class again next week. All right, this one right here. So something I want to point out, recordings are found in here. You can go back to the recordings as you need. And then there is these practice exams. So this was brought up the other day. I just want to bring it up again. It's very important you go through some of these. At the very least, I would say jump in to the platform here. It says take this course right there. I think let's see if they updated the link. Let's just check. I know this was a pending issue. There we go. They updated it, so we're good to go. So you're gonna have a code here, right, in the student portal. This document that's here, this code. I don't think mine is actually valid because I'm not needing to redeem it. But you're gonna come in here to Tutorials Dojo and redeem that code and log in. And you're going to have practice exams and stuff in here, right? And you're going to have a final test. There's a couple ways we like to handle this. You can take this however you want. Some people have found it valuable to jump straight into the final test as kind of a way to baseline yourself. Okay. And what I mean by that is, first off, this is very different than the stuff we've done here in class. What I mean by different, it's a completely different test, right? It's total third party. It's not by Amazon. We did that pre-assessment on the first day. I'm going to give you a link here in just a second to the post-assessment so you can do that. And that's the AWS provided assessment. But if you come in here and you go to Tutorials Dojo and you go to the final test, you could take that first. I say first. First thing before really going too far into Tutorials Dojo, if you'd like, do that first, because that's like, hey, I'm going to take the no joke test here, okay, and really understand your weak points. You're going to have weak points still. As I mentioned, this class doesn't cover everything, but that test will then immediately help you identify gaps for you, and then you know where to study. You can always take this again, okay? The final test can be taken again. And then you go through these practice exams and kind of, do that. But the final test can be helpful as kind of just take it for a baseline and for your own study efforts. So now you've taken the class, go through here, find your additional weak points, use those as study topics, and then come back in a couple of weeks, take the final test again. But in the meantime, take some of the practice exams as well. Don't let too much time go between. Just kind of keep hammering yourself here. Find your weak points, study your weak points, go take some more sample tests, right? Or practice exams.
Quick question.
Yeah, this is a great tool for that. Yeah, go ahead.
If we take the final test and whatever, we complete it, and then we take it again.
Yeah.
Is it gonna be like the same questions in the same order, or is it gonna be pulling, does it resample them? And
you know what? I don't know for sure. Let me get back to you on that. When I say get back to you, there is the Basecamp communication kind of collaboration kind of area. I'll put something in there and say, hey, I found the answer to this. I don't know for sure. I believe, I just don't want to say with 100% confidence, but I believe it's a question pool and your questions could change. I don't believe it's just a fixed set of questions in the same order in the same way, but could you get some of the same questions again? Of course, it's part of an overall pool, but I believe that's the case. But I'll go find out for sure, because I understand your concern there is, well, maybe you want to go take it again, but if you take it a second time, it can kind of give you false confidence if it's the same question.
Right, exactly.
Yeah, so I think that's where I understand the concern there, because you take the same test 2 or 3 times, eventually you're just memorizing it whether you want to or not, and it's going to lead you to false hope or false results, right? So
you're overfitting to the data.
You got it exactly. Yeah. So I'll find out for you, and try and put a note in there in the Basecamp area, since and then of course if anybody here has any questions, you can always try and tag me in there and reach out to me in the Basecamp environment. But also, let me give you my email address. I don't mind sharing it. So my email address, you may have already seen me use it a couple of times. It's ryan@demic.io. It's my first and last name. Makes it easy. So ryan@demic.io. Feel free to email me at any time in the future. And to be honest, you have the shorter window here through Booz, where you're trying to get certified and do all that stuff. There's a lot of things we have, kind of have you tasked with. But even, a year from now, let's say you have some questions on about AWS in general or whatever. As long as it's not like a full-blown consulting engagement, that's a different discussion. But otherwise, if it's just like, hey, Ryan, I'm kind of stuck on this. Can you point me in the right direction? I love being resources for people, right? I mean, I think it's kind of my way of giving back. I've had a lot of mentors over the years that have kind of done similar things with me. So I do that. And I've been doing that with students I've been teaching for years, and I've made some wonderful relationships in the process. So I'm not like a stickler with my time in that sense. Most people don't abuse it, but if it's a quick like, hey, can you help me here? My response may be fairly short. I'm probably not going to do again a full-time, a full-blown consulting engagement in the process. But what I might do is send you a link or something and say, hey, go check out this link. Let me know if you have any questions, that kind of stuff, right? So I could provide you resources or what have you. Like I said, I kind of unique in the sense that a lot of your machine learning, or actually a lot of your AWS instructors in general, are just instructors. But I work in this field, and so I've seen a lot of variations of things and exposures to things that work and don't work. And so I have a little different perspective in that sense. So a lot of times I have resources that a lot of your instructors don't, because they've maybe never encountered a particular issue or question. But maybe I've encountered it in real life, or a customer of mine did. And so I probably have that resource bookmarked or whatever. And so I can share a little different perspective on things. So feel free to reach out, and I can help where I can. And I'm not going to promise I know all the answers to everything. Everybody's got different strengths and weaknesses and different, exposures to things. But if I can help, I'd be glad to help. Right. And then Tutorials Dojo, definitely abuse this. Okay. Use it as much as you can to try and really get some good prep in place. I think you will notice some pretty big gaps in your knowledge still. We spent 4 days, and you're going to come in here and you're going to go, wow, Ryan never talked about X, never talked about Y. It's like, yeah, there's still a lot more to cover. So this will help you identify those weaknesses very, very quickly. The sooner you can identify your gaps, the sooner you can start studying those gaps, right?
Ryan, quick question.
Yeah, go ahead.
I think we had like a booze kind of like, intro, like I think it was like last week, and we had someone from Web8 Solutions that went on, and they said on that, is it Tutorial Dojo or whatever it's called, that we should only focus on the review mode practice exams. Do you agree with that? Or is it, even if it's like a little different, just try all the quizzes there, just since you can like see, more questions?
Yeah, review mode. I don't know. Everybody's got different takes on this one. You don't want to overdo this, because, as mentioned, what you don't want to do is either one, just totally stress yourself out and kind of lose your focus that way. But also, we don't want to start memorizing the questions and things, right? I don't know if the test is available. I think, doing it all is a good idea. That's just my take on it, simply because the more questions, the more you can kind of spot weaknesses, and the order you do it in or when you do it might be a bigger question than whether or not you do it or not. I don't know if I would tell you not to do certain things in here. Maybe the bigger question is when you do it. But there's different things. There's section based. So I would say, if you have a weakness, no matter what, that you need to focus more on this, it might not be a bad idea to take that practice exam in that section, so that you can kind of help identify some of the specific things you have to focus on, right? So and then timed mode. Well, that's timed. I think that one's a little more stressful than it needs to be. Maybe just before you go to take the real test, it's a good idea to have some pressure on time, because you will find that AWS exams are very much time sensitive. I teach this stuff at all levels. I have all of the certifications that Amazon offers, and I've recertified. I've taken tons of AWS certification exams now over all the recertification times I've been taking these. And when I take either a professional exam or a specialty exam, I usually only have like 5 minutes left. Time management is a huge part of it. So we really got to make sure you're quick on identifying. Now, some little tips actually on that one. So some additional exam tips. Amazon exams allow you to flag the question for follow-up. And so I'm kind of going on a whim here as we're going through these discussions. So I just got in mind that, the timed aspect of it. So on that note, you can flag for follow-up. Here's the thing. There will be questions that are unscored. You don't know which ones those are. That's number one. Amazon comes out and says, yes, there are a certain number of questions that will not receive a score. And part of the reason for that is that they're always kind of beta testing new questions. And so what if they put a new question into the pool and 100% of the students that take the question, or candidates, I should say, that answer that question get it wrong? If 100% of them get it wrong, it's probably not the candidates, it's probably the question, or poor answers, or some hybrid, or some combination of all. So there's going to be some questions that are not scored. And so number one, knowing that, what if that one question is the one that sucked you in and you took like 15 minutes on that one question and you ran short on time at the end, all because of a question that's not even scored? Poof, right? You don't know if that's the case. You'll never know. They won't tell you what questions you got wrong at the end. So you can only speculate. But I get a feeling I think I've known a couple of questions that I was looking at the question going, I don't think any of these answers are right. It could have just been me, but it may have been one of those unscored questions. And if I sat there and scratched my head and just stared at it and worked on it for the next 10 minutes, it very well could have been one of the unscored questions. So the way I handle these is I try and give myself like a pretty rigid time management rule where I'm like, if I can answer the question in a minute or less, if I feel like I can do it quickly, I'm just going to answer it. But if it's going to take me more than a minute, if I know it'll take me more than a minute, or a minute has now elapsed, flag it, move to the next. Okay. What I like to do, and if you think about this, if you do that and you say 1 minute per question, what is it? I think it's like 65 questions. So that's an hour, but it's a 3-hour test. Okay. So you'll get like round 1 through the exam in that first hour. You'll have gone all the way to the end. Now you'll have a bunch of questions you didn't answer, but you'll have a bunch you did. But that way you kind of know all the questions you're going to see quickly, and then go back and start working on the ones that are going to take you more time, right? And then maybe even do that same strategy over again, but with a little longer objective, right? Okay, if I can't answer it in 2 minutes, flag it and move on, right? That kind of thing. So you keep doing like multiple passes through the exam. Plus, of course, the classic exam strategy. Is it possible that there may be a question later in the exam that gives you the answer to one at the beginning of the exam? It's possible. It is unlikely with Amazon exams, though. The exam teams know about that idea, and they look for that. They really, really pressure on this one. The exam creation teams, a question is not allowed to make it in the pool if that situation exists. So can they still fall through the cracks and sneak in? Sure, but it's unlikely. So don't plan on that. But I would say it is still possible. So you go through the exam in entirety from beginning to end in that first hour. You still have 2 more hours. Go back and start hitting the questions that are going to take you a little longer. But what I also don't want to see happen is if you don't do this strategy and you're like halfway through the exam and you realize, oh no, my time is gone. I've got like 20 minutes left. I got distracted on timing. Didn't realize how far along I was. And I'm not even hardly halfway done. And this will happen to you. This time management stress will occur. I've had it happen to me where I'm just like, oh my gosh, I got to fly now. And you don't want to be in that position. So by going through the whole exam quickly initially, at the very least, you're getting a chance to see all the questions. Even if there's a bunch you flag that you don't answer, you're seeing them. And then you're going to go back and see them again when you circle back around and start answering all the ones you flagged. Okay.
Is this possible to do on the like online one, or I mean, does it matter whether you do it in person or whether you do it like remotely? Like you'll still be able to go back and.
That's correct.
Okay.
Yeah. So it does not matter whether it's online proctored is what they call that, or in-person proctored. It's actually the exact same platform. It's the same software. Whether you do it in person, it's the identical experience in that sense. The only difference is if you do it remotely or you do it online, webcams are all involved. And of course they have you scan the room with your camera and make sure that, there's no stuff out. Your desk has to be completely clean. Like I got quote unquote in trouble by one of the proctors one time. They paused my test. Apparently they were reviewing my video and pictures and stuff from before I started the exam. And they said, "What's that on your desk to your left or whatever?" And it was just a pen just sitting there. And it was like pretty far out of reach. It was a pretty big table I was at. And but they stopped my exam and they got on. They said, "What is that?" And I had to show them it was a pen. They said, "Get rid of it." Had to be well outside of reach. I guess they're afraid in today's world with technology, right? They're afraid of people using communication devices and stuff to cheat, and it happens. People do it. And so if you wear glasses, they're gonna ask you to inspect your glasses on the cameras and all that stuff. But yeah, as far as follow-up goes, that's absolutely an option, regardless whether you're in person or remote. Yeah, great question. And so okay, so on that note, like I said, just recap: time management is really important with these exams, especially these higher level exams like the professional and specialty exams. They're a long exam, like I said, they're like 3 hours, and you pretty much need every minute of it. It's sometimes equally a reading test as it is a technical test. Sometimes there's a lot of text on the screen. You have to read quickly and be able to extract information quickly. So that's where, you don't want to get just hung up on any one question for a super long time. Just try and answer the quick ones first, because, worst comes to worst. Now the different questions can have different weights to them. So it's entirely possible one question is worth more from a weighting perspective, is worth more than another. So there's this algorithm, and so it's not about how many questions you get right versus wrong. That actually isn't really a thing so much. It's more about the overall score, and that score can have different weights based on different questions. So on that note, maybe you don't get a really heavily weighted question correct because it was a really long one, and you waited till the end to do it. You finally do it, and you still don't get your answer well. But what if that one question, by skipping it initially, by flagging it, allowed you to answer 5 other lower value questions quickly? Well, you at least got 5 answered instead of the 1. Even if the 1 was worth 3, you still got 5, right? So I kind of see that as, let's just get all the easy ones out of the way, because you certainly don't want those to go unanswered, and you will not be penalized by answering wrong. In other words, a wrong answer is scored the same as an unanswered question. You absolutely must have every single answer answered. Okay. And so you don't want to get to the end and just be clicking C over and over again just to finish the exam. You want to have given yourself some sort of chance at those, right? Okay. Another great question from Desiree. Partial credit. Unfortunately, no, partial credit is not given. So if you have a pick 2 kind of question, and one of the 2 is correct, one of the 2 is wrong, the whole answer is wrong. Okay. Because of that, they also recognize those questions are worth more. Okay. So it's a good and bad, because it's like 2 questions in one, but it also is kind of like missing 2 questions in one if you get it wrong. So those are stressful questions. Because of that, Amazon has a limit on how many of those they can ask you. I'm wanting to say an entire exam can only have like 5 or 6 of those. I don't remember the exact number, but it's a pretty small number. They don't want a whole bunch of those pick 2, pick 3 kind of scenarios, because really it's kind of unfair, right? You could have gotten 1 or 2 correct, but if you didn't get all 2 or 3 right, then the whole thing is wrong. So they do not give you partial credit though. Okay. But just know that those questions are minimum on the exam. There's not a whole lot of them. All right. So time management is huge. Okay. As far as your practicing goes, though, again, my take on this, I don't know why you would not do some of the tools at your disposal, right? I don't know. There might have been some rationale behind that. I would like to know maybe who would have said that, because I'd love to talk to them further, just to see maybe I'm on a different page there. I don't know. No, it does not, Alexander. It's more like it's an algorithm, okay, and the scale is not even like that. So kind of like how some exams are out there, kind of like SATs and others. There's the minimum is not 0, okay, and the maximum is not 1,000. It's a scale that's a little different than that. The minimum, I think, is like 300 or 400, and the maximum might be 800 or 900. So I forget the exact scale. I'm just kind of throwing those numbers out there. But if you got none right, you wouldn't have a 0. And so they do that. So it's like, just answer your questions and do your best. Okay. Number right, number wrong. It's not going to be something you're going to be able to necessarily figure out. Okay. And percentage of correct versus incorrect isn't necessarily realistic, because again, it's not a number of percentage of the answers you got right or wrong. It's the score you receive. And that score is more algorithm kind of based. Different questions can have different weights and things like that. So here's the thing. What if you get a pool of questions that are easier, and then I go take the exam and I get a harder pool? It just happens to be the questions that were randomly generated for me were harder. Each question kind of has like a weight to it. And so for my exam, I could probably get fewer right and pass than you. Okay. If you got easier questions, you're going to need to get more of them correct to equal the same score. If I have harder questions, I won't need as many correct to get that same score. Okay. So it's not about the number of questions. It's just, just go for the best you can do. Okay. So yeah, that's one. Don't try and focus too much on that. All right. So Tutorials Dojo, like I said, go register for this. Go explore that as much as you can. Coming back to the student portal, don't forget there's this Basecamp collaboration portal here. So again, this is where there's some collaboration going on. You can communicate with Greg and myself here and others. There is also, so here's some announcements as an example, right? So Greg did some announcements. So he put, let's see, practice exams course. Oh, one other thing I didn't mention, actually, and it was also mentioned today in here. Hey, you're very welcome, Joseph. So yeah, glad to have you here. Hopefully you enjoyed the class. So right here, though, I want to point this out real quick. If anybody has to drop, I get it, but make sure you pay attention to this. On Monday, you will receive an email from X Voucher. Okay. Look for this, watch for this. Do not put it in your trash. Look for it. If you don't receive it by the end of the day on Monday, maybe look in your spam. But this will be your test voucher. Okay. It is not sent by WebAge or Amazon. It is sent by X Voucher. Okay. Very important to pay attention to there. All right. And then watch some of these videos. If you recall, one final thing, some of you remember this earlier in the week, we talked about it, but I'm going to recap it. This is really important for you to have this machine learning certification study guide. Okay, this is, whoops, I downloaded it. This is an Excel spreadsheet. Let me just open it up. Oops, wrong screen, opened on the other screen. Okay, so this right here, right? Keep in mind all these digital trainings. These are self-paced trainings you can go through free by Amazon. There's some really good trainings in there. So make sure you go through those. The white papers, like we talked about, you don't need to remember all the little intricate details. Bigger perspective, bigger picture is kind of what it's all about. I mentioned earlier in the week the well-architected framework. Okay, WAF is what it's called. WAF. look for that as well. Make sure you study that a little bit. That is not going to be on the exam itself, but it's standard AWS principles that everything AWS hinges on. So it'd be good for you to kind of review some of that. Don't go crazy with it. Don't spend hours and hours on it, but do spend a little bit of time, okay, and kind of get your feel for approaches that Amazon wants from you, because those will apply to every single AWS certification. You will not be quizzed on this framework outside of the architecture classes or architecture exams. So like if you were to go take the associate cloud, which one is it? The architecture exams. I'm just going to leave it at that. I'm drawing a blank, but there's a professional and associate architect. Those will actually tackle the well-architected framework a little bit more directly, but all of the certifications will leverage the thought process or the approach, the principles addressed in the well-architected framework. Okay. So that's a white paper or web page you can go to. If you just do a quick Google search for it, you'll find it real easily. AWS well-architected framework. All right. So get to studying some of this stuff. Take some practice exams and find your gaps, right? Like I said, deep learning is maybe an area to do a little bit deeper dive into, because we don't really cover that in here, but there is an AWS class for that Amazon would say is also a prerequisite for the exam, or a suggested prerequisite. So since you're not taking that class, you're going to want to know the concepts or the content in that class. So that's going to come from some of this stuff in these digital trainings and white papers and stuff. Okay.
Ryan,
Again,
so the digital trainings, are these the same? It's going to be like kind of the same setup that we've done now, like through SageMaker. Is this something where it'll be included, or do we have to make like an Amazon account and kind of pay for whatever training time that we're using and all that?
Good question. Most of these, I don't believe, are going to have much in the way of hands-on.
Okay.
Most of them are going to be more information transfer, knowledge transfer. If there is any hands-on exercises, they will be in your own accounts. So you'll need an account for that. You won't have like quick labs, paid quick labs and all that kind of stuff for it. They may have suggested quick labs you go take though, which would be public. So that would be just that place where you got, Booz gives you credits and you could go log into just your regular quick labs login, not the one for the class, but the regular one. And you'll have credits in there. You can go find classes or labs in there. And there may be some suggested labs at times, or they might say, hey, go take this quick labs lab to reinforce this discussion topic. And so if they do mention that, then that's what they're talking about. Otherwise, you might do this stuff in your own accounts. One final thing, and then I'm going to wrap up for the day. We're about out of time anyway, so I thought we'd get out early, but we're talking exam stuff. So, but one final thing, the labs. I want to explain real quick how you do these labs in your own accounts. Okay. So we have these AWS labs, right? And I open this up. Did I just, oops. Okay. Let me just see what make sure I didn't do anything I was supposed to. Okay. All right. So, so I've got this lab here. Let me open it up here real quick. All right. And SageMaker. Now, what do we need to do this in our own account? So I'm in lab 4 right now. Okay, I'm in lab 4. Keep in mind what the different labs are. All right. The only difference between lab 2 and lab 4 is lab 4 contains everything labs 2 and 3 had plus lab 4. So really lab 4 is the only one you really need. Come into lab 4 here and you go into your notebook instances. All you need to do these labs in your own accounts is the notebook instances, inside this notebook instance, there are those notebooks themselves. That's what you need. You need the notebooks. So it'd be good if you created this notebook instance in your own account. Now, how do you create that? There's 2 ways. You could manually go create a notebook instance, right? And build it out, but you need the script that launches with this. Where is that script, if you remember? Lifecycle configurations. So come over here in lab 4, come over here to the lifecycle configurations, and you'll see the lifecycle configuration right here. Now I can view the script. I could copy this whole script, control, copy and paste it into some notebook, right? And save it off for myself at that point, right? And then I could go build in my own account, build my own notebook instance using, well, first I would build the lifecycle configuration using this script, and then go build an instance. And when I build the instance, I'm going to select the script. So I'm going to go right here, create notebook instance. And when I do that, you're going to come down here under additional configuration, and you're going to select the lifecycle configuration that you created here with that script. Now, when this notebook instance is created, it will contain all of the stuff from Lab 4's notebooks, right? One other little trick though, if you don't want to do it that way, there's even an even slightly more advanced way to do this. And this is where it's outside of the scope of this class. But if any of you are familiar with CloudFormation, just go search for this, CloudFormation, if I can spell it right. Go into CloudFormation. All of the labs that you'll ever do in Quick Labs are templatized. All you need is the template for the Quick Labs, okay? And that is in here under CloudFormation. So you come in here, this is for Lab 4, right? And I can come in here and I could say template. And there's two ways that I can just download this template. One would be, whoops, not that, but grab it up here, copy and paste the whole thing, okay? Control C, put it in, or Command C or whatever, put it in a notebook, save it off as a file, go into your own account, open up CloudFormation, create stack, use that as your template, and the whole environment will build, okay, including the notebook instance. In fact, if we look at the notebook instance creation, look what it does. Here's the notebook instance right here. It creates the lifecycle configuration actually right here, okay? And this lifecycle configuration includes the script. And it even includes the role, which is our security, right? Our security needs. And then there's going to be an actual notebook instance. When we create this instance, it's specifying the instance lifecycle that we created above. So this template is really doing all that work for us, okay? If you want to, instead of copying and pasting it, if you want, you can also go view in Designer. But I'm kind of going quickly here. But if any of you get lost on this and you want a little bit of help, just reach out to me and I can help you a little bit. So you go into Designer here, in upper left-hand corner, I can just say save. And now I can save it as a local file or save it in my S3 bucket, and that will save the template for me. And then all I do is I go into my own account, go to CloudFormation, and I would basically say launch stack, and it would ask me for that template, and I build that template. So I would come in here to stacks, I would say create stack with due resources, and I would specify the location of that template. And then that will build my notebook. And then the only other thing that's been lacking at that point is if you want to use the notebook that you've already created and saved for yourself, you could, of course, upload that at any time, right? But once you build that notebook instance, whether it's in your own account or in here, so if I go back to SageMaker, once you do this in your own account, all you need is the notebooks. That's it. That's all you need. And permissions in your own account. So just don't forget to delete things. Let me tell you what you're going to need to delete to make sure you don't get surprise bills. Okay. So real quick note, though, I just want to point out notebooks. You go to your notebook instance. If we open this just like you've been doing, all your notebooks are going to be in there. All the stuff from even previous labs. So you'll notice in here, there's lab 1 even in your notebooks. The Python cheat sheet is in there. Lab 1 is in there. All your solutions, all your projects are in there. You got everything you need to do any of the other projects. So you could just come into projects and pick a different project, and the whole project file is there from beginning to end. Okay. So you've got everything you need. Okay. One thing I want to point out though, as far as risk, making sure you don't get surprise bills or something in your own accounts. Two things I usually do. If it's your own personal account and you actually have to pay the bill for it, go to billing. I don't have access in this lab environment for this, but I would actually go over here to billing dashboard, go to billing, and set up what we call a budget for yourself. In that budget, there's budget alerts. And those alerts, I could say, alert me if my bill is going to be over $2 a month or something like that. Okay. So it will notify you, and you can set up how it notifies you. It could be text message, email, automation, notifications, however you want to set that up. Plenty of flexibility there, but set up that notification first and foremost. And that way you can make sure you don't have any surprises. And that's kind of protection level number one. Number two, just know the things that are billing you. So a notebook instance, while it's running, is a ticking charge. Okay. This notebook instance exists right now and is running right now, whether I'm using it or not. So build your notebook instance, do some work in it. When you're done working for the day, if you're just exploring and experimenting, when you're done working for the day, make sure you delete this notebook instance. Okay. Stop it at the very least, I should say. If you just stop it, that's good enough. If it's not running, it won't be billing you. Okay. Technically, the storage for it will still bill you because you're still consuming storage, but that storage for this notebook instance should be really, really small. I think it's like 1 gig or something. You shouldn't even really notice that on your bill. It should be like less than a penny. Okay. So the main thing here is just shut that notebook instance down when you're not using it, or even feel free to delete it and then recreate it whenever you want to get back to work again. Okay. Then the only other thing is if you do any inference endpoints. Okay. Inference endpoints, like I mentioned, are running all the time until you tear them down. So if you do any inference endpoints, just make sure you delete them when you're done. Okay. Batch, you don't have to worry about it because that's only running when you tell it to run. Training only runs when you tell it to run, and then it runs and it goes away, and you just pay for the training time. So you don't have to worry about those things being an ongoing bill. You have to worry about the inference endpoint being an ongoing bill and your notebook being an ongoing bill. Those are really the two key things. Okay. As long as you manage those, you'll be safe and fine. Make sure you set up an alert for yourself just in case if you forget to turn off something. And then, you go into the weekend or something and you forgot to turn it off, you'll get a notification and you go, oh, I got to go fix that real quick. Go fix it. You're good to go. Right. So you can be very, very safe in here and not get any surprises. All right. But knowing that, you can go on your own AWS accounts now. You can do these things as long as you want, as much as you want. Keep in mind, Quick Labs are available for the next 3 months. So you can go into Quick Labs and exhaust those executions. You can do 3 per each lab over the next 3 months. But once you've done it 3 times for each lab is tracked separately. So if you've launched a single lab 3 times, then that lab is gone and done for. And then you would go to the next lab, do that one. You can do it 3 times, the next one 3 times, and so on. But once you've done all of them 3 times, then it's basically the environment's no longer worthwhile to you because you won't be able to do anything in there, even if they're still available for another, month or something. Okay. All right. That's all I got. Okay. I hope you enjoyed the class. Okay. So are these labs available on the general Quick Labs for credit? They are not. Genevieve has a great question there. They are not available. The labs in a class in AWS are what we call private labs. Oh yeah, I'll give you that link for the Anna as well for you to take the post assessment. Yeah, and that's just for you, but I would recommend you take that as well. You don't need to, if you don't want to do it today because of timing, we're kind of late along on that front. But yeah, thank you for reminding me. Thank you. Let me pull that up here real quick. Post assessment link. So this will kind of give you a chance to kind of quiz yourself as well, separate from Tutorials Dojo, right? So go take that post assessment, see how you do. Hopefully you took some information in. Hopefully you score better today or when you take this than you did on Monday. Are you going to be perfect at it? Maybe not. But if you're not, then just identify the things you're weaker at and go study those things. Okay. We covered a lot of content in 4 days. I don't expect you to retain 100% of it. Everybody knows when you're learning stuff, you will never have 100% retention. It just won't happen. Okay. So we've covered a lot. So even if it's something we covered, you may not have retained it. That's why also you've got the recordings. Don't forget about that. Okay, so go utilize those recordings as well. You can go back and rewatch the sections that maybe you were fading off into the distance, mentally. Maybe you had to join us late or something. Who knows? But go check out those recordings. Take that post assessment. Yeah, much help there. The quick labs, like I said, though, are just for the class itself. So general quick labs, the public quick labs, none of the quick labs that are part of an official AWS course are in there. Those are unique to the class and are part of the class value. Okay. So they're separate. You can't do them for credits. Okay. All right. That's all I got. If you have any further questions, okay. If you have any further questions, shoot me an email or reach out to me on Basecamp. Okay. I really hope you enjoyed it. I think I'm supposed to have an evaluation for you, but I haven't seen that. So I may send that out through Basecamp. Keep an eye out on the Basecamp environment because I won't send it to your email. I don't have your emails actually. That's something WebAge has, but I don't as the trainer. But I'll reach out to you on Basecamp there, and I'll send the evals out if you can get those taken care of. I think we're supposed to have one, but I haven't seen it. So I'll follow up with that. Just keep an eye out. And if you do see that come out, please fill it out and evaluate, how we did this week. Okay. All right. I appreciate your time this week. I hope you got something out of it. Thank you so much for giving me the opportunity and the honor to train you. I always get a lot of, I really like training people up. It's just something I naturally have done my entire career. Anything I know that I can share with others. I've got people on the flip side of that are my mentors. And so I kind of just pass it on through. I just get a lot of value myself out of passing that knowledge on. So hopefully you're able to learn something from me and from the materials. Like I said, this isn't it. You have a lot more studying to do. Resources are out there. Basecamp's a great way to communicate with me, but you can also shoot me an email. All right. You can also reach out to Greg through Basecamp as well. And I think Greg shared his email with you all as well. All right. Well, it's a pleasure. Enjoy the coming week. The incoming weekend coming up. Hey, you're very welcome. And again, if you need to reach out for anything, just reach out. I think one or two of you were still working on your projects, so feel free to get back to those. Okay. What I'm going to do, in case you're still working on that project, I'm going to add some time to it because I know that they're set for like an 8-hour window. But if some of you want to do it later this evening or something, I can extend those a little bit. There's only so much I can do there. So I'm just going to go ahead and just automatically, looks like most of you that are still running your labs have like 2 or 2.5 hours left. I'm just going to arbitrarily add a few hours to that. It's funny, they make me add it 10-minute increments. So I can't add like days to it or anything like that. They won't let me actually, it doesn't go that far. But I can add a few hours to it. So I'm just going to automatically do that just so that doesn't just kill itself off in 2 hours. That way you can go through the evening if you want to do that. Okay. So if you're still working, go ahead and work on that. Again, feel free to reach out to me if you have any questions or issues with it. Even after I shut things down, you can reach out and we'll give you a hand. Okay. Everybody have a wonderful coming weekend. Hopefully you got something. I'll be around for you if you need to email me. Otherwise, I'm going to shut the classroom down, but you can communicate with me through those other mechanisms. Okay. Everybody have a good one. Take care. Cheers.
Ryan?
Yeah.
How long is the student portal available for?
Oh, the student portal. That should be available, gosh, I think probably for months. That is the WebAge student portal. I don't want to give you an exact time. I'm not sure. Greg would be a better one to answer that, but I know it's not going away immediately. It's going to be around for a long time. It's there for your reference through this whole process. So long past you expecting to be certified and all that. So they're going to give you those resources for quite some time. Yeah.
Awesome. Thanks.
Absolutely. Yeah, you're very welcome. Hey, you're all very welcome. Absolutely. Take care.